Good morning, everyone. Thank you, everyone who was involved in the welcoming ceremony and for the invitation this morning. Hearing an echo. Okay, let's try this. So good morning. We will now start our final agenda item for this meeting, C2. We have several staff presentations under this agenda item, and we anticipate there will be quite a lot of public testimony. We're scheduled to take the SSC report on C2 time certain today after lunch. The AP is still taking public testimony, and we're going to have to kind of track to see how they progress today. However, it may be the case that we have to move on to public testimony before we receive the AP report. I will keep the public noticed as far as when we will be closing public testimony sign up. I don't think we can hold it. We may not be able to hold it until we get the AP report, just due to the time management during this meeting. So it may be the end of today or early tomorrow that we'll have to close up sign up, but we'll see how the staff presentations progress today, and I'll try to announce that shortly after lunch. So with that, we'll hand it over to our staff to introduce C2. Thank you.
Good morning, Madam Chair, members of the council. Kate Hoppola with council staff, and with me today is Ms. Sarah Marinin, also with council staff. We're going to introduce the C2 agenda item and then get started on the presentation for the impact analysis. So this slide provides for you an overview of the C2 agenda item in terms of the order. There's several different components to this agenda item, and it's intended to serve as a reference point for the council. So Ms. Sarah Marinin and I will provide the presentation on the preliminary draft environmental impact statement, or the preliminary DEIS. This document contains the impact analysis for all proposed alternatives. The council last reviewed this issue as well as the impact analysis in April 2024. Just a reminder that the National Marine Fisheries Service, or NMFS, is the lead federal agency, and there are 3 different cooperating agencies who have provided special expertise to this analysis: the Alaska Department of Fish and Game, the Kuskokwim River Intertribal Fish Commission, as well as the Tanana Chiefs Conference. There are several staff from NMFS, ADF&G, the Kuskokwim River Intertribal Fish Commission, and TCC who are available to help answer questions on specific sections or portions of the analysis to which they contributed special expertise. And I would just note that those staff are listed for you on the action memo in terms of who they are and their affiliations. Following the presentation on the impact analysis, the council will receive several additional reports that provide context and supplementary information for the analysis, which will help inform the council's decision-making. So there's the NMFS Tribal Engagement and Consultation Report, presentations from the Kuskokwim River Intertribal Fish Commission, as well as TCC on their appendices, which were contributions made through their role as cooperating agencies, as well as the 2024 Bering Sea Chum Salmon Genetics Report. And that'll be provided to you by Dr. Pat Berry, who's available remotely as well. Just a reminder that the council is considering new management alternatives to minimize chum salmon bycatch in the Bering Sea pollock fishery to the extent practicable, consistent with Magnuson-Stevens Act, its national standards, and all other applicable law. There's a particular focus on reducing Western Alaska chum salmon bycatch, and the proposed action is being considered in light of the recent and ongoing declines in Western Alaska chum salmon abundance and the critical importance of chum salmon to Western and interior Alaska communities and ecosystems. The council's full purpose and needs statement is available in section 1.1 of the analysis. The proposed regulatory changes would apply to the pollock fishery because it encounters over 98% of all chum salmon that have been caught as bycatch in the BSAI region. This is seen or can be seen here in table 3.8 from the analysis. And the fishery is composed of 4 different sectors: the offshore catcher processors, inshore catcher vessels, motherships, and CDQ. And the patterns of bycatch vary by sector. They have different avoidance strategies that they can use, and we'll certainly cover that more as we move through the presentation. However, not all chum salmon that are caught as bycatch in the pollock fishery originate from Western Alaska river systems. The chum salmon that are caught as bycatch originate from countries all across the North Pacific Rim. There's 6 different genetic reporting groups that are used to determine where these chum salmon that are caught in the fishery as bycatch originate from. And within these reporting groups, there's several different subpopulations. So on the right-hand side of your slide are the 6 reporting groups and the baseline for the baseline chum salmon populations that are used in genetic analyses that come forward to the council each year. And these are the Southeast Asia, Northeast Asia, coastal Western Alaska, upper middle Yukon, Southwest Alaska, and eastern Gulf of Alaska, Pacific Northwest. The text on the left is intentionally color-coded to match the population and reporting groups on the right. When we're talking about Western Alaska chum salmon and the analysis and presentation, we're referring to coastal Western Alaska and the upper middle Yukon reporting groups as the combined stock reporting group. And you can see that on the plate C, which is the yellow and blue population dots. The estimated proportion that Western Alaska chum salmon represent in the total bycatch varies each year, averaging 18.6% of the total bycatch since 2011. This slide simply provides a snapshot of the 2023 bee season. This is the most recent year for which complete genetic data were available at the time this document was published in December. The 2024 genetics report will be provided at the end of the agenda item. In 2023, 111,843 chum salmon were caught as bycatch in the pollock fishery, of which 10.6% were estimated to be of Western Alaska origin. This slide provides for you a summary of the different actions that the council can consider or may be considering at this meeting. So here in February, the council may determine whether it would like to modify the current range of alternatives. If the council does decide that it would like to modify the alternatives, it may request additional review of the impact analysis, and this would need to be accommodated at an additional future meeting. The council is not required to request additional review, and it may also choose to recommend the analysis be revised and released for publication by NMFS as the draft EIS. The subsequent action timeline will depend on whether the council feels it's necessary to receive an additional review of a revised impact analysis. And there's 2 timelines that are available for you for consideration within the action memo, and I'll walk through those timelines at the end of the presentation.
Oh, Dr. Hapala, a question. Ms. Kimball.
Thank you, Madam Chair. Thank you, Dr. Hapala. Just to be clear that the council does have the option to modify either alternatives or options within the analysis. And depending on the scope of those changes, we could still bring that back, see that analysis, and take final action at the next meeting.
Thank you through the chair, Ms. Kimball, for the question. Yes, that's correct.
Thank you.
This is just a outline for the remainder of the presentation. So from here, Ms. Marinan and I will walk through the alternatives, the environmental assessment, then the social economic assessment. We'll talk about the combined effects of the alternatives as well as management, monitoring, and enforcement. And then we'll wrap up with some final points for consideration, including the timelines just mentioned. And then we'll introduce some of the additional presentations that follow our presentation on the impact analysis. So moving on to Chapter 2. Chapter 2 of the analysis provides a detailed description of each of the proposed alternatives. The council is required by law to consider a no-action alternative, and the no-action alternative would retain the existing chum salmon bycatch regulations in the Bering Sea pollock fishery. The council is at this time also considering 4 action alternatives, which are different ways to modify the existing bycatch regulations. They're focused on different caps that would close all or part of the Bering Sea if met, as well as modifications to the salmon bycatch incentive plan agreements. The proposed regulatory changes would only be in effect during the B season pollock fishery, which has regulatory dates of June 10th to November 1st. And then I'll walk through each alternative with more detail. So as mentioned before, alternative 1 retains the existing regulations for chum salmon bycatch management, and there's 2 primary components. One is the rolling hotspot system, and the other is the chum salmon savings area. The rolling hotspot program identifies discrete areas on the pollock fishing grounds where chum salmon encounters are high, and those areas are closed for a period of time to pollock fishing, and vessels are required to move elsewhere. The location and the timing of these hotspot closures vary each year because their implementation is based on near real-time in-season data and encounters. And figure 3.9 in the document shows the hotspot closures implemented for chum salmon avoidance from 2017 to 2023. And the second component to the existing regulations is the chum salmon savings area. This is a time area closure triggered by a PSC limit of 42,000 non-Chinook salmon or chum salmon. The chum salmon savings area really continues to just exist in regulations as a backstop measure should vessels choose not to participate in the rolling hotspot program, which is managed under the incentive plan agreements or the IPAs. And this scenario has not occurred since 2010 when the IPAs were first implemented. Alternative 2 includes an overall chum salmon PSC limit or a hard cap that would be in place during each B season. The range of cap amounts that are currently being considered is 100,000 to 550,000 chum salmon. The council is not required to pick a specific number within the specified cap range. I'm sorry if I misspoke there. The council is not required to pick one of the specified cap amounts, but it can pick any value within that range. If the hard cap is met by a sector or a fleet, fishing must immediately stop during the B season. And there are 4 different options being considered to apportion the hard cap, and I'll talk about that on the next slide. So the 4 different options for apportioning or dividing the hard cap among the pollock sectors are displayed for you here. They're based on a 3-year average, a 5-year average, a pro rata split, or AFA pollock allocation for each sector. And the bycatch related ones, so the 3-year average, the 5-year average, as well as pro rata, are based on history from 2011 to 2022. Table 2-2 from the document is shown here, which includes the percentage of a hard cap that each sector would receive based upon the option being considered. And additional information is available in Chapter 6 and Appendix 2 in terms of the transferability provisions.
Dr. Hoppola, question. Ms. Baker.
Thank you, Madam Chair. Thank you, Dr. Hoppola. And I'm sorry, can we go back to the previous slide, slide 12? I just want to, since we're kicking off the presentation, just to be really clear, the very last line there, appreciate you pointing out sort of the potential interplay of the alternatives. And in terms of alternative 2 or 3 can be selected with alternative and or 5. I want to get the alternatives 4 and 5 could also be selected. They're not mutually exclusive. So I just really want to make that clear and get it on the record.
Thank you, Ms. Baker, for the question. Through the chair, that's correct. Alternatives 2 and 3 are mutually exclusive to one another, meaning only alternative 2 or 3 could be selected. Either may be selected in combination with alternatives 4 and 5.
Thank you. Ms. Kimball.
Thank you. On that same slide, Dr. Hoppola, if the hard cap is met by a sector or fleet, fishing must stop, and that is certainly true in practice. However, if the co-ops apportion the limits to individual vessels would stop fishing when they met their limit, and that could be well before the sector meets their whole limit. Is that not the case?
Through the chair, thank you, Ms. Kimball, for the question. Yes, that's the case. The sector's amount of the hard cap would be further apportioned for the inshore sector among the inshore cooperatives, and then the CDQ program further across the CDQ groups. And so how they apportion for the inshore cooperatives or the CP and mothership cooperative down to the vessel level is something they would handle internally. But yes, the cooperatives could issue a stand down and manage by prohibition.
And thank you, Mr. Twite.
Thanks, Madam Chair. Ms. Hoppala, you used the word could there in that last sentence. And I thought that was appropriate because it strikes me that they might not, that depending on the size of the hard cap, co-ops might simply be unable, if it's small enough, might be unable to find a fair way to apportion. And so they might have to simply operate under either at least a co-op, if not a sector-wide hard cap, whereas at a higher hard cap, it's much more likely that the co-ops would use the tool that seems to have worked in Chinook of apportioning to the individual vessels. Is that right? That there's very much a dynamic in that between the size of the hard cap and the likeliness that the co-ops might adopt that strategy?
Thank you through the chair, Mr. Twite, for the question. I think that general logic is correct, but we don't have in the document a specific cap amount or threshold where that would be a break point in terms of how the cooperatives would deal with that at the vessel level. But Ms. Marinan might have something to add.
Good morning, Madam Chair, members of the council. For the record, Sarah Marinan, council staff. I would agree with what Kate said. I would also add that we do talk about some of the operational dynamics that could play out. Within the document, we discuss this. There's been some testimony highlighting the potential for a race for fish. And in theory, that could happen at the cooperative level. We generally expect that there could be, that the cooperatives would operate in the same way that they have with the Chinook limit in apportioning it out to the vessel. But there are some considerations like what the cap amount could be and what vessels could do and how the cooperatives might consider that amount of chum PSC apportioned to the group that would factor into that dynamic. So the paper does discuss in theory, the possibility of a race for a fish. Generally, we would expect that the cooperatives or the IPAs would institute some type of system to manage that PSC among their vessels, likely a vessel level apportionment.
Yes, and Mr. Twite.
Thanks. I just wanted to tug on that just a little bit further. We do get a sense, though, that, say, at the 100,000 level, how small those apportionments might be at the individual vessel level. And that's informative enough to give us a sense of that might be extremely difficult to manage and might actually trigger that race for fish. Whereas, we don't know the midpoint, as Dr. Hoppala pointed out, but we do know that at 550, how that might be apportioned to individual vessels would provide a lot more options that would allow the co-ops to probably structure to avoid a race. So we don't know the inflection point, how broad it is, or if it's even sort of a breaking point, but we can at least make inferences from the extremes, right?
Through the chair, Mr. Twite, I think that's correct. We don't try to identify what specific amount that would be. I think we just highlight that if you have a PSC limit that is on the low end and broken up by sector and cooperative, and then if they choose by vessel, that gets to a level where an individual vessel, before they even start fishing, doesn't feel like they could go fishing with that amount. Fundamentally, it might be a different system than the Chinook PSC limit, and so there might be different choices that are made there.
Okay.
Sorry, back on slide 13. Appreciate that. Just, I had a question, Dr. Hoppala. I believe that the council may have given staff direction to blend the CDQ and CP rates. Just wanted to make sure that the numbers here reflected that. Maybe if you could walk through just very briefly the math behind that and remind us of the rationale. Thank you.
Sure. Thank you, Madam Chair, for the question. Yes, for this table, where the apportionments are reflecting what's used in alternatives 2 and 3, they are based on a blended bycatch rate. And so for the CDQ and the CP sector, That's looking at the number of chum salmon for CDQ and CPs from 2011 to 2022, as well as the B season pollock harvest for each of those sectors in the same time period. We're basically creating a combined pool of chum salmon PSC and pollock catch for those two sectors. And then the blended rate is multiplied by the landings for each sector to get that adjusted rate. And the rationale for that, which was provided in October of 2023, was due to the operational choices that can be made at the vessel level when the vessel is fishing for CDQ pollock on how different hauls are assigned. So that is reflected here. Alternative 3 also includes a hard cap for chum salmon PSC during the B season pollock fishery with abundance indices. So alternative 3 differs from alternative 2 because a hard cap would only be in effect if certain areas had returns that fell below the indices thresholds. There are two different options being considered for abundance indices, and they're mutually exclusive to one another. So just as alternative 2 and 3 are mutually exclusive, where only one could be selected for implementation, that's the case for the two different options of area indices as well. The 3 area index is under option 1, and the Yukon area index is included under option 2. And I'm going to walk through each of those in the coming slides here. So this slide summarizes the 3 area index, including the current data sources being used in the middle column of this table. The 3 area index reflects the Yukon, Kuskokwim, and Norton Sound regions. On the right-hand side of the table are the current thresholds for each area. There's 2 values in place because this is still an outstanding decision point for the council, which is to pick one that would apply in regulation. The lower number represents the 25th percentile of historical abundance based on data available from 1992 to 2022, and the higher number represents the 50th percentile for historical abundance based on the same years. The Yukon thresholds are based upon run reconstructions for the summer and fall chum salmon runs. The Kuskokwim area threshold is based upon the cumulative CPUE from the Bethel test fishery, and the Norton Sound thresholds are based upon a standardized index of escapement for the Snake, Nome, El Dorado, Quinnipiac, and North Rivers, as well as total harvest within the region. There are step-down provisions included within the alternative 3 option 1. So using the 3 area index, if all 3 areas have returns above thresholds, a hard cap would not be in place in the next B season. If only 2 areas or 2 of 3 have returns above their thresholds, a hard cap would be in place in the following B season, so there's a 1-year lag. A hard cap amount would be set between 100,000 and 550,000 chum salmon. If only 1 or 0 areas have returns above thresholds, a hard cap would be in place in the next B season, and that hard cap amount would be set at 75% of the amount selected when 2 or 3 areas have returns above their thresholds. Option 2 of alternative 3 includes the Yukon area index. And again, based upon the Yukon summer and fall chum salmon run reconstructions, if both stocks are above their thresholds in a given year, no overall hard cap would be in effect the following year. If 1 or 0 are above their thresholds, a hard cap would be in place set at 100,000 to 550,000 chum salmon. In between the prior April meeting and this February meeting, a new issue arose, which is that future funding to operate the Bethel test fishery is uncertain beginning in 2025. So the purpose of highlighting this is to bring forward options to replace that data source should the council wish to move forward with option 1 of alternative 3. The test fishery was originally chosen for the Kuskokwim area because it was a reliable index of abundance for the river system. It has an extended time series and was unaffected by weather patterns and changes within the river. But listed below are a set of identified alternative options from ADF&G, as well as with input from the Kuskokwim River Intertribal Fish Commission. There's more information on each of these sources available for you in Appendix 2. And I would also note that Appendix 7 provided by the Fish Commission provides additional information on the Kuskokwim sonar as well. Selecting a new data source is a decision point for the council at this time. If the council were to replace the test fishery, it would also need to identify the thresholds for use because there would be subsequent analytical implications for determining the years in which a hard cap would have been in effect. This slide simply provides a reference point for you. It's a summary of the different advantages and disadvantages for each of the alternative data sources identified in Appendix 2. We simply pulled it up here into the presentation for ease of reference, so the content would be available for you in one place. In general, the advantages and disadvantages center on the length of the time series of the data that's available, a sense of future funding certainty, as well as data availability and reliability. If the council has additional or specific questions at this point in time, I believe we have staff from ADF&G as well as the Fish Commission available to help answer those. We can certainly circle back later on too.
Yes, Ms. Kimball.
Thank you, Madam Chair. And I can wait, but if it's appropriate, I just wanted to understand how we gauged a sense of reliable funding. Maybe was that just looking at reliable funding retrospectively, or were we thinking that's a sense going forward?
Through the chair, thank you, Ms. Kimball, for the question. It's my understanding, I think it's both. I think it's both a past look as well as a sense of what might be available in the future. So if I'm not mistaken, I believe that some of the other weir projects, so the Queetlock, George, and Takatna River weirs are funded by competitive grants. And so that's not the same as a commitment from Fish and Wildlife or ADF&G year over year. But I'm happy to be corrected if needed.
Yes, Mr. Blahovedy.
This is focusing on alternatives for the Kuskokwim, but couldn't this also be an issue on any of the other systems like Norton Sound on Yukon? If there's a lack of funding or if weather has an impact to the assessment projects that are going on there, then is there a plan B for those areas as well?
Thank you through the chair for the question. So I think when we had originally worked with ADF&G to develop these recommendations prior to the October 2023 meeting, a consideration was given to the run reconstructions for the Yukon area and that there are treaty obligations. So the future funding and availability of those data sources was assumed to be pretty sure. And then at that point, and as well as at this meeting, there's certainly no indication that the escapement projects for the Norton Sound region would have an issue. But sure, there are always future uncertainties that are associated with these kinds of data sources for an index.
Thank you.
Alternative 4 would modify the existing regulations for the incentive plan agreements or the IPAs. The salmon bycatch incentive plan agreements were implemented alongside the Chinook salmon hard caps, which took effect in 2010. In April, the council modified the alternative by formalizing the 6 different provisions that would be added to the regulations, and they're shown as a reference point for you on the right-hand side of the slide. The provisions are based upon the proposals that were received from IPA representatives prior to the April 2024 council meeting. Should these provisions be set in federal regulation, the substance of what the IPAs would be designing their measures to respond to. I would just note that the CPIPA was amended in 2022 and the inshore and mothership salmon savings incentive programs were recently amended prior to the 2024 B season. And most IPAs have implemented measures that respond to these provisions at this time. And just circling back to the final point there, alternative 4 may be selected in combination with alternatives 2 or 3 as well as 5. Alternative 5 includes 3 different in-season corridors or time area closures that are triggered by a PSC limit. The corridors are shown at the bottom part of the slide here with gray shading, and the catcher vessel operational area or the CVOA is shown in purple. And the importance of the CVOA relative to this action is that catcher processors are prohibited from fishing AFA pollock inside the CVOA during the B season. These corridors would only be in place during the bee season fishery, and they're triggered by specific cap amounts that are currently specified for each one. And those cap amounts, the range is set in orange text in the top right corner. They range from 50,000 to 200,000 chum salmon. Only those chum salmon caught between June 10th and August 31st would count towards the cap. If the cap is met at any point during that window, NIMS would close the area until September 1st, but fishing may continue outside of the corridor during that time. From September 1st onwards through the remainder of the bee season, vessels may return to fishing inside the corridor if they so choose.
Oh, excuse me, sorry. Ms. Goen.
Thank you, and thank you for the presentation. Dr. Hapla, this is actually back on alternative 4. My question, am I understanding this correctly, that this is similar to status quo in effect, that the fleet is already doing these measures in their IPA, but this would be putting it into regulation?
Thank you, Ms. Goen, for the question through the chair. We did struggle with how to handle this in the impact analysis because yes, there are elements of this alternative that are similar to status quo in the sense that most of these provisions have measures that are currently designed to meet them in each of the 3 IPAs. But we point out in the analysis that without codifying these provisions within regulation, because these IPAs were voluntarily amended to meet them, that could always change in the future. So this is really about ensuring that less stringent chum salmon avoidance measures couldn't be used in the future. And this slide just provides for you the in-season corridor apportionments. And the purpose of bringing this forward for you is that the alternative 5 apportionment options are the same as alternatives 2 and 3 in terms of the 3-year average, 5-year average using a pro rata split and AFA pollock allocations. However, the apportionments are based on each sector's historical PSC inside the corridor during the closure window, and so the percentages are not the same as alternatives 2 and 3. And we just wanted to be clear on that for you. Okay, the next portion of our presentation is going to move into the environmental assessment, which is chapter 3 of the impact analysis. This slide provides you with the list of different resource categories that were analyzed within the environmental assessment. Today's presentation is going to have a more limited scope and focus on the potential impacts to chum salmon, Western Alaska chum salmon, as well as Chinook and herring. We're focused on these categories because the alternatives would change the existing chum salmon bycatch regulations. And one of the assumptions of the analysis is that the fleet will change their behavior in response to these new regulations. But they are currently constrained by PSC limits for Chinook and herring as well. So we wanted to understand and better convey the interactions between these components. And there's extensive analysis on these other categories within the document as well.
So in consideration of the impacts of the proposed actions across the resource categories, there's a few consistent types of methods that we use throughout. So for the alternatives with PSC limits, that's alternative 2 and 3 and the time area closures in alternative 5, we included the use of retrospective analysis that considered catch and bycatch data. We looked at data from 2011 to 2023. And we used the weekend date in which the sector could have hit those caps, looking at the different PSC limits and apportionments. So this is consistent methodology with what we did in the April analysis. It's also similar methodology that's been used in other PSC actions that the council has seen in the past. What is different, and I think better characterized in this iteration of the document, is how far you can go with those numbers and what qualitative descriptions and assumptions are paired with them. So we've talked a lot about this with the SSC. Some of these values are described as upper bounds or lower bounds in the analysis, and some are not upper bounds or lower bounds. This is inherently an evaluation. These retrospective numbers are inherently an evaluation of meeting the cap and the impacts at the point which a cap is met. However, it is likely that there will be changes to fishing if there's a risk and consequence of a closure, and these changes and impacts could occur prior to and regardless of whether a limit is met. So these behavioral changes are primarily mapped out throughout the document qualitatively. And this is a summary of a figure 1.5 from page 16 of the executive summary that summarizes some of the analysts' expectations around the incentives that are generated by the different alternatives and how they may drive behavioral changes. So these changes could occur prior to closures, and they could also influence the outcome of impacts across resource categories and human dimensions that are considered in the analysis. So we're presenting it here at the beginning because we're going to walk through different resource components and human dimensions that could be impacted throughout the analysis, and this could apply throughout. So for instance, under alternative 1, there are currently regulatory and non-regulatory incentives. And this is, as we just discussed, many of the new provisions that were adopted within the IPAs have incentives that have generated the fleet to behave differently. So there's a series of incentives that are happening even under no action. Under the additional adoption of chum salmon PSC limits and regulations, so under alternative 2 and 3, there's additional incentives being layered on. Harvesters would be incentivized to avoid all chum salmon to prevent a fishery closure or having to take more severe measures like fleet consolidation or other options. And that there's going to be an assessment of risk and likelihood of meeting those limits, and that is going to dictate the strength of the incentive. So if it's towards the end of the season or a relatively high limit relative to what the vessel has fished in the past, alternative 2 and 3 might provide limited incentives on their own to fish differently. If there's a medium or high risk of a limit being met, and again, this could be considered at the vessel or the company level, there could be a strong incentive to avoid all chum salmon. And those factors will be considered in a complex in-season decision environment. Under alternative 4, the new IPA measures. So a lot of those incentives are currently, a lot of those provisions have currently been adopted. So those incentives are currently functioning. So alternative 4 would be similar in that way. But as Kate mentioned, some of those components are new and all would be codified in regulations. So they couldn't be rolled back. Under alternative 5, the corridor caps. So in addition to status quo incentives, if the area is important to operations, harvesters wouldn't want to risk being closed out of those areas. So the strength of the incentive depends on their assessment of the likelihood and consequences of hitting the cap. And we're going to talk about alternative 5 in a lot more depth, but those consequences vary by sector. So that alternative might not necessarily incentivize Western Alaska chum salmon avoidance specifically, but it could provide it if that area closure has higher rates of Western Alaska chum salmon.
Sweet. Looks like we have a couple questions, Mr. Twite.
Thanks. When I went through this first, I really wondered about the characterization of high risk, but because it seemed to me certainly that could be one possible outcome of a high risk situation. But equally, it seemed to me that under high risk, there could be a strong incentive to essentially race to the cap to catch pollock regardless of chum impacts. And that is, I admit, the worst possible scenario, but it seemed to me that that was potentially as likely or likely enough that it should have been mentioned as well. And maybe I'm missing something major there.
Through the chair, Mr. Twite, that is a possibility, and the paper talks about the possibility of a race for fish. I think we are sort of operating under the assumption that the cooperatives and the IPAs will institute some type of measure to prevent that from happening within their cooperative.
And maybe it's that assumption that I'm really questioning. What basis do we have to make that assumption at the very low levels? I certainly agree that our history supports that, but we've gone to great lengths to structure the situations in the past to give co-ops enough tools that they can take that off the table. But our history before co-op is that people raced for fish. I mean, this fishery was conducted as a race for its first 20 years or longer in some cases. So that's the assumption I think I'm questioning.
Through the chair, Mr. Twite, yes, I would say that the assumption is based off of past fleet behavior. And I think there are a few places in the document that highlight that the future incentives and future conditions and the way that the fleet might fish in the future based on restrictions that are put into place here might suggest different outcomes. But that assumption was primarily based on historical past relationships and what we can see within the IPAs and the cooperative agreements.
Thank you. And Ms. Kimball?
Thank you. Thank you, Ms. Marinan, for this. I wondered if there was, even though chum is the focus of this analysis, currently, obviously, the IPA is the primary focus is Chinook. And so did you consider doing something similar under these alternatives about the incentives and how they might change for Chinook? For Chinook avoidance, sorry.
Yeah, through the chair, Ms. Kimball, yeah, we don't have incentives mapped out like this for Chinook, but we do pretty extensively talk about the interplay of these PSC species in a section about PSC trade-offs. You're correct. There's a lot of language within the current IPAs that try to structure incentives specific to Chinook, and there can be when you get to a place where if the meeting a new chum salmon PSC cap is high risk, you get to a place where there can be a lot of tension between those incentives that are being attempted to be created and propped up through the IPAs and new incentives being layered on by a chum salmon PSC limit. That's primarily talked about in the PSC trade-off section of the analysis.
Thank you. Through the chair, and I did read that section. I'll wait until we get to that in the presentation. And I assume it's just too complicated to try to choose that point at which those incentives change, either by sector or obviously at the individual vessel level. That's too complex for an analysis of this type.
Through the chair, Ms. Kimball, yeah, we conceptualized it. And I think we use that kind of concept throughout our qualitative description, but I would expect that that's a really dynamic point. It depends on at what point in the season you are and what's happening with herring rates and pollock aggregations. And there's a lot of factors that would play into that. So we weren't able to model fleet behavior in that way with all of those dynamics, but we conceptualized it on a spectrum in terms of high and low risk of meeting a chum salmon PSC limit, and then what might happen with other existing PSC limits in terms of complex in-season behavioral decisions that the vessels need to make.
Madam Chair, we're going to move on to the next section, which is going to discuss the potential impacts on chum salmon. But first, we're going to walk through some of the status quo trends and use that as the baseline and a jumping off point for potential impacts. I would just note, given the focus of the presentation is more limited, there is a lot of additional background information available for your consideration that covers chum salmon biology and distribution, abundance changes across the North Pacific, as well as stock status, environmental factors, and traditional knowledge on chum salmon declines, all of which is available for you in section 3.2 of the document and the corresponding subsections. This is table 311 from the analysis, and it shows the total chum salmon bycatch in the pollock fishery in each year and for each sector from 2011 to 2023. The total bycatch during this period has ranged from just over 22,000 fish to just over 545,900 fish. The average has been 267,704 chum salmon during the period. And while not depicted within this table, it's worth noting that the 2024 B season bycatch was substantially lower than this average for the period at 35,125 fish. This is figure 1.6 from the analysis, and it's just provided here as a reference point. We're going to walk through some additional data that's displayed by these cluster areas. These genetic cluster areas are simply groupings of ADF&G groundfish statistical areas. They're used in the genetic analyses produced by Auk Bay Labs, and they should be fairly familiar, but we just wanted to make sure that you had a spatial reference point for you. And then the red shape at the bottom right-hand corner is the CVOA, and the blue dotted line are the chum salmon savings area, both of which we spoke to earlier in the presentation. This table is slightly modified from one that's provided in the addendum AD-2. It shows the number of chum salmon caught as bycatch during the B season, and then the total number of chum salmon caught within each cluster area. So it's typical for chum salmon encounters to be higher in cluster 1. However, in 2017, 2018, and 2021, the bycatch was higher in cluster 2. This is figure 311 from the analysis, and it shows the annual chum salmon bycatch for each sector inside these different cluster areas over the same time period. Each panel is an individual year, and the different color bars represent the different sectors. And there's a reference legend for you on the right-hand side. The cluster areas are also shown on the bottom. So the inshore sector typically has higher bycatch and inside cluster 1, and this reflects where these vessels are typically fishing, so where good pollock aggregations can be found. The processors that they deliver to have delivery requirements to maintain high-quality products, among other factors as well. And 2017 is a little different, we can see, where the CP sector had higher bycatch compared to others, and in cluster 2. This is table 314 from the analysis, and it shows the estimated proportion of Western Alaska chum salmon in the total bycatch for all analyzed years by the early and late periods inside of these different cluster areas. The early period aligns with June 10th to mid-August, and the late period is mid-August to the end of the B season. Western Alaska chum salmon are typically encountered in higher proportions of the total bycatch in the fishing grounds near the Alaska Peninsula, so clusters 1 and 2. There are some higher proportions observed during inside cluster 3 during the analyzed period as well. And additionally, Western Alaska chum salmon are more likely to be encountered in higher proportions during the early period as compared to the late. So compared to the April 2024 analysis, which was the last iteration that the council received a presentation and had an opportunity to review, a major change has been the completion of an adult equivalency analysis. The council regularly receives the adult equivalency or an AEQ analysis for Chinook salmon bycatch, but the data that are available for Chinook and chum salmon are different. So this was a new effort undertaken to inform decision-making at this time. It was prepared by Dr. Patrick Berry and Dr. Diana Stram, both of whom are available for specific questions. The overall goal of an AEQ analysis is to estimate the number and the relative impact of salmon that were caught as bycatch but may have otherwise survived the marine environment and made it to their natal streams. The AEQ model is combining chum salmon bycatch genetics data along with the ages of chum salmon and then discounting natural mortality while also accounting for maturation. The adult equivalency estimates do not account for any associated mortalities, be they natural mortality or indirect fishing mortality that may accrue within the river. In order to complete an AEQ analysis, there's several different components that are needed. So the number of total chum salmon caught as bycatch, as well as the genetic stock composition estimates to be able to determine how many chum salmon caught in the total bycatch originated from Western Alaska river systems. An estimate of oceanic mortality is also needed to make an estimate on how many of these fish may have died from disease or predation had they not been caught as bycatch. The ages of the fish, so how many would be maturing in each year, as well as maturity estimates by river system or the percentage by age that would return to their river systems. There's a high degree of uncertainty in numbers 3 through 5, and we describe that at length beginning on page 94 of the document. So we've certainly caveated and pointed out that the estimates that we provide should be taken within the context of the associated levels of uncertainty with those calculations and some of the assumptions.
We have a question for you, Dr. Hapola. Ms. Kimball.
Thank you. And on this slide and the previous, through the chair, I should have asked you this earlier on the side, but it says it discounts natural mortality. And I just wanted to understand that a little bit better. It is accounted for in the AEQ as such. There's an estimate of natural mortality. Are you saying by saying discounted it, that it's a very conservative estimate, or what do I read into that word?
Thank you, through the chair, Ms. Kimball, for the question. I think it's simply meant to reference that some of those fish they're not surviving the ocean environment. So there's a discounting of natural mortality in terms of those that are maturing. So it's not to imply that the uncertainty is greater, but just, thinking through maturation and moving forward, if that's okay.
Thank you. And maybe it's just semantics and on the word natural mortality is accounted for in the AEQ analysis. Is that how I read that?
Thank you, through the chair. Yes, that's correct.
Okay. Thank you, Dr. Hapola. My second question was on the high degree of uncertainty attributed to the ages of chum salmon in the bycatch, because I know we're not aging every sample, but we do do the aging. I know it's a little bit difficult to do and takes a long time, but can you explain that a little bit better? That my assumption is for the samples that we are aging, there's a very high degree of certainty. So I'm wondering why that is attributed to number 4.
Thank you, Ms. Kimball, for the question, through the chair. If Dr. Berry is available online, I think he explained that excellently to the SSC, and I think he's the right person to answer that.
Do we have Dr. Berry online? I think we've connected with you, Dr. Berry, if you can hear us.
Hi, for the record, this is Dr. Patrick Berry with the Alaska Fisheries Science Center. Can you hear me?
Yes, we can.
Great. So yeah, that is correct that when the fisheries observers take genetic samples, they also take a paired scale. And so we receive the same proportion of scale samples with ages. So 1 in 30 chum salmon are sampled for scales. With that being said, there is some uncertainty when you estimate age based on the scale pattern that age readers are reading from these impressions. And we've gone through with the Mark Tag Age Lab and had multiple different agers read the same scale. And for, some proportion of them, there are discordant ages where multiple age readers will call a different age for the same scale. And it's because of some ambiguity in the patterns that they're seeing within the circuli that are laid down within that scale. So typically these age readers use the patterns within circuli that are laid down. And so during the summer months, the distance between these circuli is larger because they're putting on more growth. And in the winter, they get closer together. And in some cases, they look at these scales and they might infer where the patterns are getting really close to call a winner. But they're interpreted differently by different people. And so for the collection of scales that we have for years 2005 to 2019, those were all aged at the Alaska Fisheries Science Center. After that, they were aged at the Mark Tag and Age Lab. So there's also a difference between the person that was interpreting those scale patterns. So there is some uncertainty just within the estimation process and interpreting those patterns within the scales.
Yes, I think, yeah, Ms. Baker and then Mr. Twite.
Thank you, Madam Chair. It is on this topic, if that helps. So thank you, Dr. Berry. I think then this also might be appropriate for you as the author of the AEQ analysis. And following up on Ms. Kimball's question, thank you for that. I think what I heard is there is some uncertainty related to our ability to age chum salmon in the bycatch, but the bullet that's really jumping out at me here on slide 33 under number 4 is where perhaps we get to the characterization, high degree of uncertainty, is how many of those chum salmon would mature in each year. That is really perhaps the important point coming out of number 4 and perhaps how we get to that bar of high degree of uncertainty. Am I interpreting that correctly?
Thank you for the question through the chair. Yeah, so there is like some small uncertainty around the age estimates. But yes, as you point out, there is a high degree of uncertainty around just parameterizing the oceanic maturity schedule for each of the 2 different stocks that we modeled. And so for the AEQ, we estimate both the coastal Western Alaska summer run as well as the fall Yukon run. And so we have different estimates of the oceanic maturity schedule for those stocks. And how we arrive at that is we assume a specific natural mortality level and then look at the age composition within the spawning grounds. And so we only have a limited number of collections from each of those different groups to estimate what proportion of fish on the spawning grounds were certain ages to arrive at that oceanic maturity schedule. And so most of those systems for the coastal Western Alaska group, which when we think of it, it extends from Kotzebue Sound in the north all the way down to the Nushagak, we only are using systems within the Kuskokwim River drainage to parameterize that model. And so we apply just an average over all of those systems to represent that large geographic area. Does that answer your question?
Yes, it does. Thank you.
Thank you, and Mr. Twite.
Thanks. I think one more for Dr. Berry. And just first off, this is impressive to all the staff involved. Being able to pull together an AEQ for chum is really pretty much fresh ground as far as I'm aware in salmon management as well as just our own world. So congrats on doing this. My question is about I wanted to dive maybe a little deeper into the characterization of high degree of uncertainty because I totally get that. And I think that is largely accurate, but I'm wondering if the accuracy or the uncertainty to some extent depends on the age of the fish that are being looked at. At least I think that's correct. The older a fish is, the more likely it is to have low ocean mortality from that point forward. The older a fish it is, the more likely it is to mature and return to the river. So the amount of uncertainty seems for older fish is lower than the amount of uncertainty around younger fish, say difference between 3 and 5-year-olds. Is that A, am I right? And B, is that enough of a difference that we might want to, instead of just characterizing it as high degree of uncertainty as a blanket characterization, if we might want to think about that a bit more?
Through the chair, thanks for the question. So you are correct in stating that for older ages, there is less natural mortality and a much higher probability of maturing in a given year. However, when you look at the kind of the distribution of ages that are seen within the bycatch, the predominant ages are going to be those 3s, 4s, and 5s. We rarely see 6s and 7s, but they do account for some small fraction of the overall bycatch. So you are correct in saying that there is definitely there is less uncertainty in the older age classes and whether or not they would have matured. We parameterize the model such that all age 7s will mature because we don't really see any on the spawning. Well, we don't see any age 8s within the spawning grounds. And so, we're fairly certain that most of those age 6s and 7s will have matured in that age because we just don't see them within the spawning grounds. But again, we're using estimates of in-river maturity from just those, handful of systems within the Kuskokwim for parameterizing the oceanic maturity schedule. In addition to the fact that we see mostly age 3s, 4s, and 5s, I think how we characterize the uncertainty around this model I think it's pretty adequate. In describing just the overall level of uncertainty that we have that underlie all of the parameters going into the AEQ.
Yes, and Mr. Sakata.
Yes, thank you, and thank you for the presentation so far. My question is on the ocean mortality estimate. My understanding is that AEQ analysis was based on a 2002 study of Asian Japanese origin chums, and so I guess I was wondering, it seems like that a study based on hatchery origin fish would underestimate mortality because those fish don't have different fisheries, even directed fisheries on them. They're counted at the hatchery. Would you agree that there may be a bias or along those lines? Was that taken into consideration, or is that one of the reasons that we're listing as a high degree of uncertainty?
Through the chair, thanks for the question. Dr. Stram, are you there to answer that?
Thank you. Through the chair, Diana Stram, council staff. So when we were looking at oceanic mortality, it's true there's not very many studies, and the ones that there are tend to be Asian hatcheries. So we have considerable uncertainty in the estimate of oceanic mortality. And at the end, what we did is borrow the 2012 analysis that we did for chum, which is a pretty conservative estimate of natural mortality. So we thought that we would err on the side of a more conservative natural mortality rate. At that time, we looked at 3 different scenarios for natural mortality. We chose scenario 2 from the 2012 analysis. We looked at the uncertainty. It didn't affect modifying that number didn't affect the overall results substantially, but I would caution that that is a more conservative estimate of natural mortality. If we were to take a less conservative estimate of natural mortality, you would find that the AEQ is much less.
Thank you.
Oh, thank you. I think we're ready to move on.
So this slide provides for you a modified table from Appendix 4, and it compares the estimated number of chum salmon caught as bycatch from the coastal Western Alaska, or the CWAC, and upper middle Yukon reporting groups. Adult equivalent bycatch removals from the CWAC reporting group averaged just over 38,000 chum salmon over the 12 years analyzed. For the upper middle Yukon reporting group, which is aligned with the Yukon Fall Chum Salmon Run, AEQ removals average just over 6,000 fish. There's instances when the adult equivalent estimates exceed the B season bycatch estimated for the reporting group, and this occurs for slightly different reasons depending on the specific year. But it is because the AEQ model is accounting for the lagged effect of bycatch in prior years, which can impact the current year's estimate. So for instance, the AEQ estimates for the CWAC reporting group exceeds the B season estimate in 2012 and 2018. That occurred in the 2012 estimates because of the substantial drop in bycatch from 2011 to 2012. The bycatch of fish that would have matured in 2012 but were caught in prior years is contributing to that higher AEQ number. In 2018, the CWAC AEQ exceeds the genetic reporting group estimate. And again, because of the large catches of chum salmon bycatch in 2016 and 2017, and of fish that would have likely matured in 2018, combined with the overall large reduction in total bycatch. So an AEQ estimate does not account for the associated mortalities that may accrue within river, because it's an estimate of those fish that, had they not been caught as bycatch, may have made it to their rivers of origin. A run reconstruction provides an estimate of total run size by accounting for escapements and harvests, and there's limited run reconstructions for chum salmon available across Western Alaska that align with the stock groupings for the specific bycatch estimates. A run reconstruction is available for the Yukon Fall chum salmon, which is aligned with the upper middle Yukon reporting group. And on the bottom of this slide is table 316, and it shows the AEQ estimates for the upper middle Yukon reporting group from 2011 to 2022, along with the Yukon Fall chum salmon run size based on the run reconstruction that's available. And on the right-hand side is the impact rate. So this is showing you that the AEQ removals due to bycatch based on the upper middle Yukon reporting group ranged from 0.22% in 2013 to 4.93% in 2021, averaging 1% over the time period in terms of the impact on this population and run size. For the coastal Western Alaska reporting group, there's no composite run size. So that means we don't have a total estimate for all of these populations in terms of abundance. So it wasn't feasible for the analysts to complete an impact rate for this reporting group. And so instead, what we work to do is to contextualize the removals of adult equivalent fish with other populations or sources of total removals within the reporting group in line with the SSC's recommendations from their April minutes. So to do this, we looked at commercial and subsistence chum salmon harvests from the different management areas that are aligned with the coastal Western Alaska reporting group. And those areas are shown here on the right-hand side of the slide. And again, we were looking at the same time period, so 2011 to 2022. And certainly this is an imperfect approach because harvest amounts can be influenced by external factors. So for instance, commercial harvests in a given year might be influenced by a processor being available and in-river management decisions in terms of different subsistence or commercial fishing opportunities. So this is only meant to be a partial measure for what may be happening in river, and it's not representative of drainage-wide abundance. This is figure 316 from the analysis, which compares the estimated number of AEQ coastal Western Alaska fish to subsistence and commercial harvests, as well as the AEQ estimates as a proportion of total removals. So commercial fisheries harvests are represented by the dark blue portion, which account for the largest proportion of total removals. An AEQ bycatch of the CWAC reporting group chum salmon as a proportion of total removals fluctuated annually across this period, averaging 2.5%. Moving on to alternative 2. So as Sarah had mentioned before, we are using a retrospective analysis based on the date that a cap would have been met historically. So the quantitative estimates do not account for any potential changes in fishing behavior. That's something that we addressed qualitatively throughout the document. So the hard caps being considered under alternative 2 would have been a binding constraint for sectors in a varying number of years as shown on this slide. The variation in the number of years that you see reflects the apportionments that were used or analyzed. Hard caps that are evaluated at the lower amounts within the range were inherently more constraining for the sectors. And as the hard cap amount increases, the retrospective analysis indicates that it would have been a binding constraint in fewer years. This is figure 1.7 from the analysis, and it compares the historical level of bycatch in each year shown by the red line, and the predicted bycatch level in each year shown by the blue line under each analyzed cap amount and apportionment. Tables on the estimated number of potential salmon saved are available in section 32421 of the document. And then the black dotted line is indicating the hard cap level that we're analyzing. And you can also see that on the right side of each row of the panels. The analysis indicates that the greatest potential reductions of total chum salmon bycatch would accrue from the lower cap amounts and in years with historically high bycatch, so 2021 and 2017. On the other hand, there are years like 2012 with low historical bycatch, where there's no estimated savings compared to status quo because the bycatch in that year is less than the cap amounts analyzed. Across all years and for the entire fleet, the highest reductions were estimated under a PSC limit of 100,000 chum salmon using the pro rata apportionment, which was estimated to reduce fleet-wide chum salmon bycatch by 56.4%. These estimates that we're showing now do not account for oceanic mortality and varying age at maturity, and thus represent chum salmon that would not have been caught as bycatch, but not necessarily those fish that would return to their rivers and regions of origin. This is table 321 from the analysis, which depicts the estimates on AEQ savings from the Coastal Western Alaska Reporting Group. And these savings estimates do account for oceanic mortality and varying age at maturity. When we look at the potential estimates for AEQ reduction, similar trends are observed in terms of the cap amounts. But one thing that we wanted to highlight and bring forward in this slide and the next is that when we look within a given cap amount, there tends to be relatively small differences in the predicted savings amounts when the apportionments are compared to one another. This slide is conveying the same point and information, but it's providing you the estimates on AEQ savings for the Upper Middle Yukon Reporting Group, again, so that you have them easily available for you as a reference point. Moving on to some of the specific implications related to alternative 3. More information is available on this in the document beginning on page 112. Again, under alternative 3, a hard cap would only be in effect during a bee season after indices failed to meet their thresholds. And this is a modified table that shows the years when there would have been a cap in effect under alternative 3, option 1 and 2, as well as an indication of the cap amount. So these are just slightly different from the tables 323 through 326 in the analysis. And a hard cap would have been in effect under 3 or 6 years for option 1 and 4 or 5 years under option 2. On the right-hand side of this slide are the abundance numbers for each area based on the data sources discussed at the start of the presentation. And the table on the left is simply shortened from the prior slide to focus on the more recent years. And I've highlighted 2019 on the right-hand side of the slide to indicate the lag in timing of when the recent period of decline was first observed in river. So the thresholds that are evaluated at the 50th percentile would have caught that first year of decline in 2020 with a hard cap being implemented under both options, but not when they're evaluated at their 25th percentile. So for both thresholds, a hard cap was not, for both thresholds, a hard cap would not have been in effect consistently until 2021. And so when we compare the expected chum salmon bycatch savings under alternative 3 to alternative 2, they're less, but when compared to status quo, there would still be expected savings under alternative 3. This slide walks through some of the information contained within section 32424 of the analysis. So as we've just discussed, alternative 2 and 3 include hard caps that would close the pollock fishery if the cap is met. The management measure itself, they don't inherently provide incentives for the fleet to reduce their Western Alaska chum salmon bycatch, but rather total chum salmon. So the analysis expects that pollock fishermen would target fishing grounds with the lowest chum salmon bycatch rates, with also high catch rates for pollock. So thinking about high efficiency and a low risk of extending the bee season when there is more likely going to be an implication with Chinook bycatch. But also there's variability in the estimated proportion and the estimated number of Western Alaska chum salmon that are caught as bycatch each year. And that's what we've tried to capture here in figure 317. So looking at the retrospective data, we see that reducing total chum salmon PSC is not necessarily a guarantee for the lower number of Western Alaska chum salmon caught in that year. And we used 2021 and 2022 as an example in that analysis where the fleet was able to reduce its total chum salmon bycatch by half, from 545,901 chum salmon to 242,309 chum salmon. But in doing so, they increased their Western Alaska chum salmon bycatch by 8% compared to the prior year. This slide provides a summary of the impact. Sorry.
Dr. Hapala, Ms. Kimball.
Thank you. Thank you, Dr. Hapala. Before you moved on to the next alternative, I understand your conclusions about in your last slide on alternative 2 doesn't necessarily mean you would save Western Alaska chum. You'd be focused on all chum. And so if we were trying to discern what level of salmon saved, or your best estimate of that under alternative 2, for this chum that we care about, Western Alaska chum, we need to focus on, I'm just trying to find the right tables, the table on slide 41, table 3-21. Is that correct? I'm trying to look at between different cap levels and apportionments all seem the same, what level of savings we might see to the Western Alaska chum we care about. So I'm comparing in a 325,000 cap level, 3-year average, compared to a 550,000 cap level. For CWAC, your potential difference is saving 5,000 chum across all CWAC. And the same scenario for upper and middle Yukon, between those two cap levels, you save 800 chum. Are those the tables to focus on? There's a lot of tables in this document, but if I'm focused on the purpose and need, is that where I should focus on alternative 2?
Thank you, Ms. Kimball, for the question through the chair. Yes.
Okay, thank you.
So this slide provides for you a summary of the impact analysis for alternative 4 contained in section 3243 of the analysis. We evaluated each provision for its likelihood to reduce chum or Western Alaska chum salmon bycatch compared to the status quo. And the analysis concludes that all provisions have the potential to reduce bycatch compared to the status quo, except for provisions 3 and 5, although the mechanisms for each of these provisions is different. And we want to be clear that the reason why provision 3 would not necessarily be expected to reduce PSC compared to status quo is because the IPAs are either using excluder devices, they're requiring their use throughout the bee season now, or it's standard practice. So it's really a way to amend the regulations to align with these existing practices from the fleet. And similarly, provision 5 is focused on information sharing, which in and of itself would not inherently reduce bycatch. But the benefit of provision 1 is that it would require the IPAs to describe how they're using historical genetic data, which would be done by completing a weekly likelihood assessment for hotspot closure areas. And when the closures need to be prioritized, deference would be given to areas that are more likely to have higher proportions of Western Alaska chum. Provision 2 provides a benefit by requiring data that informs hotspot closures to be evaluated more than once per week. And this reduces the chance that bycatch rates are increasing on the fishing grounds and they go unnoticed by managers, and managers would also be weighing the risks of allowing vessels to continue fishing in those areas for several additional days prior to a hotspot closure being reconsidered. Provision 6, Provision 4 is really focused on creating vessel level incentives for chum salmon avoidance. And so this is aligned with some of the intent of the changes that were made to the Chinook salmon bycatch program under Amendment 110. And Provision 6 is expected to provide benefits by closing ADF&G groundfish statistical areas with very high chum salmon bycatch rates with benefits to total chum. And depending on where or when these stat areas are identified, there could also be benefits to Western Alaska chum salmon as well. So the next couple of slides are going to walk through the impact analysis for alternative 5. And one of the things,
Excuse me, Mr. Sakata.
Yes, thank you, through the chair. Number 1 in slide number 46 describes the use of historical genetic information, and I noticed that seemed to be a fairly common thing, historical genetic information. At the presentation the BBSRI gave, it seemed fairly evident that in-season current genetics is, if it's not here already, it sounds like it will be very shortly. Are there plans to incorporate more than historical, but there's possibility of a current genetic information in this analysis as we move forward?
Thank you, Mr. Sakata, for the question through the chair. So the IPAs have the flexibility to make that change if they so choose. So at this point in time, the way the analysis is considering the responses to Provision 1 is based off of the proposals that were submitted prior to the April 2024 council meeting. And those proposals are not focused on the use of in-season genetics data. However, because they have the flexibility to modify the IPA contracts, if they so choose, yes, they can use the in-season genetics data in response to this provision moving forward. And the council would receive reports on that annually, usually in their April meeting cycle.
Just follow up. So what you're suggesting here is then the industry needs to kind of realign their IPAs and then submit them for analysis, or maybe I'm sorry about that.
No, that's okay. Sorry, Mr. Sakata, through the chair. So the provision that would be specified in regulation is for the IPAs to describe how they're using historical genetic information to avoid different areas or for avoidance areas. And so right now, they're indicating that they would use a weekly likelihood analysis. If in-season genetics data proves to be an effective way for the fleet to respond to chum salmon avoidance or Western Alaska chum salmon avoidance on the fishing grounds in the future, they can make that change in season to incorporate that. And what I'm trying to convey is that if that change is made, the council can expect to be made aware of how the IPAs are responding to this provision with new or different measures.
All right, thank you very much.
And Dr. Hapala, Ms. Kimball.
I'm sorry, one more follow-up on that, Dr. Hapala. I understand that alternative 4 was generated through industry proposals, but at this point, it's a council alternative that we've adopted. So the council could modify that alternative, correct, to require the use of in-season genetic data if it is available. And then the IPAs would have to come back to the council every year with their IPA report and tell us how they did that. Is that a possibility today too?
Through the chair, Ms. Kimball, yes, that's correct. That's a possibility.
Actually, before we move on, this might be a good place to take our mid-morning break. So let's take about 15 minutes, come back at 10:15, and we'll continue on the presentation for C2. Thank you. Council members, please come back to order. So we are continuing our discussion with our C2 presentation.
Madam Chair, members of the council, again, Kate Hopla with council staff. We're going to move on to alternative 5. So the next couple of slides are going to walk through the impact analysis as it relates to chum salmon for alternative 5. And we tried a couple of different approaches, and I'm going to walk through those here, as well as the potential impacts of the alternative, which include time area closures where pollock fishing can continue outside of a corridor if or when it closes. So at the outset of this, the analysts tried to develop a fleet movement model to estimate the impacts of displacing that pollock catch to outside areas when a cap was met. And the model was designed to move catch from inside a corridor to statistical areas outside in proportion to the catch that occurred. Ultimately, the analysis doesn't rely on those results and put forward all of those estimates for a couple of different reasons. One is that there were several cases where the model had nowhere to move vessels to. And this is what table 333 on the right-hand side of the slide is showing you. It demonstrates the proportion of weeks for each corridor and sector where no fishing occurred outside. So hyphens denote that no closure occurred for that sector, year, and corridor. 0% indicates a closure did occur, but there was some fishing both inside the corridor and outside of the corridor. Percentages greater than 0 indicate the proportion of weeks where a closure did occur and the weeks where no fishing occurred outside. So this was not an issue for cluster 2, but it was a larger issue for cluster 1, and then to a lesser degree in the Unimac corridor, which is fully encompassed inside of cluster 1. And so this made it very challenging to compare impacts across the corridor closures. And then another issue that arose was that there is sometimes or many times only 1 or 2 statistical areas to move catch to, and this could artificially inflate PSC if there was a higher rate for that within the stat area that catch got moved to. So there's more information for you available there in the document, but that's why we didn't move forward with the fleet movement model and instead turned to a different approach to try to think about what elements would be helpful for decision making. So given those limitations, we started by looking at each sector's relative dependence on the corridor areas during the closure window. And again, that's June 10th.
Excuse me,
Sorry.
I apologize. Question, Ms. Baker?
Thank you, Madam Chair. And I just wanted to follow up on your closing statement for the previous slide and in terms of the fleet movement model. And I appreciate the clear explanation. I guess reading through the analysis, though, I felt like there were additional concerns with the fleet movement model that were outlined, just maybe conceptually not quite as specific as you described, that also served as a caution in terms of using that approach for these analyses in general. And I was just wondering if you could describe those a little bit for us, please.
Sure, Ms. Baker, thank you for the question through the chair. So I think at least specific to this portion of the alternative 5 component and analysis, we really used this as a jumping ground or a point from which we said it can be extremely challenging to use retrospective fisheries dependent data to predict where vessels may move to in the future. So we decided to go with an approach that would move catch outside on a weekly basis in proportion to where it occurred historically. But that doesn't necessarily indicate where vessels may fish in the future. And then we considered different options. So we looked back at the SSC minutes for Bristol Bay Red King Crab and that time area closure analysis as well, and considered using PSC as well as CPUE as ways to redistribute effort. And there are some data limitations with those. There's additional considerations that we'll speak to later on in the presentation, both myself and Ms. Marinan, with respect to some of the different characteristics of vessels and the limitations and constraints that they have. And so how that plays out qualitatively within the document as a accompaniment to the quantitative analysis, if that answers your question. So given some of the limitations of the model, we turn to look at each sector's relative dependence on the corridor areas during the closure window. And this is showing you table 336 from the document, where we're looking at the proportion of each sector's B-season pollock harvest that was taken inside the corridor. So we can see that the inshore sector is heavily reliant on cluster 1, and then to a slightly lesser degree, the Unimac corridor. Similar trends are observed for the mothership sector, but their fishing history is more variable. The CP and CDQ sectors are more reliant on cluster 2 compared to the other 2 corridors that are being considered, but it's more common for CPs to move further northwest and fish B-season pollock beyond cluster 2. And then the analysis considered the amount of pollock catch that would have been displaced from a corridor based on the date that a cap was met retrospectively. And these numbers give us a sense for the amount of catch that would have been moved. So the subsequent PSC outcomes would ultimately also be influenced by what the bycatch rate is in the stat areas that vessels would move to. But an important consideration is how much pollock we would have been moving out of the corridors. So this provides you cluster 1 and 2 for comparison. The Unimac data is, of course, also available in the document on page 137 for you, but we're doing this to try to streamline the presentation. So there's some years when sectors would not have met a cap and no pollock catch would have been moved outside. And so in these instances, the impacts would be expected to be neutral or best approximated by the status quo. In other years like 2019 and 2021, we can see that the amounts of displaced pollock catch are quite high, especially for the inshore CV sector and then the mothership sector, so approximately 149,000 metric tons to 217,000 metric tons. The amounts of pollock catch that are displaced from cluster 2 are typically, however, much smaller. So a key factor, again, that will determine the impacts of alternative 5 is the amount of pollock catch that's displaced and then must be caught outside of the corridor when the corridor closes if a sector is going to fully utilize their B-season TAC, and then also what the bycatch rates are inside these new areas. So this is figure 322 from the analysis, and it compares the weekly average chum PSC rates on top, the Western Alaska chum PSC rates in the middle, and then the pollock catch for each sector across weeks in the B season from 2019 to 2023. We added the rectangles for the presentation because they bracket the closure window and are just provided for you as a point of reference. So if a sector did close within this window, we would be looking at where vessels would move to and then the subsequent consequences of that. The document provides an extensive discussion on the constraints different sectors face, as well as their usual fishing locations, and these dynamics will influence where vessels go, and we'll speak more to that in the next couple of slides. But starting on the left, we can see the CP and CDQ sectors have higher pollock catches in cluster 2 compared to the other corridors, and that's represented by the orange line. Conversely, the CV sector's pollock catch is higher in cluster 1, which is shown in blue, followed by Unimac in gray, with smaller catches accounted for in cluster 2. And we can see that all sectors have chum and Western Alaska chum salmon PSC rates that tend to be higher in cluster 2. And what we would be concerned about, or what the analysis raises as a potential for unintended consequences, is a scenario where a substantial amount of pollock catch got moved out of cluster 1 or Unimac and into cluster 2. Even though cluster 2 has had lower proportions of Western Alaska chum salmon, the bycatch rates there are much higher. So this scenario appears as though it would be most likely to occur if the inshore CVs were closed out of cluster 1 because they're more limited in where they can go, and it's expected they would move to cluster 2 and then further northwest as able, but that would be a decision that's made on a vessel and cooperative level basis.
Question, Ms. Baker?
Thank you, Madam Chair. Thank you, Dr. Hoppala. And please feel free to tell me if this isn't a fair question and maybe better left for testimony. But in terms of the higher chum bycatch rates in cluster 2, generally speaking, were you able, in compiling this analysis and looking through the data, is that generally because of a higher incidence of Western Alaska chum in cluster 2, or potentially a lower pollock harvest or lower pollock harvest in cluster 2 relative to say cluster 1. I'm trying to figure out, it's the rates are important, but the rates depend highly not just on the Western Alaska chum being there, but also the amount of pollock that is being caught. And so if you don't, it's possible that we might need to get that out of testimony, but I wonder if there's anything in the analysis that can help, at least at a very rough scale. Is the rate higher because pollock catch is lower relative to the cluster 1, for example, or are there just more Western Alaska chum there?
Thank you, Ms. Baker, for the question through the chair. So I agree that might be something that you can hear more of in public testimony. However, the way the Western Alaska chum salmon bycatch rates are calculated is by applying the estimated late or early period proportion within that area to a sector's weekly chum PSC. So they're inherently linked. So it's not that there's a higher proportion or a greater number of Western Alaska chum salmon that are caught in cluster 2. It's really driven, and I think that's what you were keying in on, and I apologize if you weren't, but is the higher Western Alaska chum rate. And so it's really driven by chum PSC, total chum PSC within that area. And yes, the rates are higher because the number of chum salmon that can be caught or have been caught within cluster 2 tend to be high, but also that the pollock catch compared to cluster 1 and Unimac is substantially lower. And we didn't pull it forward into this presentation, but I think on page 135 is table 338, where we do, we compare the pollock catch by monthly period, the chum PSC, as well as the rate, and that provides a nice clear example of at that difference. Okay, so this slide captures some of the different considerations that we pulled into the analysis to inform how we made inferences and conclusions about where sectors and vessels may move to. So we looked at different regulatory and environmental constraints, and they're provided for you here, but we were considering things like the operational type and the relative flexibility that certain vessels may have. So for instance, catcher processors and motherships to a slightly lesser degree have the ability to move further northwest compared to inshore CVs that have processor delivery requirements, and some smaller vessels have a limited capacity to travel further from port. CPs likewise are prohibited from fishing AFA pollock inside the catcher vessel operational area. And there's other regulatory constraints like the nearshore Bristol Bay trawl closure and other closure areas that prohibit where vessels would move to. And then the fleet would not fish further directly west off of the shelf edge. So we were essentially using this to try to triangulate different options for where vessels could go and what kinds of outcomes we might be able to expect. This is a summary slide that ties together some of the implications for chum salmon and Western Alaska chum salmon bycatch under the corridor options. The logic is provided on the left, and the table on the right is a summary of the different benefit and risk or the unintended consequence scenarios. So because overall chum and Western Alaska chum salmon bycatch tends to be higher in cluster 1 or Unimac, if vessels continue to fish in these areas and they're able to successfully minimize bycatch, there could be a substantial reduction in chum salmon and Western Alaska chum salmon bycatch. This scenario could have the greatest potential benefit in terms of reductions, but it also has a high risk that those benefits would not be realized, and an increase in chum salmon bycatch, including Western Alaska chum salmon bycatch, could be realized if vessels are incentivized to move into cluster 2, both prior to and after a closure. And so when the corridor areas are compared to one another, and again, we did that because these are mutually exclusive options. So it's not just a comparison to status quo, but also trying to help the council weigh the different trade-offs between them. The analysis indicates that implementing a cluster 2 corridor would pose the least risk to creating adverse outcomes for chum and Western Alaska chum salmon bycatch.
Thank you. And Ms. Kimball.
Thank you, Madam Chair. I think I just got my question together on your previous slide 50. And I just wanted to understand for the cluster 1 outcomes, maybe just look at the inshore sector. These are weekly averages over five years. How much differentiation was there by year for the Western Alaska chum rate or the chum rate in the inshore sector in cluster 1? I keep trying to find that table. I'm sure it's in here, but table 338, I think, is all chum, not just Western Alaska. It doesn't have cluster 1 those big spikes like cluster 2 does, and so I'm trying to tell if really every year is kind of similar or if there are a couple years that are really throwing that curve too.
Thank you, Ms. Kimball, for the question through the chair. So table 338 isn't broken out by sector. That's correct. It's fleet-wide. But it's more typical for the inshore CVs to be fishing inside of cluster 1. So given the limitations and the overlap with the CVOA, it's more common that the CPs would be fishing in there for CDQ pollock, not AFA pollock. And there is some variability with the mothership sector fishing inside of cluster 1, but the rates, it's fairly typical for the rates to be low inside cluster 1. And we could also check, but I believe we pulled that out by sector in the addendum. So you could look across the entire bee season. It's not also broken out by monthly period, but we pulled forward each sector's chum, salmon, bycatch, pollock catch, and then the rates in that for you too.
Thank you. That is helpful. And then is there a table 338 equivalent that is just Western Alaska chum and chum rates? Because what I'm looking at is all chum.
Thank you, Ms. Kimball, for the question. No, we don't have a similar table that would be provided for Western Alaska chum and the Western Alaska chum salmon PSC rates.
Okay. Thank you.
The next portion of the presentation is going to transition to talking about the potential impacts to Chinook salmon and herring bycatch. So Chinook salmon bycatch has been managed under hard caps since 2011, often referred to as Amendment 91, and then more stringent regulations were put in place in 2016 under Amendment 110. Appendix 2 has more information on the way existing Chinook salmon bycatch management, how that program works. This is figure 324 from the document, and it shows the number of Chinook salmon caught as bycatch during the A season, B season, as well as the annual total. And then there's also a breakout, so pre and post Amendment 91 when those hard caps took effect. And while there's interannual variability in the number of Chinook salmon caught as bycatch, the levels have substantially decreased since those hard caps took effect. So from 1991 to 2010, the annual average Chinook salmon bycatch was 40,876 fish compared to 18,325 Chinook from 2011 to 2023. The stock composition for 11 different reporting groups is estimated annually for the Chinook salmon that are caught as bycatch. And the Coastal Western Alaska Genetic Reporting Group includes all major river systems in Western Alaska from Kotzebue Sound to the Bristol Bay region, excluding the Middle and Upper Yukon River. This is figure 327, which provides the annual stock composition estimates in the top panel and the estimated number of Chinook salmon in the bottom panel. The proportion of coastal Western Alaska is shown in the second grouping from the left. And the proportion of coastal Western Alaska Chinook salmon caught in the bycatch has decreased from a high of 68.0% in 2011 to a low of 23.7% in 2017, and has fluctuated annually around 47% since 2020. Analyses for Chinook salmon have included an estimated AEQ mortality for both the Upper Yukon and the combined Western Alaska stocks. Those estimates are available in figure 328, as well as additional information in Appendix 5 of the document. The AEQ estimates for Chinook were compared to run size information that's assembled for two regional stock groupings, the aggregate coastal Western Alaska, which includes the Middle Yukon and than the upper Yukon for Canadian origin fish. And this is table 342, which shows the estimated impact of bycatch in the pollock fishery on these aggregate stock groupings. The impact rate for the upper Yukon reporting group was less than 1% in all years from 2011 to 2023, except for 2022, when it's just above at 1.1% of the total run size. And the impact rate for the coastal Western Alaska reporting group ranged from 1.2 to 3.6%. The potential outcomes for Chinook salmon bycatch under alternatives 2 and 3 are varied. What we tried to be more clear about in this iteration of the analysis in response to feedback received in April is that these outcomes could be positive, neutral, or adverse. So the council is currently considering alternatives to minimize chum salmon and Western Alaska chum salmon bycatch, and those alternatives do not inherently create incentives for Chinook avoidance. And the analysis expects that Chinook salmon bycatch would only decrease as a result of these alternatives if the bee season closed early. So the retrospective analysis predicts that an average of 5,448 Chinook would have been saved under the lowest cap of 100,000 chum using the pro rata split, but the estimates are substantially less as the cap amount increases. However, the low chum salmon hard caps amounts were also estimated to be the most constraining. And so the analysis expects that pollock fishermen would react to this constraint. And they may slow down their fishing, they may move more frequently, or move into areas that have lower pollock CPUE. So these scenarios could have unintended consequences in terms of increasing Chinook salmon bycatch. And this is ultimately because the timing of Chinook and chum salmon encounters during the bee season are dissimilar, and we can see that in figure 329 here on the right-hand side of the slide, where we're comparing weekly chum salmon bycatch rates that are shown in the black bars, the average Chinook bycatch rates in gray, and then the average pollock catch in blue. So the Chinook bycatch rates increase during the later weeks, particularly September and October. So the risk of alternatives 2 and 3 would be moving higher amounts of pollock catch to these later weeks. And in this sense, we've been thinking about the blue pollock catch as a wave. And so what are the potential impacts as you move that amount of pollock catch represented by the higher peaks during the time when chum salmon are more often encountered on the grounds to the later aspects of the bee season when Chinook salmon are caught on the grounds?
Yes, thank you. And Ms. Van der Hoeven.
Thank you, Madam Chair. Thank you, Dr. Hopla. I didn't hear in the examples of potential fleet responses, isn't another, depending on how big the stick is of the hard cap, isn't another potential response that the fleet could delay the start of the season, thereby pushing a lot more of the effort later into the season to avoid a cap that would shut them down early based on a really low hard cap?
Thank you for the question through the chair. Yes, that's correct. And we also discussed that there's different possibilities where a cooperative could be issuing a stand down as they monitor their PSC against the cap. So not just at the start of the bee season, but also pauses in fishing throughout if that was required as an avoidance strategy to not meet the chum cap. Alternative 4, which modifies the regulations for the salmon bycatch IPAs, is not expected to result in adverse impacts to Chinook salmon bycatch. The pollock fleet has operated under the IPA since 2010, and the provisions under Alternative 4 largely reflect operations in recent years. Additionally, the IPAs would retain the priority for Chinook salmon closures and Chinook salmon incentives and avoidance measures that are intended to ensure Chinook salmon bycatch is minimized. The approach that we use to analyze the potential outcomes to Chinook salmon bycatch under Alternative 5 was largely the same as that which was used for chum salmon bycatch, and we built off of that work. So this is table 344 from the analysis, and it compares the pollock harvest, the Chinook salmon bycatch in terms of number of fish, and the Chinook salmon bycatch rates during June and July August, and September through November 1, inside each of these corridors. So Chinook salmon bycatch rates were highest in all corridors during the later aspects of the bee season compared to the earlier periods. And this aligns with prior bycatch analyses focused on Chinook salmon. And it also tells us that whether the bee season is being evaluated using grounds-wide data as we displayed for alternatives 2 and 3, or if we're looking at these smaller spatial scales, the corridors, Chinook salmon bycatch increases later in the bee season. This is figure 330 from the analysis, and it shows the average weekly chum salmon and Chinook salmon bycatch rates compared to the weekly pollock catch. Again, similar to the figure that was shown for chum salmon, where the rectangles indicate the corridor closure window. Chinook salmon bycatch rates are shown in the middle row, and we can see that for each sector and corridor, they're very low within that window, typically below 0.02 Chinook per metric ton of pollock. But we can also see that Chinook salmon bycatch rates increased during the later portion of the bee season after the corridor window across all of the corridors. So the red arrows that you see there are simply used for illustration to envision the effect of a sector that got moved out of a corridor where equally good pollock catch rates could not be realized, and that would increase the likelihood that catch is diverted to the later weeks in the bee season with adverse effects or potential adverse effects on Chinook salmon. Because the highest amount of pollock catch moved out of the corridors would come from closing cluster 1 or Unimac to the CV sectors, the analysis indicates that prioritizing chum salmon avoidance in these corridors would be more likely to result in adverse impacts to Chinook salmon bycatch. And so this is where we also referenced back to the estimates on the amount of pollock catch that would have been moved out of these areas based on a closure. And so in some instances, like 2019, when the inshore sector would have closed on June 29th and displacing approximately 200,000 metric tons of pollock, in order for Chinook for the effects to be neutral, we would be looking at a scenario where the inshore sector would have to make up that amount of catch outside. Okay, unless there's questions on Chinook, I'm going to move on, but happy to pause.
I'm not seeing any. Thank you. Oh, Ms. Kimball.
Thank you. Madam Chair, I remembered my question. Dr. Hapala, back on slide 57, and where the conclusion is alternative 3 poses less risk to Chinook compared to alternative 2. I just want to understand that conclusion a little bit better, because my understanding of alternative 2 in general, and very similar to alternative 3, is that we could have positive impacts on Chinook bycatch, or we could have very detrimental impacts. It could go up or it could go down, and we're not quite sure based on movement of the fleet, but it's a risk. And so is that conclusion simply based on the fact that under alternative 3, there would be some years in which a chum cap would not be in place and not push the fleet out of cleaner Chinook areas, or am I missing something else in that conclusion?
Thank you, Ms. Kimball, for the question through the chair. That's correct. It's based off of the conclusion that a cap would, under alternative 3, would not have been in effect in the majority of years retrospectively. And so that's where that's drawn from.
Thank you. So then if I was going to modify that in my brain, I would think in the years in which it was in effect, the risk to Chinook under alternative 2 and 3 are similar.
Through the chair, Ms. Kimball, that's correct.
Before we move off the Chinook section, my last question was on this slide 60. And we know in Chinook bycatch, there are also times of year in which the Western Alaska Chinook are more prevalent, even though it doesn't seem as consistent as chum. And about 50% of the Chinook are Alaskan. Not all Chinook are Alaskan caught in the bycatch, but we did not try to overlay that into this table or figure 330, correct? This is simply all Chinook, not just Western Alaska Chinook, and we didn't try to overlay when we see a greater proponent of Alaska Chinook in the bycatch.
Through the chair, Ms. Kimball, that's correct. I would note that we also didn't pull into the section on Chinook salmon 3.3 in the preliminary DEIS, the seasonal breakouts for coastal Western Alaska and upper Yukon and middle Yukon, but you can find that on page 21 of Appendix 5 and some of the related figures that show the estimated proportions for the A season and the B season. It's not the weekly estimate, but it is there for you in terms of the variability. And I guess a takeaway, as you mentioned, is that the proportion of Western Alaska Chinook salmon in the pollock fishery bycatch is typically a majority proportion, and so, or higher at least compared to chum salmon. And so, yes, and at least in the B season as well, those trends hold true in terms of looking at other stocks. It tends to be slightly less than the A season, but there are years where that's an exception. And so, I hope that answers your question.
Yeah, it does. And thank you for the appendix reference.
Okay, so similar to Chinook salmon bycatch, the potential impacts of the alternatives on herring PSC are varied. So for herring, there's a stronger spatial component for how we approach the fleet's interactions with both chum and herring bycatch. Herring bycatch in the pollock fishery and other groundfish trawl fisheries is managed under time area closures that are triggered by a PSC limit. There's 3 different herring savings areas in effect that are shown on the right-hand side of the slide, which is figure 332 from the document. The timing of these area closures coincides with when a fishery meets its apportionment of the limit. Herring encounters by the pollock fishery are generally higher in the B season compared to the A season. And the analysis expects that the fleet would need to make operational choices on a season-by-season basis to balance its PSC against multiple constraining limits. It's possible that the fleet, as it's prioritizing chum salmon avoidance, inadvertently triggers the herring savings areas. And all of these savings areas have dates that fall within the range of the pollock B season. But the winter savings area, which is indicated by the red square further northwest on the fishing grounds, closes on September 1st. And if the PSC limit was met, that could have the unintended outcome of moving the CP fleet out of the area in September and October further southwest, where chum salmon bycatch interactions may increase. Or if they cannot find equally good catch rates and fishing slows down, we would again be looking at the potential for Chinook salmon bycatch for adverse effects on Chinook salmon bycatch. Likewise, the summer herring savings areas have a high degree of overlap with the in-season corridors being considered under Alternative 5. And due to the dates, herring savings area 2 would be more likely to be triggered just because of the dates that we're looking at in terms of July 1 to August 15th and June 15th to July 1 for the herring savings area 1. And so really what we were trying to focus on there is just the trade-offs that could be presented for the pollock fishery in terms of movement scenarios where if they're prioritizing chum salmon avoidance and potential adverse outcomes for herring and then vice versa.
Hey, Madam Chair, so we're moving into the economic and social impact assessment piece of the analysis. And so I'm going to begin with presenting some information about the Bering Sea pollock fishery and potential impacts. So I'm presenting these sections at a very high level. There's a lot of content. There's a lot that we covered in April. Feel free to stop me and ask questions. And I'm also going to try to high grade some of the new pieces relative to the April analysis. Section 4.1 of the document provides information on the current pollock fishery participation and conditions. It provides data and background on the AFA sectors, associated processors, communities, and some of the market dynamics. For the CDQ groups and communities, this includes CDQ pollock quota, in addition to additional investments in AFA that some of the groups have made. The section also summarizes some of the community benefits that have been funded through the support from some of these revenues. There was expanded information in this iteration on some of the CDQ investment and harvesting relationships, and some of that is pulled through the impact analysis that I can highlight as well. Section 4.2.1 references these sections and the impacts related to this fishery that may continue under status quo regulations. So of course, the selection of alternative one would retain existing chum, salmon, bycatch regulations. So market dynamics, operational costs, and other external factors that can affect the pollock fishery and the communities. They can vary in the future, but the choice of alternative one, so maintaining current regulations, wouldn't inherently create these changes. So it's just a reference to the baseline that we're comparing it to isn't static. There are things that can happen in the future. In consideration of alternative 2 and 3 and overall chum PSC limit, if there's a perceived risk associated with hitting the limit, a vessel or cooperative, it is expected that this could impact them prior to a closure. So vessels would work to avoid chum, and in doing so, they would use different avoidance techniques. Many of these techniques are likely similar to techniques already used, including increased movement, slower, potentially less efficient fishing. One of the most likely impacts of alternative 2 and 3, depending on where the cap is set, is some type of increased avoidance costs. And those can look like a number of different things. We've heard about some of these types of avoidance costs in public testimony in the past. It can affect vessel and crew, including more movement, more fuel costs, possibly extended seasons with associated variable costs. It can affect the shore plants associated with the inshore sector through slower and potentially interrupted deliveries. Avoidance techniques can also potentially affect the size of pollock caught or product quality. The analysis can't quantify the magnitude of these types of impacts, and they really depend on the PSC limits, apportionments. They also depend on specific vessel characteristics, how behavior might change, environmental conditions in the future. However, some level of adverse impact is likely if there's a risk of a chum salmon PSC limit closing down a vessel or cooperative. So individual vessels and companies and shoreside processors will need to evaluate the options pre-season with imperfect information, thinking about their season if there's a risk of a closure. If chum salmon PSC limits met, there's likely broader implications of B-season closures. This is where we use the retrospective data in this portion of the analysis to demonstrate the likelihood and potential magnitude of gross foregone revenue impacts. We emphasize in the analysis that these estimates are an upper bound for potential foregone revenue because avoidance techniques could delay or prevent a closure. And as expected, lower limits would present a greater likelihood and magnitude associated with impacts. So as you can see for the CPs, inshore and mothership sector, they could have been closed out in most of the years under 100,000 cap if fishing behavior hadn't changed. The CDQ sector was impacted in fewer years. However, and I'll expand on this more, but their ability to fish has currently been tied to the CP sector. So even though they show a lower number of years that they could potentially have been closed out, they could have been impacted through the CP performance as well. This table also helps you understand some of the implications of apportionments. It shows the most and least adverse apportionments are highlighted. This can also be seen in a table that I believe Kate presented, table 2.2, which is on page 51. And you can see, especially in that table, that there's a large marginal difference for the CDQ, CP, and inshore sectors, and less variation with the apportionments for the mothership sector.
Ms. Marinan, before we move on, just a point of clarification as far as you identified the relationship between the CP and CDQ sector, but when we're looking at this particular table and the potential foregone revenue, that you're not accounting for the CDQ level of investment in the CP when we're looking at the CDQ line. That is just based on the CDQ allocation.
Yes, Madam Chair, this is specifically associated with the CDQ pollock and looking retrospectively when that sector could have closed relative to the CDQ pollock. So it doesn't account for any other investments there.
Okay. Thank you.
In April, the AP requested some more information and a vessel level impact analysis. Provided in Appendix 6 this is an extension of the retrospective methods and using the inshore vessel apportionments as an example. And this analysis demonstrates another layer of impacts that could be experienced by vessels and companies. I don't have the information to connect vessels together through companies, but as shown for all 3 years at higher chum salmon PSC limits and least adverse apportionments, the sector wouldn't have reached its apportionment, yet adverse impacts could have still been experienced for the vessel owners and crews for some vessels that reached their vessel level apportionment. And so it's possible that, especially if there are a number of vessels within the same company, they could have moved that pollock quota and still had it harvested. So you might see the harvest amounts at the sector level or the company level. But this is just another note to indicate that there could still be distributional impacts within those numbers in terms of crew that are impacted or captains that are impacted or vessel owners.
And Ms. Marinan, when you, I guess when you were describing moving across vessels, that would, the implication of that, I guess, are we to draw the conclusion that the implication of that could be consolidation within that sector? Okay.
Madam Chair, yes, that is what I was referring to. If there are frequent or erratic bee season closures, impacts could be broadly felt and even potentially beyond the pollock fishery and pollock communities. So some of these sections have been expanded in this analysis based on feedback in April. So for instance, for shoreside processors that are connected to the pollock sector, early closures could reduce wholesale revenue, reduce economies of scale, and compromise market opportunities. This could affect compensation and potential employment for approximately 1,700 processing crew. The impacts for shoreside processors and processing workers are linked to the performance of the CVs that deliver to them. An analysis demonstrates a high dependency for these processors on pollock and a dependency that has increased with recent declines in crab. Instability of bee season closures could be extended to non-pollock fisheries as well. So the effects of processor availability in the late fall, early winter could be impacted with the early bee season closure. So for example, for processing for Pacific cod, crab, salmon, sablefish, and given current market vulnerabilities and consolidation in the shoreside processing sector, it could potentially impact processing stability in other fisheries or communities. There's some expanded considerations for potential CDQ impacts. So as discussed, groups can be impacted through their CDQ pollock in addition to additional investments in AFA. And there's a table in the paper that highlights what those investments are, as have been described to me. For most CDQ groups, the CDQ pollock apportionment has typically been leased to CPs for most of the groups. And this has represented a large and relatively stable portion of revenue that contributes to community benefit programs. 5 of the 6 groups have additional investments in AFA sectors. So the amount of pollock associated with CDQ groups between the 10% apportioned to CDQ and additional investments represents approximately 29% of the total directed fishing allocation for the Bering Sea pollock fishery. And that's shown in the document. This document has additional discussion highlighting the potential for impacts to CDQ groups' leverage in negotiating harvest agreements and lease rates with harvesting partners, and potential challenges with CDQ pollock if the groups wish to shift pollock from harvesting with the CPs to the inshore vessels in the future based on apportionments that are being considered.
Looks like we have a question, Mr. Sakata.
Yep, thank you. You kind of, I think, touched upon it at the end there. With some of the fleet consolidation as well as some steel coming offline due to certain events, did you receive any indication to support kind of what you were saying in the last sentence that future CDQ may not be harvested on CP? Did you receive any indication that might be something that will happen in the future?
Through the chair, Mr. Sakata, I can't predict the future in that way. I have received concerns from CDQ reps that have highlighted what if a CP harvesting partner wasn't available in the future. I think even if groups don't choose to shift their quota from the CP fleet to the CV fleet, there's also been concerns highlighted to me that it could impact their ability to negotiate lease rates because that option might not be available for them, or at least not available for them in an easy way to transfer quota from the CPs that they've harvested with in the past if they want to move their quota to an inshore CV, for example.
Thank you.
And Ms. Baker.
Thank you, Madam Chair. My question is slightly different, but on the same slide. And you mentioned, so I'm back to the shoreside processor impacts of potential impacts of alternatives 2 and 3, and particularly the potential impact on processors' ability to process other species or impact operations in non-pollic communities. Can you just provide a little bit more detail about what the analysis, the potential qualitative impacts there that you looked at? I'm just trying to go through the various fishery seasons in my mind and how that might play out. If you could help me walk through that, please.
Through the chair, Ms. Baker, Kate produced a really helpful table on page 203, table 49, that I think does a nice job for helping me think through the seasons. There highlights the processors that have been active in this fishery and the different seasons related to species. So, for instance, after the pollock bee season, some of these same processors might be processing crab, or Pacific cod, or black cod, if I'm missing any. But I think that table is a helpful reference.
Through the chair, thank you. It is.
And Ms. Kimball.
Thank you, Madam Chair. Follow up on Ms. Baker's question. Ms. Marinan, did you think about any other ways in order to identify what those impacts might look like? I know that it's not a directed entity that's being regulated in, any fixed gear fisheries or non-pollock fisheries that are dependent on having markets in the Aleutians. But it's a pretty significant potential impact to a lot of people that aren't directly regulated. So have you thought of other ways to kind of characterize either that likelihood or the significance of it? I do see that you have at least community revenues associated with the pollock bee season, and I was wondering if even revenues associated with other fisheries that are provided to communities might be one way to get to that, but maybe you've thought of other things through your SSC discussion.
Through the chair, Ms. Kimball, that would be something we could consider is thinking about the other fisheries that occur, especially later in the fall and earlier in the winter, and expanding to provide some information on those fisheries and how many people are involved with them, and how many people could potentially be impacted. I still really struggle with identifying more context around the likelihood of that. I think the likelihood could be highly variable, and we're in very challenging market conditions right now, and it's hard for me to predict where those are going to go and what those external factors are going to do for the sustainability of shoreside processors. I think the best I could do with it is with additional communication with processing reps to where they individually might perceive those thresholds, but I think I would have a hard time with the data that we have available to determine for them where those thresholds might be.
Thank you. That's very fair. I'm just looking for other ideas, and I think having more context around the likelihood is really complex problem, something very difficult. Maybe a little more focus on who might be affected should that likelihood come to pass might be helpful to round out what could be some pretty significant impacts on non-directly regulated entities out of this action. We've already seen that come to pass in salmon, and it's pretty dramatic. So just putting in a plug if there's any other ideas, at least on potential impacts, if not the likelihood. Thank you.
So Madam Chair, an additional element from this iteration of the paper is an expanded discussion about potential spillover impacts. This was another request from the AP in April. And so there's additional analysis that's been included in Appendix 6 and summarized in the paper. The purpose of this analysis, which we had an abbreviated version in April, is to think about if there's an early bee season closure, could some of these vessels move from fishing pollock in the bee season to fishing in other fisheries and make up some of that revenue in other fisheries? Also, would there be any other fisheries where people would be impacted from the movement of new vessels showing up and competing in their fisheries? And the very brief summary of this appendix is that there's very limited spillover possibilities. There's quite a bit of rationalized programs and sideboards, and really where there's opportunity, it's very vessel specific and based on LLPs and endorsements. And there could be some differences for vessels that are already exempt and able to fish in the Gulf. They might make different decisions about whether to participate in bee season pollock, but overall, very limited spillover possibilities for both the CVs and CPs. There's also been some expansion in this analysis related to potential market impacts. Current conditions of record low seafood prices, inflation, increased foreign competition, among other factors, could make the pollock fishery and associated processors more vulnerable to impacts in the current state. Additionally, if frequent or erratic early bee season closures occur, the analysis expects there could be broader implications for adverse impacts across certain communities. The magnitude and potential effects depends on the community's connection to the fishery and the amount of pollock that could have been left unharvested. So this is most clearly demonstrated through communities associated with port of landing for pollock. So that's Unalaska, Akutan, based on previous landings, also King Cove. These communities could see reduced tax revenue from product transfers. This is a tax base. The tax base from pollock has been an important and relatively stable source of revenue for these communities. There's community infrastructure and support services that are built around commercial fishing and the seafood industry. And the closures could impact other fisheries that provide tax revenue or other local opportunities. So there could be compounding effects for these communities. Also, in relation to communities, there could be impacts to captains and crew compensation, potentially employment opportunities for approximately 2,300 onboard harvesting and processing crew. We don't have crew community data for the AFA sector, but impacts could expand through these communities as well. There could be impacts for vessel owner and home port communities. So that's primarily identified Seattle, MSA, Kodiak, Newport, and Unalaska. Closures that could impact CDQ groups through their direct quota and investments could also make it difficult for these groups to support community programs in the same way. Okay, moving on to impacts from Alternative 3. So the potential impacts here could be very similar in concept to those that were described under Alternative 2. However, there's two primary differences here from Alternative 3. The first is that because this is based on an index and it may not be in place every year, impacts may not be experienced in every year. So under option 1, based on the retrospective data that we looked at, it would have been in place in 2 or 6 of the years. And for option 2, it could have been in place, the overall limit would have been in place 3 or 5 of the years. Under option 1, a chum salmon PSC limit could be reduced to 75,000 with 2 or 3 of the area's abundance thresholds being unmet. And if the cap was initially set at 100,000. So this is just a point because it added another layer to a retrospective analysis. We needed to look at that 75,000 limit as well and how that would look in terms of sector apportionments. So as you may expect, a lower limit could close the fishery earlier and result in greater economic impacts. In terms of alternative 4, we would expect minimal to no additional costs as a result of alternative 4 relative to status quo. Again, this is sort of a product of how we're measuring status quo here. Many of these measures have been adopted by the IPAs. So avoidance techniques and costs may have been incurred as a result of their adoption, but this alternative essentially codifies many of the recent operational changes. So Kate provided quite a bit of context for alternative 5, and this is really just an extension of that analysis. In evaluating the potential impacts to pollock fisheries and associated communities, the pollock sectors are expected to weigh the risk of a corridor closure, but also the consequence. So this had sort of a 3-part approach to the evaluation of potential impacts. The first is to look at historical reliance for each sector, as well as operational constraints. So as Kate already highlighted, the inshore and mothership sectors are highly reliant on Cluster 1 and UNIMAC. The inshore sector has less flexibility in how far from port they can travel. There's generally a 48-hour delivery standard. So smaller inshore CVs could be disproportionately impacted from a Cluster 1 or UNIMAC closure. And I have a slide here to quickly demonstrate some of the information from the analysis that categorizes vessels by length and the maximum distance within that year that some of the vessels have traveled. And just to give you a general sense, plotting out Cluster 1, it's approximately 80 nautical miles just to get to the edge of Cluster 1. So for some of the smaller vessels, especially the less than 100-foot vessels, it might not, given where they can move from there, they might have too many opportunities, and essentially we would expect would be fishing in Cluster 2 or have some other challenges to fish further outside. The CP and CDQ sectors have more reliance on Cluster 2 than the other areas. The second part of the impact analysis for alternative 5 is considering the impacts prior to a closure being met and impacts if the closure was met. So if the closure presents a high consequence for the sector, it's likely that they would change their behavior to the extent they can prior to the closure. So depending on the cap, we would expect this to be the case for the inshore sector and the mothership sector for a Cluster 1 or UNIMAC corridor. And the types of avoidance costs that could occur under this situation are similar to what I described for alternative 2. If the closure was met, the analysis estimates revenue at risk associated with potentially unharvested pollock. And these numbers really present an unlikely upper bound for the likelihood of closures and the magnitude of revenue impacts, because we would expect the fleet to try to adjust beforehand, and also if a closure happens, to move outside of that closure to the extent vessels can. The analysis highlights that unharvested pollock might be possible for the inshore sector with a Cluster 1 or UNIMAC cap, depending on the cap and when it's hit in season. Unharvested pollock could adversely impact harvesters, processors, crew, CDQ groups, and potentially have market impacts in a similar way that we described with alternative 2. There's also an impact analysis for alternative 5 associated with communities. Based on the analysis of pollock sector, there's similar types of impacts as alternative 2 considered for communities under alternative 5. Okay, Madam Chair, move into potential benefits. So similarly, this section of the presentation is going to be covered at a very high level. There's quite a bit more depth in the analysis, and also the cooperating agencies have submitted information relative to some of these parts that I can point out as well. So Section 4.4 provides current subsistence and commercial harvest information. Section 4332 describes the importance of chum salmon for Indigenous people in the Yukon and Kuskokwim region. And there's additional information on stock status in Section 3231. Beginning in 2020, West Alaska chum salmon runs declined dramatically. Management has a priority for conservation, then subsistence uses, next all other consumptive uses. Nearly all the river systems have had run sizes below recent averages, with some river systems at historic low levels. Those dependent on chum salmon for subsistence use, particularly on the Yukon and Kuskokwim rivers and associated tributaries, have faced closed or limited fishing opportunities. These fisheries are critically important for food security, food sovereignty, culture, as well as the holistic health and well-being for Indigenous communities. The impacts of the chum salmon closures have been experienced cumulatively by communities along the river, with declines in other salmon species, resulting in broader ecosystem impacts, amplifying the food security crisis, and disrupting traditional practices and knowledge transfers. And as I mentioned, the cooperating agencies have provided much more depth and information related to these impacts. You can see information related to health implications, financial implications, and I think there's going to be some more of those pieces presented in the cooperating agencies' presentations as well. So here under Alternative 1, this would retain existing chum salmon bycatch regulations. Existing conditions could change in the future, but the choice of Alternative 1 wouldn't inherently create those changes. So there's a two-part approach to our analysis of potential benefits here. The first is walking through each alternative and thinking about the magnitude and likelihood of Western Alaska chum salmon savings under each alternative and how that might manifest in terms of benefits. And then the second part of the approach is to more qualitatively describe broader benefits that could be realized under any action alternative that provides increased Western Alaska chum salmon returns. And just to highlight, there's different nuances and types of uncertainty and potential impacts, but we tried to use a similar approach to what we used on the cost side of the impacts. So we used the retrospective data where we could. This is really an extension of the presentation Kate gave on the Western Alaska chum salmon impact analysis. For consideration of future impacts relative to the retrospective data and the AEQ estimate, there's different qualitative assumptions and different assumptions that move forward. So in contrast with the foregone revenue analysis, which is an upper bound when we look at retrospective data, the numbers that are being provided are not necessarily an upper bound or lower bound of potential savings. There's a different type and resolution of data to describe the nuances of the potential impacts of the proposed alternatives, but there's a similar emphasis here as we have in the cost side in considering the broader implications of the alternatives, which is mostly done in a qualitative way.
So as Sarah was just mentioning, we did take two different approaches, one that's quantitative and one that's qualitative, to try and characterize the different types of benefits or the conservation benefits of the proposed alternatives and how they may be realized for Western and Interior Alaska communities. So this next part is going to walk through the analysis, which starts on page 305. And as we discussed earlier in the presentation, there is different data that are available for the two genetic stock reporting groups that comprise the combined Western Alaska reporting group. So we know that the chum salmon caught as bycatch and attributed to coastal Western Alaska are from a wide range of populations, and that can be seen here on the left-hand side of the slide, but we don't know the total or composite population size for this reporting group, and we don't know the proportion that these individual populations represent within this reporting group. So we're very limited on the quantitative, we're very limited on our ability to take the quantitative estimates on potential adult equivalent coastal Western Alaska savings, which are shown here on the right. So pulling forward table 321 from earlier in the presentation and the analysis, where these savings estimates are accounting for genetic stock of origin and age of fish and maturation. So it's very difficult for us to say the extent to which any of these river systems or communities would receive potential benefits as a result of the proposed action. But we did work with ADF&G staff to figure out what might be a reasonable pathway forward. So the Yukon Summer Chum Salmon Run is accounted for within the Coastal Western Alaska Reporting Group. But again, we don't know exactly how many of those fish are accounted for within it. So the relative proportion is unknown. But there is a run reconstruction that's available for Yukon Summer Chum, which is not available for other stocks and populations that are encompassed within the reporting group. And a run reconstruction provides a scientifically defensible way to measure a run size by accounting for escapements and harvest. And the run reconstruction numbers give us a numerical benchmark to be able to make a comparison against the AEQ savings. And additionally, for the Yukon Summer Chum Salmon, the Yukon Summer Chum Salmon Management Plan has a drainage-wide escapement goal, as well as thresholds for the run size that need to be met for managers to consider providing subsistence and other directed use opportunities. And that's available for you on the left-hand side of the slide, which shows the Yukon River Summer Chum Salmon Management Plan thresholds. The approach that we used to scale the potential savings estimates are the same for Coastal Western Alaska and the Upper Middle Yukon Reporting Group. We're comparing the AEQ savings estimates for each reporting group to the run reconstruction. So again, remember that Upper Middle Yukon, that reporting group is aligned with the Yukon Fall Chum Salmon stock, so that's a more direct comparison. But we're looking at the run reconstructions as well as markers for directed fisheries opportunities. So this is table 438 from the analysis, and I just want to spend a little bit more time trying to explain this because the display of data is different from what you would see or you do see in table 439, which is for Yukon Fall Chum Salmon and not shown here. So on the left, you see adjustments, and what those rows are showing are downward adjustments to account for the uncertainty and how many of these adult equivalent fish may actually be Yukon Summer Chum Salmon. So it's assumed that it would be unlikely 100% of the coastal Western Alaska fish are Yukon Summer Chum, but we don't know how many actually are and would be attributed to that run size. So the way to conceptualize the adjustments is to say that if 100% of these savings estimates are returning to the Yukon as summer chum, then 0% of those fish are returning elsewhere within the reporting group. And likewise, if 75% return to the Yukon as summer chum, then that would mean that 25% of those fish are returning to other river systems across the region and reporting group. So this slide walks through the implications of the scaling exercise, which is trying to get at whether or not they could have had a measurable effect on escapements or in-river opportunities. And so again, going back a couple of slides to the different management plan thresholds, those are intended to be used as a conceptual framework and a place of reference. So these are adjusted tables from 438 and 439 in the analysis that show the years with the high and low run returns compared to predicted AEQ savings under the lowest cap amount for alternative 2. In 2017, both Yukon summer and fall chum runs were at their highest level within the analyzed period. And despite both runs being well above the lower bound of their escapement goals, there were limited subsistence fisheries or fishing opportunities due to Chinook conservation measures. And so this gets at some of the potential intervening variables. And this was something that was asked of us in April to be more clear and articulate some of that context better in this iteration of the analysis. And so we spent a lot of time in Chapter 4 talking about how in-river management is dynamic and it could be affected by any number of things. And so when we compare the retrospective estimates to the run size and management measures that would have the management measures appear to have resulted in more fish in the river system and possibly improved abundance, but not necessarily expected to improve directed fisheries opportunities within a given year.
Question, Ms. Kimball.
Thank you. Dr. Hapala, on the slide 79, I suppose it is. I thought I understood this table, but maybe I don't. And the estimated AEQ savings on the kind of the top row of each sector apportionment, that's the assumption that every one of those CWAC chum came from the middle or upper Yukon. I'm trying to understand what that estimate of AEQ savings is? The
Thank-
unadjusted.
Thank you, Ms. Kimball, through the question. So the unadjusted savings here would be indicating that 100% of the coastal Western Alaska savings are Yukon summer chum. So for this table, we're looking at the run reconstruction for the Yukon summer chum. Right? Yep. Yeah. And sorry. And so given that we don't know the proportion of these fish that are actually Yukon summer chum and returning there, we're making then downward adjustments to say, if not 100%, then 75, 50, and 25.
Thank you. And I assume that's kind of the best we could do in trying to determine what level of benefit we'd provide. Did you consider providing this for the other cap levels? Or, I mean, there is some benefit to providing, here's kind of the bounds. But if what the council is trying to do is make a decision on various options, I guess I would need to be able to see what the difference was between a 100,000 chum cap and the difference between a 325,000 chum cap or 550,000 chum cap. So is this just too coarse to require kind of doing it for all those other cap levels, or please help me with this?
Thank you, Ms. Kimball, for the question through the chair. So we certainly could do the same exercise for the higher cap levels. We would just be using the estimates that are provided here in table 321. So then working through 325,000 and 550,000. So it would be easy enough for us to do, and we could do that in the next iteration. The reason why we didn't, or at least we focused on 100,000 for a 100,000 chum salmon cap for this iteration of the document, is because that's the lowest cap amount that was estimated to produce the highest potential for chum salmon savings, and therefore the starkest contrast compared to status quo. And then we were also just thinking through the amount of tables to provide that for all of the different apportionments and all of the different cap options, and then for 2 different reporting groups. We certainly can revisit that and find other ways, especially if the council feels like that would be of use, comparing across the different cap options. But that was just the rationale for why we didn't.
Thank you. Thanks for that response, and thanks for the latitude, Madam Chair. I do think the difference in costs in the analysis are so large among options that it's important for us to see the difference in estimated benefits. Thank you.
Okay, Madam Chair, we're going to move on to alternative 3 then. Similar to the discussion on the cost side, the primary difference between alternative 3 and 2 in terms of impacts is savings and associated benefits may not occur in every year under alternative 3. So option 1 impacted, the impacts could be experienced in 3 or 6 of the years, looking at 2011 to 2023, or for option 2, impacts in 3 or 5 of the years. Under option 1, chum salmon PSC limit could be reduced to 75,000 with more thresholds unmet if the limit was initially set at 100,000. So again, this extended our tables down to 75,000. So there's a complementary table to what Kate just showed in terms of potential benefits that also connects with the 75,000 limit. In terms of alternative 4, relative to status quo, most alternative 4 provisions have the potential to reduce chum salmon bycatch. Although the analyst can't disaggregate the impacts of specific measures relative to external factors, new measures adopted voluntarily through the IPA amendments since 2021 have coincided with a approximately 95% reduction in chum salmon bycatch So again, this alternative essentially codifies recent operational changes. And so there could be a continuation of some of these reductions. Many of the measures that are described would increase the likelihood of Western Alaska chum salmon savings. So it could provide benefits for Western Alaska chum salmon users. Under alternative 5, alternative 5 could have varied outcomes for those dependent on Western Alaska chum salmon. Again, this is an extension of the impact analysis for Western Alaska chum, which highlights a likelihood for positive outcomes and a potential risk of adverse effects. So tries to characterize both of those things when we're looking at the corridors. So depending on the corridor and the cap amount and the apportionment, as well as the pollock fleet's response, Cluster 1 and UNIMAC demonstrate possible high benefits if the fleet stays in those areas and is able to minimize chum salmon using avoidance techniques. But there's also a high risk for adverse effects if the response is to move vessels outside of those areas, especially we identified a potential risk with more movement into Cluster 2. So a Cluster 2 corridor cap has potential low-medium benefits, but a lower risk of adverse effects. Under this alternative, we also considered potential impacts to Chinook salmon PSC as another species of critical importance to Western Interior Alaska tribes and communities. And the analysis highlights that if the corridor caps result in longer seasons due to increased chum salmon avoidance techniques or increased travel, there could be adverse impacts to chum salmon bycatch associated with chum salmon bycatch as well. I mean, Chinook salmon bycatch. If Western Alaska chum salmon savings are realized under the corridor caps or any of these alternatives, there could be much broader implications and benefits. And that is described, I'm going to describe that next more broadly among the alternatives. So this slide is just meant to highlight the potential flow of benefits as we're describing them in the benefits section. So the impacts of reduced Western Alaska chum salmon bycatch could be experienced cumulatively with other factors that influence Western Alaska chum salmon returns. There are intervening variables, and those can add another layer of uncertainty to potential impacts. So what we have control over here is Bering Sea pollock regulations, and we're thinking about that in terms of how it might change behavior or close fisheries or move fisheries, focused on reducing Western Alaska chum salmon bycatch. And then if increased Western Alaska chum salmon returns, then this could open the possibility for much broader benefits in terms of social, cultural, economic, and ecosystem benefits more broadly. So as highlighted in the paper, there's a few types of benefits that could increase, if any amount of increased Western Alaska chum salmon return as a result of bycatch reduction actions. So specifically highlighted in the paper is the concept of passive use benefits, and also ecosystem benefits are highlighted and in the analysis and also by the cooperating agencies. So this can include cumulative or longer term impacts from a small number of spawning females and survival of discrete spawning populations. The focus of potential benefits for directed use opportunities for subsistence or commercial fishing associated communities can be maybe based on meeting escapement goals and dynamic in-season management that Kate described. The analysis can't predict which communities or river systems may receive benefits from potential bycatch reduction in terms of improved harvest opportunities in a quantitative way. We can't take that analysis that Kate provided further to communities. However, the analysis does provide extensive information on trends in historical harvesting patterns and the importance of these harvests. The analysis highlights the severe and escalating impacts of closed or limited salmon fishing opportunities on the Yukon and Kuskokwim in particular, for culture, food security, food sovereignty, and way of life. This piece of the analysis is also emphasized in the cooperating agencies materials that they've provided. If there is an opportunity for subsistence or commercial fishing, even a few hundred fish could have a positive impact. And if bycatch reductions contribute to longer-term viability of the stocks, the analysis describes a profoundly positive effect on human salmon ecosystem relationships, indigenous values and culture, food security and food sovereignty, and the resilience of communities within these regions. And again, I believe these are topics that cooperating agencies, tribal cooperating agencies may highlight in their presentations in more depth.
Excuse me, we have a question, Mr. Sakata.
Yes, thank you. You had mentioned that a small number of fish may be beneficial in discrete what did you say about that? Discrete populations, like the genetics. Is there evidence? I thought the reason that we have to lump all these into these kind of large groups like the Western and Central Alaska genetics groups is that we weren't able to identify discrete genetic populations within the Western Alaska area.
Thank you, Mr. Sukata, for the question through the chair. I'm happy to speak to this a little bit. So this is a concept that the cooperating agencies have brought forward and highlighted. And some of the literature that is being referenced there is focused on Chinook salmon. And so the analysis points out that if similar assumptions were to be made, although if similar assumptions for Chinook salmon to chum were to be made, it is possible that there could also be discrete spawning populations that would have potential benefits to Western Alaska. That being said, you are correct that there is an inability to differentiate genetically among these populations. So it's a concept. It's not, we're not pointing to it in the analysis I think in such a direct way as what your question might be indicating.
Okay, so that information was provided by the cooperating agencies.
Through the chair, that's correct. And I think the council will hear more about this in their presentations. But if you have specific questions for them at that time, of course, ask them, but they're also here now. So if you would like more, but we can.
Oop, I'll go ahead and wait till the presentation. Thank you.
Okay, so this is the final section of the final section of the analysis for the analysis of potential impacts. And we're going to talk about some of the combined effects of the alternatives as well as the trade-offs. So we're really trying to pull together some of the high-level takeaways from the different chapters and portions here.
So if one or more of the alternatives are adopted in combination, this could generate different incentives than the alternatives on their own. So this is should be a familiar figure. I walked through the incentives under the alternatives on their own. In general, adding the 6 provisions from alternative 4 to an overall limit or corridor cap, is not expected to change the incentive structure established by alternative 2, 3, or 5. The provisions in alternative 4 are generally aimed at being more responsive to chum salmon PSC rates, like with weekly closures, for example, and that would be expected to complement industry efforts under alternative 2, 3, or 5. Adopting an overall limit in combination with a corridor cap, so alternative 2 or 3 in combination with alternative 5, could shift incentives. The consequences of the corridor caps would be felt differently across sectors. The overall caps are more similar of a consequence. So we expect the measure with the greatest consequence and likelihood of occurring to drive behavioral decisions. And this could be different by sector and different within season. Even stronger incentives. So generally together, they would provide an even stronger incentive to minimize chum salmon. Not inherently Western Alaska chum salmon, but all chum salmon in the corridor and outside, and contribute to more complex in-season decision-making.
This slide walks through some of the potential benefits for chum salmon and Western Alaska chum salmon bycatch reductions under a combination of alternatives. So alternative 5 may be selected in conjunction with alternative 2 or 3, and this scenario would require the pollock industry to operate under 2 different PSC limits for chum salmon, one that would halt fishing immediately if a cap was met, and the other that would require vessels to move to new fishing grounds for a period of time. Alternatives 2 or 3, as well as 5, would implement a hard cap alongside an in-season corridor cap. And the analysis expects that the combination of alternatives would reduce bycatch compared to status quo, but the magnitude of these reductions would depend on the cap amounts and the apportionments chosen, as well as the degree to which pollock fishermen are able to change their behavior and stay below both caps. Implementing 2 caps together could also decrease some of the uncertainty that's associated with the risk that in-season corridors could create unintended adverse effects on chum and Western Alaska chum salmon, in that a hard cap would effectively put a ceiling on the total number of chum salmon that could be caught anywhere on the fishing grounds. Alternatives 2 or 3, as well as 4 and or 5, if the council were to select alternative 4 in combination with any other alternative, the IPA measures designed to respond to the regulatory provisions could be used as tools to further reduce bycatch under any of the alternatives, specifically thinking here about chum and Western Alaska chum salmon avoidance. So for instance, the biweekly evaluation of rolling hotspot closures would enable the industry to be more reactive at avoiding chum salmon bycatch on the grounds. That specific measure is reducing the chance that bycatch rates would be increasing and go unnoticed or unresponded to by hotspot implementation and cooperative managers. Instead, they would be weighing the risks of not moving vessels and advising vessels to stay out of an area on Monday evening, so from Tuesday to Friday closure.
In terms of the potential costs under a combination of alternatives, with the adoption of alternative 2 or 3 in addition to alternative 5, so PSC limit, an overall limit in addition to a corridor cap, if the sector wouldn't experience a high consequence from the corridor cap, so for example, the CP sector, if there was a Unimac cap established, the overall cap would drive the behavior and avoidance costs. So similar impacts would be expected as the standalone alternative 2 or 3. If the corridor cap does pose a high consequence to a sector, they're likely to have increased operational costs associated with avoidance relative to just a standalone alternative 2 or 3 alone. So possibly increased movement, slower fishing, more test tows, possible consolidation. And then in general, lower amounts for an overall PSC limit and a corridor combined are likely to result in broader adverse economic implications. The adoption of an overall chum salmon PSC limit and a corridor cap, especially if we're talking about cluster 1 or Unimac corridor caps, along with the existing Chinook and herring limits, would drive more complex in-season decision-making for the fleet. And we're going to talk about that next. The combination of alternative 2 or 3 plus 4 and or 5 together, generally these avoidance techniques might aid the industry attempts to remain under the overall PSC limits or corridor-specific caps. So we expect that adding alternative 4 in addition to these other measures are unlikely to increase the costs relative to just evaluation of the cost of the alternative alone.
Yes, Ms. Kimball.
Thank you. Just briefly, I had kind of expected, based on our purpose in minimizing Western Alaska chum salmon, that we would see, and I think this is a very difficult task to try to figure out the effects of a combination of alternatives, but that we would see this kind of a analysis or basis of your summary slides on the potential for Western Alaska chum bycatch reductions under the combination of alternatives, not total chum. Is that, I'm just wondering if that's something you've thought about or something that we need to focus on.
Thank you, Ms. Kimball, for the question through the chair. Yes, we certainly did think about that, given the purpose and needs statement for this action. I think there's a lot of uncertainty in the way that these alternatives and their design structure and the incentives that they create and their ability to for the analysis to have certainty in the potential outcomes for Western Alaska chum salmon. So that's why we try to focus on different scenarios and depending on the alternative that we're focusing on, so be it hard caps or in-season corridors or the different measures for the IPAs to respond to, the scenarios that are more likely to create those outcomes, positive outcomes that would be in line with the purpose and needs statement. But apart from the AEQ estimates for alternatives 2 and 3, we don't have specific numbers for alternative 4 and for alternative 5, and so it's just a different comparison that we're doing there. We could look into doing that in the future, but the granularity that we're able to provide, we did so earlier in the presentation, so I think we just decided to focus on the concepts rather than specific numbers.
Follow up. Thank you for that explanation, Dr. Hepla. I do just think it maybe lends to a little bit of inconsistency in the final conclusions, given that, especially under alternatives 2 and 3, there were some, pretty strong statements that we may be saving chum, but not Western Alaska chum. So when we move that conclusion into a combination of alternatives, I think I'm losing that consistency with your original conclusion in the RIR. So maybe I'll give that some more thought and just see if we can talk about that a little bit more as we go through the day. Thank you.
Okay, so this slide is going to walk through the different PSC trade-offs. So we're now going to think about how the alternatives could work together to create different or uncertain outcomes for the PSC species mentioned previously in the presentation and of primary focus in the analysis. So there are existing PSC limits for Chinook and herring, and alternatives 2, 3, and 5 within this current action include different PSC limits for chum salmon. So the analysis is very focused on the potential impacts of layering on new alternatives for chum salmon bycatch management. And we outlined several different behavioral responses, and we've also covered those earlier in the presentation in terms of vessels responding to a hard cap or an in-season corridor cap by moving to new areas, using more test tows, slowing down the pace of fishing, or even having a cooperative issue a stand down, or as discussed earlier in the presentation, perhaps delaying the start of the B season fishery. Certainly all of these would have associated costs that may limit fishermen's ability to stay below the chum salmon PSC limits, as Ms. Marinan has already mentioned. But there's also potential for these behavior changes that they would be implemented in response to a chum salmon cap to have adverse outcomes on Chinook and herring. So we've discussed earlier that the timing of chum and Chinook salmon encounters during the B season are dissimilar. So should the strategies that are used to avoid chum salmon from June to August, which is also the time of the B season when Western Alaska chum salmon are more likely to be encountered on the fishing grounds, divert pollock catch to the later months in the B season, the analysis expects that there would be an increased likelihood for Chinook salmon bycatch to increase. And the outcomes for other PSC species like herring would depend on the fleet's ability to move and respond to new measures for chum salmon. And we expect that those kinds of decisions would be made on a season-by-season basis and reflect market conditions, environmental conditions, operational constraints that are posing themselves on a yearly basis. And so one of the other mentions that I wanted to circle back to, and we talked about this with the AP a little bit yesterday, is the potential for alternatives 2, 3, or 5 to have an impact on the Chinook incentives under the IPAs. So one of the items that we had talked about with the AP yesterday, and I believe it was mentioned earlier in the presentation this morning with the council, are the different incentives that the IPAs create for Chinook salmon avoidance. And so one of the specific incentives is the Chinook priority, so describing how the IPAs, the Chinook salmon bycatch in October is not increased from earlier months or weeks in the B season. And so the way the IPAs respond to that is by implementing a Chinook priority provision for the rolling hotspot system. And so it's a threshold. And if Chinook salmon bycatch rates increase past that threshold, the IPAs prioritize Chinook avoidance as compared to chum salmon avoidance on the fishing grounds. And so one of the scenarios that we had pointed out was that if you are thinking about the wave of pollock and that catch being diverted to later weeks in the B season and there's a greater amount of pollock harvest that's left, when the rates have been very high, you could end up in a situation where the fleet is facing an increased movement scenario in response to that Chinook priority provision under the IPAs. But the reason that the diverted catch is there is because they were responding earlier in the bee season to chum and Western Alaska chum salmon. So if there's a hard cap or the in-season corridors and that kind of avoidance. So these are the types of different scenarios and trade-offs that we had considered in the analysis with respect to Chinook and herring. And I'll see if there's questions.
Not seeing any at the moment, but I have one. So I really like this graphic. I think it's really useful. Actually, I think it's applicable more broadly than just this action. But it left me wondering, do you have any sense of what a similar graphic would look like if you had degree of constraint on the horizontal axis, but on the vertical axis, you had potential for desired outcomes? I doubt it's as neat as this, but I just was wondering if you thought about that.
Thank you, Mr. Twight, for the question. I don't think I've thought about that specific change, and I think I would have to, with more direction about specific aspects of the purpose and need statement, to feel confident in drawing some conclusions with that. But I take your point in terms of trying to think about other ways of conceptualizing important concepts to the action.
Floor is yours.
Okay. So moving on to management monitoring enforcement, this was a section that was provided by NIMS. We just have 3 slides here. And they kind of cover how NIMS monitors, manages, and enforces the existing Chinook and chum salmon bycatch management measures. And the takeaway for these 3 slides is that under the action alternatives that are being considered, although NIMS would need to modify regulations in order to include the PSC limits or corridor caps or whatever was chosen, there wouldn't need to be any new tools or substantive management changes in its approach for management monitoring enforcement. So under monitoring, just a reminder, under status quo, alternative 1, NIMS has a comprehensive salmon bycatch monitoring program in the pollock fishery. In this fishery, all catcher vessels must have observers on board or participate in the electronic monitoring program, EM. If they participate in EM, cameras record all hauls to ensure that no fish are discarded before being counted by observers at the processing facilities. And in 2025, every catcher vessel in the Bering Sea pollock fishery has chosen to participate in the EM program. All catcher processors and mothership vessels have 2 observers on board. These observers count all salmon as the catch is being processed, and the observers take the samples from some of the bycaught salmon, which are sent to the Alaska Fishery Science Center for genetic testing. The results are shared in the annual genetics reports that Alaska Fishery Science Center provides to the council, which, among other things, estimate the proportion of chum salmon bycatch in the genetic reporting group. So as we've seen some of that information presented today. If the council were to adopt any of the 4 action alternatives, no changes to NIMS' comprehensive approach to monitoring salmon would be necessary. Similarly, if the council were to recommend the adoption of alternative 2 through 5 or a combination of them, no changes would be needed to NIMS's existing management tools. And I think this is especially because there are already PSC limits for Chinook, so NIMS would likely take a similar approach for these different aspects. I'm not going to walk through the whole table, but for example, for apportioning PSC limits, because there are PSC limits for Chinook, these practices already take place with NIMS, and they would use a similar approach. For monitoring PSC limits, approving the IPAs, this is the same process as described in regulations. Applying the PSC limits during low abundance, that would be relative to alternative 3. And approving PSC transfers. This is similar to how things are currently monitored and managed for Chinook. So as with Chinook salmon, if the council were to adopt a PSC limit under alternative 2 or 3 or 5, NIPS would notify NOAA's Office of Law Enforcement, OLE, when a sector, CDQ group, or cooperative exceeds its apportionment of chum salmon PSC and may no longer continue to fish. So the OLE would use its existing tools to monitor the vessels within that sector, investigate potential violations, and if appropriate, apply the applicable remedy, which could include a citation, penalty, vessel and catch forfeiture, or criminal prosecution.
Thank you, Dr. Hopala and Ms. Marinan. I think we are right at noon. I think that there are some members who may have some conflicts during lunch, so this might be a good place to break and come back. I think there'll be a few questions on timeline. So we'll break for lunch. We'll come back at 1:15, and we'll take the final slides and then the SSC report following that. And just a notice to members of the public, we will likely start public testimony, probably take a limited amount before the end of the day. I'm gonna check in with the AP, see where they're at with timing as far as their motion and finishing up public testimony. And we'll make a determination about what time we're closing public testimony sign up after lunch. So thank you. Council members, please come back to order. So we have a couple more slides on our main presentation on C2, and then we will go into our four additional shorter presentations and then our SSC report. So, thank you.
Madam Chair, members of the council, Kate Hoppola with council staff, and yes, we'll just wrap up the last bit of the presentation here on the preliminary DEIS under C2.
And Dr. Hoppola, I just forgot to make an announcement. I said I was going to notice the public on when we were going to be closing public testimony. So that'll, our signups will be closing at 5 p.m. today for agenda item C2. So if you wish to testify, please sign up by 5 p.m. today. Thank you.
Okay, so just a brief reminder for the council on the action under the C2 agenda item at this meeting. So here in February, the council may decide whether it would like to modify the current range of action alternatives, and if so, how. Whether to request additional analytical review through another council meeting, or whether to recommend the analysis be released for publication by NIMS as the draft EIS. The council can recommend publication whether the alternatives are modified or not. And then we did pull together a couple of different resources for you in the executive summary that provides a comparison of the alternative, each alternative, as well as some additional points for consideration and what is needed to further develop the alternatives, especially looking forward to potential final action. So this slide provides two different timelines for the proposed action that are also included in the action memo. Ultimately, the timing of how the Bering Sea chum salmon bycatch action moves forward is going to depend on whether the council recommends the analysis presented at this meeting be revised based on input and released for publication as a draft EIS by the agency, or if there will be a request for additional review. These are all tentative milestones, but the key points are really the milestones themselves and the time in between them. So on the left, this timeline shows you what could be expected in terms of the timing moving forward based upon a recommendation at this meeting that the document be finalized and published, with final action being scheduled for December 2025. So if that were to be the case, Ms. Marinan, myself, and other staff would be working to make any revisions required and to get the document to NIMS prior to August 15th, but with that being the publication timeline. And the figure on the right is based upon a request for additional review. So this would clearly delay publication of the draft EIS as well as final action. So that is one primary trade-off for the council and its consideration, is just, yeah, these two different points within the timeline. And staff would expect that if additional review is required or requested, that would be scheduled for October 2025 later this year. I'll just pause for questions.
Ms. Goen.
Thank you. Thank you for this timeline. Can you speak to why on the right that the council wouldn't take final action till October 2026? Is there an option to do that at the June meeting? And does that help with the timeline?
Thank you, Ms. Goen, for the question through the chair. So the reason we didn't consider the June 2026 meeting is because it's located in Vancouver, Washington, and we often receive testimony that June is just not a good fit for Western and Interior Alaska subsistence users. And then also just the additional travel requirements of getting down to Vancouver would be more of a burden. So that's why we weren't looking at June.
Yes, and Ms. Kimball.
Thank you, Madam Chair. And Dr. Hoppola, did you say on the schedule on the left, if the council chose to make changes to alternatives and release the preliminary draft EIS, we could do that at this meeting without selecting a preliminary preferred alternative? I just want to clarify that point.
Through the chair, yes, Ms. Kimball, that's correct. There's no requirement for a preliminary preferred alternative to be selected prior to publication.
Yes, and Mr. Witherell.
Just to clarify, Dr. Hopla, that if the council makes significant changes to the alternatives, though, wouldn't that require additional time for analysis before it gets published? And thus, we probably wouldn't be following the schedule necessarily.
Thank you, Mr. Witherell, for the question. That's possible. It would depend on the scope of the changes and the analytical workload that is required in order to meet those changes and requests. So we would be trying to keep all of the different milestones in line and what the council's priorities are, but substantial changes, especially if there were new methodologies or things like that, yes, could take more time. Okay, so this is just a reminder of the remaining components of the C2 agenda item. So right now we are concluding and at the end of the preliminary draft environmental impact statement portion of the presentation. What follows next is a series of short and supplemental presentations that provide additional information and context that the council may find helpful for deliberations on this issue. They're listed in order here on the slide for you. The Tribal Engagement Report has been prepared by the National Marine Fisheries Service. It provides a summary of comments shared with the agency during tribal engagement, as well as government-to-government tribal consultation meetings. The appendices prepared by cooperating agencies, appendices 7, 8, and 8 will be provided with two separate presentations. The Kuskokwim River Intertribal Fish Commission and the Tanana Chiefs Conference were named as cooperating agencies to the National Marine Fisheries Service and providing special expertise related to salmon fisheries on the Kuskokwim and Yukon rivers, as well as their tributaries, along with salmon life cycles, subsistence, and commercial fisheries in the area, and regionally specific local and traditional knowledge. Some of this material has been referenced and integrated into the main DEIS conclusions and presentation provided to you today. NMFS has provided an opportunity for these cooperating agencies to author and include verbatim appendices as part of the preliminary draft EIS, and the council has agreed to provide space for short presentations on the material that council staff have not already covered in the presentation. And following that, you will receive a report on genetic stock composition information for the 2024 Bering Sea Chum Salmon Bycatch Genetics. This will be provided by Dr. Patrick Berry. And this will just be more of a high-level focus on some key trends for the most recent year to try and keep that presentation short for the council. And with that, Ms. Marin and I are always happy to take any questions.
Thank you both. Let's see if there are any questions. Yes, Ms. Kimball.
Thank you, Madam Chair. And maybe it's for Mr. Curlin. I just, prior to getting into the next set of presentations, wanted to understand the, because I don't think the council's really a part of that, the role of the cooperating agencies and what role the agency or our staff had in the appendices that are being provided by the two cooperating agencies. Is that something you can share with the council, how that process works? It's not something we do all the time. Thanks.
Yeah, thanks, Madam Chair, Ms. Kimball. So let me start at kind of a high level. A cooperating agency's role in helping to prepare an EIS is clearly defined by NEPA regulations, and in this case, by the cooperating agency agreements that we have. And that's separate agreements between NMFS and the Kuskokwim River Intertribal Fish Commission, NMFS and the Tanana Chiefs Conference, and also NMFS and the Alaska Department of Fish and Game. Our cooperating agency agreements with each of those entities focus on those organizations' contribution of material within their areas of special expertise for development of the EIS, and the cooperating agency agreements don't address presentations to the council or its advisory bodies because that's council process. That's not directly related to producing the NEPA analysis. NMFS is responsible under NEPA for preparation of the EIS, and as regional administrator, I'm the responsible official for making sure the EIS meets all applicable requirements. For this EIS, I saw real value in including each of the cooperating agencies for expertise that they could bring to bear on this process and help us do a real comprehensive job in the EIS. With regard to the appendices, we decided not to be prescriptive regarding the contents of appendices 7 and 8. So not filtering the content, allowing the Kuskokwim Intertribal Fish Commission and TCC to essentially say whatever they wanted to characterize the community's reliance on salmon, importance of subsistence practices, all of that. We felt that it was really best to not try to filter that, not take their input and synthesize it and summarize it in the EIS, but that was the reason for having those be essentially standalone appendices. So some of that information is captured or referenced in the body of the EIS, but that's the reason we have these separate appendices. The regulations and cooperating agency agreements do not address how cooperating agencies might participate in a council process. And maybe we should have addressed the council process and presentations as part of the cooperating agency agreements. This is new for us. We haven't done this before. So that might be something to consider for the future. But the agreements that we arrived at did not address those subjects. So, just acknowledging that this gets a little complicated, maybe messy, because the Kuskokwim Intertribal Fish Commission and Tanana Chiefs Conference have dual roles here. They are cooperating agencies for providing information where they have specialized expertise, but they are also participants in the council process who are seeking specific outcomes from the council. So, again, this is kind of new territory for the council and for NIMS in how we navigate this. I think it's really up to the council to determine how to integrate, how or whether to integrate cooperating agency presentations in a council meeting. And Mr. Witherell and I collaborated on some guidance that we provided to those two entities regarding the scope of their presentations. And, essentially just pointing out that council staff, agency staff go to great lengths to be really objective in their presentations to the council and providing analysis without editorializing or advocating for a particular outcome or position, and encouraging both the Kuskokwim River Intertribal Fish Commission and Tanana Chiefs Conference to likewise present their information objectively, and also encouraging them for the advocacy portion, do it, bring it, but do it during public testimony, not during the staff presentations. So if they want to, and they should, advocate for particular outcomes, alternatives, criticize parts of the analysis, any of that, that would be appropriate during public testimony and rather than during the staff presentations. So sorry, that was a bit of a long answer, but I hope that addresses the question.
It does. Thank you. I really wasn't as focused on the presentations as the content and what was being asked of the cooperating agencies, but I appreciate the explanation. Thank you.
Thank you very much, Mr. Curlin. And Ms. Gahn.
Yeah, thank you, Madam Chair. And just a follow up to that question for Mr. Curlin, can you explain a little bit further how the cooperating agencies were involved or not in reviewing the draft analysis then? I understood the appendix part, but for the draft analysis, were they involved in reviewing that?
Madam Chair, Ms. Goen, to be honest, I don't know. I'd probably look to Ms. Happela and Ms. Marinan as coordinators for the EIS to talk about how other team members were involved in review of pieces.
Through the chair, Ms. Goen, so for this iteration of the analysis coming out of the April 2024 meeting, coming out of any council meeting, we end up going through what's called an action planning process where we basically retool and redesign what the analysis needs to cover based on the input that we received at that meeting and whether or not any changes to the alternatives are made. So we worked with cooperating agencies to figure out different sections and components of the analysis that they would like to contribute to or where their expertise fit within. And so in terms of your specific question about review, they had identified ADF&G as well, specific contributions that they could make and wanted to make and were interested in. And so we had gone, after receiving their submissions for the main content of the DEIS or within the text that is also authored by staff, conversations, and I guess just making sure the documents align. There's some aspects of this I'm not really sure what you're looking for and how far into the writing process that you're interested in going, but it's more of a collaborative piece at that point, once we know what it is that they would like to make contributions on and going back and forth from there.
Thank you, Dr. Hapala.
Yeah, thank you for that. I was just trying to get a better understanding because it seems like it's new territory and working with cooperating agencies, so better understanding the layers of how that worked. So thank you.
Okay. Thank you both. Not seeing any further questions. Really appreciate your work on the presentation and all of your work on this analysis. Thanks. So our next, we have, as staff shared, we have 4 additional presentations. All of them are scheduled to be relatively short. So I would ask council members to hold questions until the end to make sure that we're intaking all of the slides and getting a full presentation. And then we'll please write down your questions and we'll take them at the end of each. Thanks. So I think Doug Shaftel is next. Thank you.
Good afternoon, Madam Chair, members of the council. Doug Shaftel, Fisheries Management Specialist with NOAA National Marine Fisheries Service based out of NIMS Anchorage office. For this action, my role includes tracking its development through the council process and supporting council staff with their analysis and eventually leading NIMS review and implementation of any management measures that the council should recommend. I'm also responsible for supporting NIMS tribal engagement consultation and am here to provide a summary of NIMS tribal engagement consultation on this action, a written version of which you can find at section 1.3 of the preliminary draft environmental impact statement. This summary of NIMS tribal engagement and consultation efforts, however, does not cover the council's additional tribal outreach. So NIMS tribal engagement and consultation on chum salmon bycatch began in early of 2022. Before the council conducted its June 2022 council meeting at which the council formed the Salmon Bycatch Committee. Since then, in addition to the tribal input received at the 5 council meetings on this action, NIMS has received input on chum salmon bycatch in the Bering Sea pollock fishery at 6 tribal engagement sessions and 4 tribal consultations. In addition, last summer, NIMS invited submissions of information and traditional knowledge on the proposed alternatives from all tribes. And in response, NIMS received 2 letters. One from the Yukon River Intertribal Fish Commission and another from 6 tribal coalitions and organizations that collectively serve dozens of Western and Interior Alaska tribes. The Yukon River Intertribal Fish Commission letter contains information on the historic context of commercial fisheries and salmon declines within the Yukon River system. The tribal coalitions noted in their letter perceived limitations in the current analysis, including the use of an impact rate. They also provided feedback on the current set of alternatives. These letters can be reviewed in their entirety in Appendix 1, starting at page 33. Now, since March of 2024, NMFS began holding a tribal engagement session prior to every council meeting for the purpose of providing information on agenda items that may affect tribal interests. And most recently for this council meeting, NMFS conducted a tribal engagement session on February 14th, at which NMFS provided a brief overview of the preliminary draft environmental impact statement, and council and NMFS staff fielded questions about the action. In light of the substantial interest from tribes and based on feedback from certain tribal coalitions, NMFS also conducted a tribal consultation on this action on February 21st, 2024, which was open to all tribes. NMFS would like to share some of the perspectives that have been expressed during these tribal consultation and engagement sessions. However, I'd like to start by saying that NMFS is not authorized to speak on behalf of any of these tribes, nor is the following intended to be an endorsement of any particular viewpoint. And given the time constraints, this does not include all the viewpoints and perspectives that NMFS has heard. There indeed are, a wide range of perspectives that have been expressed to NMFS and the council over the course of these, that were expressed to NMFS over the course of these engagement and consultation sessions. And this is not intended to be a substitute for the input of tribal representatives at this council meeting. We expect that many, if not all, of these points may be reiterated and refined during public testimony. With that said, ideas and concerns that individuals and tribes have expressed in NMFS include the following. With regard to alternative 1, as in prior council meeting testimony, NMFS heard about how salmon declines have affected tribal culture, traditions, spiritual connections to salmon, the ability to pass on a way of life to younger generations, individual and community well-being, and food security and sovereignty. Tribes have expressed a desire for a sharing in the burden of conservation. They've said that there are feelings of inequity when tribal, commercial, and subsistence fisheries are closed or severely limited, and the Bering Sea pollock fishery continues. The tribes have expressed in these engagement and consultation sessions that salmon bycatch is a form of waste, in conflict with the tribal traditions and historic practices with respect to making use of salmon, which many consider a sentient species that makes itself available for catch only when harvest is properly conducted. We've heard that frustration about the multiple jurisdictions managing salmon in marine and freshwater habitats, that is the National Marine Fisheries Service, the state of Alaska, and the U.S. Fish and Wildlife Service. And the tribes have expressed that regardless of whether reducing bycatch in the Bering Sea pollock fishery increases the likelihood of subsistence harvest opportunity in a given year, there are other benefits to consider, such as the cumulative benefits to stock productivity, potential benefits to genetic diversity in times of low abundance, and increased nutrients for ecosystems. Tribes have also expressed that even slightly increased numbers of returning salmon may have benefits to tribal food security and sovereignty. With respect to alternative 2, tribes at these engagement and consultation sessions and in writing have expressed that the PSC limits at the higher end of the range being analyzed need to be reduced to closer to the average that industry has achieved since 2011. And with regard to the PSC limits currently under consideration, these tribes have expressed that it needs to be set well below the historic average and preferably at the lowest end of the range under consideration here. In other words, 100,000 chum salmon. With respect to alternative 3, the tribal coalitions in their October 4th letter expressed that they feel that an abundance threshold set at the 50th percentile remains too low. These coalitions also expressed a preference for option 1 and alternative 3, the Three River Index, over option 2, the Yukon River Index. However, in their October 4th letter, the Yukon River Intertribal Fish Commission expressed that the Three River Index has inherent flaws in reflecting abundance in such a large area of Alaska. With respect to alternative 4, tribes have expressed general concerns about industry's role in management of the rolling hotspot system. However, some have also expressed an interest in combining provisions of alternative 4 with other alternatives. And with respect to alternative 5, these tribes have expressed that the range of PSC limits under consideration are too high and do not achieve the purpose of a conservation corridor, and that the council should consider combining clusters 1 and 2 into a larger area for potential closures. Specifically with regard to the coalition's letter of October 4th, 2024, the 6 tribal coalitions said that they see potential promise in an alternative that includes the following elements. An overall an overall prohibited species catch limit that would be well below the historic average. IPA modifications that encourage working towards genetic testing to identify whack chum salmon in season. A conservation corridor that includes both clusters 1 and 2, and a program review after a certain number of years or metrics that have failed to be achieved. They've also expressed an interest in investigating a framework that could facilitate implementation of real-time genetics without further environmental review. They specifically requested that such a combination of alternatives be analyzed. Now, as has just been discussed, there are 2 cooperating agencies on this action, the Kuskokwim River Intertribal Fish Commission and Tanana Chiefs Conference. And since the April 2024 council meeting, NMFS has facilitated 4 joint cooperating agency meetings between the Alaska Department of Fish and Game, the Fish Commission, Tanana Chiefs Conference, and council staff. And these meetings have been, the focus of these meetings has been on facilitating contributions from the cooperating agencies that fall within their respective areas of special expertise. As a result of the effort of these cooperating agencies and council staff, this version of the preliminary draft environmental statement does include new information and knowledge in the following sections of the document. In addition, again, as has been discussed, Tanana Chiefs Conference and the Fish Commission have drafted standalone contributions, which you'll find in appendices 7 and 8. Now, NMFS tribal engagement and consultation efforts will continue beyond this council meeting. To engage with additional communities and salmon users, NMFS intends to attend at least one of the regional advisory councils to the Federal Subsistence Board, and that will likely be the Yukon Kuskokwim Delta RAC meeting in Bethel on March 4th to 5th. And should the council recommend that NMFS publish the draft environmental impact statement after publication in the Federal Register and during the public comment period, NMFS will hold additional tribal engagement and consultation sessions. There will also be tribal engagement and consultation opportunities as NMFS engages in the rulemaking and implementation of a management alternative. Finally, NMFS will work to accommodate all additional requests for tribal consultation that it receives. Now, NMFS would like to thank all who participated in their engagement and consultation sessions for the time and information that they have brought. Throughout this action, NMFS has received constructive feedback on its tribal engagement and consultation processes from participants and continues to learn from that feedback and make improvements. Again, for further information on NMFS tribal engagement and consultation, please see Chapter 1.3 of the preliminary draft environmental impact statement. I'd be happy to take any questions.
Thank you very much for your presentation, Mr. Sheftel. And looks like we have a couple questions. Ms. Baker?
Thank you, Madam Chair. Thank you, Mr. Sheftel. And I just wanted to, I appreciate that your presentation focuses on tribal engagement, but I just, back on your slide 5, I think as you were presenting that, I believe you referred to the cooperating agencies for this action. And while you're absolutely correct and focusing on the 2 tribal organizations that are cooperating entities, I just wanted to clarify there are actually 3 cooperating agencies on this action for the council. In addition to the 2 tribal organizations, the Alaska Department of Fish and Game is also a cooperating agency, although we are not providing a separate presentation today. Just wanted to clarify that.
Through the chair, Ms. Baker, thank you so much for that clarification. And I apologize if I misspoke at the beginning of my presentation, limiting it to suggesting there was only 2 cooperating agencies. Indeed, Alaska Department of Fish and Game is also a cooperating agency on this action.
Thank you. And Mr. Ritchie?
Thank you, Madam Chair, and thank you for the report. On slide 4, I'm looking at the last bullet point. It says program review after a certain number of years or metrics that have failed to be achieved. And I'm wondering if there were any examples of the metrics that they're looking for, or ways to measure success here, I guess is the way I'm thinking of it. If there were any examples provided.
Through the chair, Mr. Ricci, thank you for the question. that bullet point came directly from the letter of October 4th, the coalition letter that you'll find in the Appendix 1. To my memory, no specific examples were provided.
Thank you. And Mr. Twite.
Thanks, Madam Chair. Thanks, Mr. Sheftel. Also on slide 4, when you were describing interest in continuing to incorporate genetic information into in-season management, you said that there's this sort of a stipulation that if that could occur without further environmental review. I was trying to parse what those words meant. And I thought rather than trying to do it myself, I might just ask you.
Through the chair, Mr. Twite, thank you for the question. I'm in it's a bit difficult for me to put myself in the position of the authors of the letter that and what their intent was, but that extra point that I was referring to about having a framework going forward that would facilitate incorporation of real-time genetic information without further environmental review. My understanding of what that idea would look like is some sort of frameworking that would happen here at the council that would allow for the incorporation of genetic review in any management action that's adopted at this time without having to go back through the environmental impact statement process. The authors of the letter were not specific. They used the term frameworking. I'm not sure that's even I'm not sure what their intent is when they use that term frameworking. I'm sure members of the council have a better understanding of it than I do as to what that could look like. But yeah, that's the extent of the information that I have for you.
Any further questions from council members? Okay. Thank you very much, Mr. Sheftel.
Thank you.
Thanks. So our next presenter is Therese Vincente.
Thank you. Good afternoon, Madam Chair, members of the council. My name is Therese Vicente. I'm the Policy and Programs Director for the Kuskokwim River Intertribal Fish Commission. And I'm presenting today on Appendix 7 to the preliminary DEIS, which, as Mr. Curlin just noted, the Fish Commission contributed to this analysis to provide additional information from a tribal perspective about the role of chum salmon in Kuskokwim communities and ecologies, as well as understandings and traditional knowledge of chum salmon declines, including through cumulative impacts to salmon for our cooperating agency special expertise. I also do want to give a nod to Appendix 9, which includes the DEIS submissions co-authored by the Kuskokwim Fish Commission and Tanana Chiefs Conference as cooperating agencies in their original form. And I encourage the council to look at those to see the knowledge and information put forward by our entities. Starting with Section 3 of Appendix 7 to first introduce the people of the Kuskokwim region. Indigenous communities of the Kuskokwim and Yukon can trace their roots back at least 11,000 years, or back to 9,000 BC. There is archaeological evidence of Kuskokwim harvest and use of salmon dating back 800 years, but oral tradition goes back much further. Over these generations, Indigenous people have developed a stewardship relationship with salmon, involving careful and respectful harvest, preparation, eating, and celebration of these fish. There are 4 major ethno-linguistic communities in our region, the Yup'ik, Degaton, Dena'ina, and Upper Kuskokwim Athabaskan. And each of these larger communities has a distinct language, as well as a distinct name for chum salmon. And those are listed here in this table, which is Table 1 from our Appendix 7, alongside the Western Scientific and Common English names used along our river. And it's important to show these names for chum because having a name for something signifies being in relationship with it or having knowledge about it. These long-lasting multi-generational ties to salmon continue in our region today, and the Federal Subsistence Board's Office of Subsistence Management has identified 40 federally recognized tribal nations with cultural and traditional ties to salmon in the Kuskokwim drainage. Those are named here on this slide, and I will note that the Kuskokwim River Intertribal Fish Commission works to represent 33 of those nations in fisheries co-management, research, and monitoring. Appendix 7.2 discusses how salmon are key for the Kuskokwim ecosystem as they provide a linkage between the ocean and freshwater environments, in many ways tying together the 700 plus miles of the Kuskokwim. Historically, chum salmon were one of, if not the most abundant and reliable species of salmon on the Kuskokwim. And Appendix 7 looks specifically at the Aniak River, which is a tributary in the middle Kuskokwim, known by traditional and local knowledge holders for long teeming with chum salmon. It's known for its stink in the fall time as hundreds of thousands of spawned out chum line the gravel bars, providing nutrients to predators and plants in the river valley ecosystem. For 30 years, the Department of Fish and Game ran a sonar at the mouth of the Aniak River. On average, that sonar counted 400,000 chum per year. That's between 1980 and 2010. And while there's no drainage-wide run reconstruction for Kuskokwim chum, considering these returns to a single tributary, as well as spawner counts in other tributaries, on top of subsistence and commercial harvests, as well as local and traditional knowledge about run abundance, annual chum salmon returns to the entire Kuskokwim may have averaged around 1 million fish. However, this is no longer the case as chum abundance has declined dramatically in 2021, as noted as well in the DEIS, and it's remained well below historic levels. And the figure at the right shows assessments from 3 projects throughout the Kuskokwim drainage. Those are the sonar, the George River Weir, and the Kogrugluk River Weir, and all of these track this chum salmon decline. Appendix 7 also provides some additional traditional knowledge about chum salmon to complement that found in the DEIS. And in summary here, traditional knowledge from our Kuskokwim region shares how chum are holistically important for the Kuskokwim way of life. They provide food for humans and dog teams, as well as waterproof clothing and materials. They are incredibly important at fish camp, as many young fish cutters learn to first use their uloks and fillet fish on chum salmon before they are allowed to move on to processing king salmon and other salmon. And I want to flag this quote from a knowledge holder found on the right of the slide, which is in our appendix, because I think it poignantly points out the role of chum for people in our region. Jonathan Samuelson shares that the word for food in Yupik is naka, and that's also the word for fish. And he says, if naka is not how you view fish, then we come from different worlds, and that the people of the Kuskokwim wouldn't exist without salmon. We exist, salmon and people. Importantly, chum and all salmon are meant to be shared and not to be wasted. These are the key teachings shared by traditional knowledge holders in our region. And Appendix 7 also notes additional traditional knowledge about the causes of salmon declines, including those of chum. These include wasting fish through bycatch, which is the breaking of one of the key teachings. And other knowledge about causes of decline are noted here on this slide. But in summary, declines of chum and other salmon are having widespread, profound impacts to food security, physical and mental health, cultures and traditions passed on through thousands of generations, spirituality, economic security, and holistic well-being of the people of the Kuskokwim. And this is tied to the health and biodiversity of the ecosystem because people's well-being and ways of life are interconnected with the ecosystem around them. Appendix 7.4b looks at subsistence fisheries on the Kuskokwim. These figures in our analysis show that across the Fish Commission's governance units, which span the entirety of our watershed, and as well as in all subsistence households, chum salmon subsistence harvests have declined. Amounts reasonably necessary for subsistence, or ANS, have not been met since 2019. And in 2022, households in 4 communities reported harvests of 0 chum salmon. And we've noted the census data used to calculate this information at the bottom left of this slide as a reference of the number of people and households in the region in 1990 and then again in 2023, spanning the time series here. Section 5 of Appendix 7 discusses cumulative factors contributing to chum salmon declines and knowledge of those from the Kuskokwim region. And this figure from our appendix outlines many of the likely drivers of decline, including environmental drivers, many of which are themselves driven by climate change. However, it also includes anthropogenic drivers contributing to declines, and these are the ones that Section 5 focuses on because they can be readily controlled with human and management intervention, including through the action before the council. So Section 7.5A looks at how Bering Sea bycatch, including by the pollock trawl fleet, and South Alaska Peninsula, or otherwise known as Area M, salmon intercept, are contributors to Kuskokwim salmon declines. And from a tribal perspective, the impacts of these fisheries cannot be siloed from one another because they are connected by the Gulf of Alaska to Bering Sea migration patterns of Kuskokwim chum salmon, as illustrated by this figure. Traditional knowledge holders share how the disjointed management of salmon between this council and the Board of Fish also contributes to chum salmon declines and fails to conserve and rebuild salmon stocks. And on this slide, the figure on the left shows coastal Western Alaska chum bycatch, and I will note it's specifically coastal Western Alaska because the upper and middle Yukon genetic stock group is not bound for the Kuskokwim region. So this shows CWAC chum bycatch in light blue as part of total chum bycatch compared with Kuskokwim subsistence harvest between 2011 and 2023. This information may provide insight to how the higher CWAC bycatch estimated for 2016 and 2017 may be linked to declining Kuskokwim subsistence chum salmon harvest in subsequent years, as well as how high levels of CWAC salmon bycatch relative to subsistence salmon harvest prevailed in recent years, especially in 2021 and 2022. The bycatch of any Kuskokwim chum salmon during this depressed period is likely to affect the viability of stocks. And then on the right, we have a figure showing the potential contributions of CWAC chum in June Area M fisheries. This data is from the 2007 to 2009 WASIP study, as well as new studies underway by the Department of Fish and Game. And we show here that coastal Western Alaska stocks annually have composed during this 1980 to 2024 time series with the data we have available between 18 to 57% of June Area M chum harvests. So evaluating these stock proportions, the Fish Commission estimates between 3.6 million and 8.7 million coastal Western Alaska chum have been taken by the Area M June fishery since 1980. These kind of removals accumulate over decades, affecting the way salmon can develop intergenerational climate resilience, rebuild stock abundance, and support fisheries. Moreover, during low abundance, the impact of removals increases such that they have high relative impacts on salmon, and especially on discrete spawning populations. These are tributary stocks with distinct genetics due to spatial adaptation that contribute to the genetic diversity of a watershed. This figure 18 from Appendix 7 illustrates how sustained levels of chum salmon removals have greater negative impacts to discrete spawning populations at times of low abundance. When abundance of all populations is high and removals are low, like in scenario 1 on the left of this figure, it is more likely to find many discrete spawning populations in tributaries throughout a watershed. However, when abundance is low and removals remain the same or increase, as shown in scenario 3 on the right, they may impact those discrete spawning populations to a higher degree with bigger risks to genetic diversity of salmon in a watershed. During a scenario like that, both Western and Indigenous science indicate that every fish that is able to return to a river to spawn becomes exponentially more important. Other cumulative factors contributing to salmon declines in the Kuskokwim include impacts of trawl fisheries on the food webs and habitat that salmon depend on. As Section 7.5b explains, because the Kuskokwim freshwater ecosystem is connected to the Bering Sea, these impacts ripple up into interior Alaska where our headwaters are. So for example, traditional knowledge holders and hunters in the headwaters of our river are seeing fewer moose in their area because bears that are hungry for salmon are now targeting young moose, driving down those populations. Other knowledge holders are noticing how whitefish and trout abundance in some tributaries declined after chum did in 2021, making it plausible that those species are linked. Knowledge shared by Kuskokwim fishers notes that reducing bycatch will help rebalance these ecosystems, and reducing bycatch such that there may be fleet standouts could provide additional benefits to stock restoration by reducing net and water time to cause fewer effects to interconnected ecosystems, as well as to build equity into bearing the burden of conservation across user groups. And another driver cumulatively impacting salmon, discussed in Appendix 7.5D, is the erasure of indigenous stewards and loss of traditional ways of life. Colonial fishery management systems have disrupted indigenous stewardship practices and erased indigenous peoples, knowledge systems, and values from the work of caring for salmon. This section of Appendix 7 discusses how inequitable representation of these people, this knowledge, and these values perpetuates, declines, and goes against best management practices and policies for fisheries. And some of the conflicting values and priorities of Indigenous stewardship and Western management discussed in Section 7.5D are listed in this table. Notably, while Indigenous stewardship focuses on balancing communal harvests with ecosystem services as guided by the values of sharing, taking only what is needed, avoiding all waste, and respecting all life, Western management systems value maximum sustainable yield and optimum yield and prioritize the maximum harvest and profit for industry. And our analysis in Appendix 7 discusses how collaborative gravel-to-gravel salmon management with tribes can help alleviate this factor and restore salmon through an ecosystem-wide stewardship approach. And with that, I just want to say, Koyana, Dogadin, Janan, Jinan, thank you. And there are some additional slides in the rest of this slide deck following. They just have information we shared with the AP, but they're here for your reference at the end of our presentation.
Thank you very much for the presentation. See if there are any questions. Yes, Mr. Blahovedy.
Thank you for the presentation. So it was pretty quick and I was trying to keep up, but the Aniak River is a discrete tributary where chum have spawned and the numbers have gone down. I'm familiar with that river, but I think you just had data up to 2010 on the chart. And so, and you mentioned that there's 400,000 that used to spawn there and even as high as 1 million. But what are the recent numbers like? And then why is it cut off at 2010? And then also, are you getting more traditional knowledge from folks about the effect of that in that local tributary?
Thank you for the question, Mr. Blahovedy, through the chair. The reason for that time series is that the sonar project that was run at the mouth of the Aniak River ended in 2010, but we pulled that information because it was the best project and the best data set showing a full count of abundance of Aniak River chum salmon when they were in a period of abundance. There are other weir projects further up in offshoot tributaries of the Aniak River. I don't have the data in front of me, but one of them, the Salmon Aniak River, has also noted declines of chum salmon. I could find those data if you'd like it. As for traditional knowledge about salmon declines, yes, and we were recently working with some traditional knowledge holders from the region this summer to document their observations of salmon declines. And one in particular mentioned how he's observed rippling out effects to the Aniak River Valley ecosystem, like seeing fewer bears or hungrier bears closer to town. And he attributed those with declines of chum and other salmon that spawn in the Aniak.
Thank you. And Mr. Toit.
Thanks, Madam Chair. Thanks, Ms. Benz. I'm thinking faster than I'm speaking faster than I'm thinking. Anyway, thank you, Ms. Vicente. I'm kind of stuck on slide 8. And because I was trying to think about the point you made on the previous slide about not siloing these two. Trying to think about them sort of holistically. And so I actually probably didn't catch everything you said about slide 8 even. But area M, it's sort of potential contributions. The scale's much larger. I'm used to the Bering Sea bycatch because that's the graphics I see all the time. And I just don't know how to integrate these. I assume you couldn't either, and that's probably part of your point about siloing. But I'm wondering about, first off, how you do look at these two in contrast. And then secondly, what your thoughts are about how one might integrate them in the future.
And I think Mr. Twite's looking at slide 9, actually. So if you could, at least on his computer.
I was mangling. Yes, that's right. Thank you.
Maybe we need a stretch break. Thanks, Mr.
I
Dwight.
need more than that, I think.
Through the chair, I appreciate that question. And I actually might, to answer well, maybe both parts of your question. I think this graphic illustrates how knowledge holders and fishers in the Kuskokwim region perceive these two areas working together, or rather contributing to the removals of chum salmon, because this, I mean, it's simplified, but it shows, the annual summertime migration of chum salmon between the Gulf and the Bering Sea and how they pass through these two fisheries, the Area M fishery, which is directed for salmon, and then the pollock trawl fishery, which incidentally takes salmon. And I think the way that our knowledge holders think about salmon management is in a gravel to gravel perspective. It doesn't consider how, I mean, salmon do not see these boundaries and these different management bodies that have segmented up the oceans, the rivers. We have our own disjointed management within our river that also impacts salmon as well. So I think our knowledge holders look at this in a way of, if we are trying to prioritize the restoration of chum salmon, and if this action is one piece of that puzzle, we really need to be looking at the bigger picture. So Area M may have a larger impact, but with low salmon abundance on our rivers and considering what's within this council's control, we have to look at the pollock trawl piece of the puzzle as well. As for recommendations for blending these, I feel that airs a little bit into public testimony, so I might not give you an answer at this time. Thank you.
Thank you for that. Yes, Ms. Kimball?
Thank you, Ms. Vincente, for the presentation. And I just wanted to ask a little bit more about the figure you highlighted on slide 6 and the likely drivers of Kuskokwim River chum salmon stock collapses. And I haven't seen this particular slide before, but how did you collect these, I guess? Where did this come from? Is it through ongoing work of the commission or surveys or part of the ecosystem status report? I just wanted to get a feel for how this was collected.
Yeah, thank you for the question, Ms. Kimball, and through the chair. A little bit of everything. This figure in our appendix was adapted from one that we first put forward in our 2021 salmon situation report. And I can provide that link to you if you'd like it. But we as an entity, as well as our knowledge holders, look holistically at what is causing salmon declines. And there are certainly environmental drivers, and we recognize those. They're also recognized by the recent Salmon Research Task Force that was put together by Congress, by other entities. The ecosystem status reports discuss those as well. But there are also anthropogenic drivers that can be managed with human intervention. So it's in additional slides here, and we discuss it in our appendix, and I skipped it for the sake of time today, but we do discuss how hatcheries are impacting our chum salmon as well. But that's part of the collective whole, and if one would want to restore chum salmon, one would have to try to address all of these, and the ones that are, within the jurisdiction of this body and perhaps similar management bodies or departments, agencies are the ones that are in that yellow-orange color, the anthropogenic drivers. Does that answer your question?
Thank you. Yes, and I wasn't disputing any of the drivers, but really just how you collect this type of information to come up with this slide. So it sounds like it's a kind of an amalgamation of different sources and pretty recent sources.
Yeah, and I'd say, I mean, it's a mix of both local and traditional knowledge from people on the river, as well as the Western scientific research and understandings that we bring, because our entity has, a commitment to, some would call it a co-production of knowledge approach, but really bridging and bringing both indigenous knowledge, local knowledge, as well as the best available Western science.
Thank you. And Mr. Sakata, everyone's being very polite this afternoon.
Yeah, no, thank you very much. And thank you for the presentation. I think we're going to have a very similar question for the TCC presentation, but in slide 10, back to the genetics, especially at low abundance, it seems to be emphasized that, even a single chum can support the viability of discrete spawning populations. Unfortunately for myself, I really only have access to kind of the Western scientific knowledge. I have to admit, I've not mastered the art of getting into the traditional knowledge side of things. But my understanding from the Western science view is that chum salmon are not only the most likely to wander from their natal streams, and hence that's why they have the widest distribution of any of the Pacific salmon, of the 5 Pacific salmon. Tired. Sorry about that. And so I guess I was wondering how did you collect the information or arrive to the conclusion that tributary stocks with significant spatial separation, such that they may have genetically distinct, given that at least currently, the kind of most specific we can go for these particular chums stretches all the way from Area M all the way up to Norton Sound. So I was wondering, is this just a kind of a conflict between sometimes, the Western science lens versus traditional, or I guess maybe best to ask where that source of knowledge came from?
Sure. Thank you for the question, Mr. Sakata, and through the chair. I think we do put this forward more conceptually, and I think should you ask the TCC representative who will be presenting, she might have more, from on the ground knowledge to share from the Yukon. But I mean, we adapted this, as council staff mentioned when you asked a similar question, from a study on Chinook salmon and how Chinook salmon have these discrete spawning populations that are, spatially attributed to different tributaries, and managing to those discrete populations is critical when trying to manage for stock restoration. So we did apply that to chum salmon, noting also that knowledge holders from our region, they have shared there are times when they can tell, like, oh, this salmon was meant for this tributary or this river or something. They possess that knowledge. I myself do not. But if that answers some of your question, and but we do bring this forward more conceptually as another way of understanding how, like, the impacts of a single fish can ripple out to help restore stock abundance. It's another way of understanding that and how it's presented in the DEIS. I hope that answers your question.
Yes, just a quick follow-up then. So it's my understanding, and I believe the previous presenters that were summarizing some of this mentioned that, what was I going to say now? That the part of it was brought over from studies in Chinooks, and so it was transferred over. Okay, yeah, because I was a little confused by that, partly, once again, conflicting a little bit with what I've learned, not on the traditional side. It's interesting because my understanding is that the Chinooks are the least wandering, and so the genetic diversity is a little bit less there, but I'll be interested in hearing what the other folks have to say. Thank you very much.
Yeah, and if I could, through the chair, I just want to note attachment 1 to Appendix 7 does note a study that's ongoing to better understand the full genome sequencing of coastal Western Alaska salmon stocks. And so we do hope to better understand what you might be describing and what we're trying to address here in the coming years. So thank you.
Thank you.
Thank you. And Ms. Baker, did you have a question?
Thank you, Ms. Vicente. I appreciate your presentation. And I am interested in the table that you have at the bottom of slide 11, I believe at the version I'm looking on. And yeah, conflicting stewardship and management principles. And I'm particularly interested in the priorities you have listed there, and wanted to ask for the Indigenous stewardship priorities. I actually noticed what you have for balancing community harvest with ecosystem services and needs. What are and this is probably a difficult question, but I'm hoping you can just maybe give me some concrete examples. What are the types of indicators that Indigenous knowledge holders use to indicators of community harvest needs and indicators of ecosystem services and needs to help them arrive at that balance? Does that question make sense? I'm hoping you can just help me with that a little bit.
Yeah, thank you, Ms. Baker. And through the chair, I can help a little bit. And I do want to caveat, I'm non-Indigenous, have a great privilege of working with the tribes. And so I'll try to characterize the knowledge as best I can, but I'm not a knowledge holder. I mean, community needs, for instance, from talking with knowledge holders this summer, they shared that back before different management agencies were on the river, their grandparents and their parents, they were the original game wardens, is what I was told. They determined when a family had enough, and it depended on the size of the family. However, knowledge holders, especially from the lower parts of our river, also understand that fish that they're harvesting are passing through to go further upriver, both to the nets and the fish wheels and the smokehouses of families that are further along the stretches up into interior Alaska, as well as to feed, say, the bears and the wolves and the eagles. And it's critical to keep these species, these traditional foods intact. If the bears don't have enough food, they may start going after the moose. If the wolves don't have enough food, they're going after the caribou. And we're seeing these things play out now. So I think thinking about the priorities of Indigenous stewardship, it is, meeting a family's needs for the winter. Salmon is the essential food source throughout the year, but particularly in the winter. But it's also thinking of those above and thinking of the other foods, the other relatives, some describe them as, throughout the watershed that also need these salmon. Does that help answer your question? Yeah.
Ms. Vanderhoven?
Thank you, Madam Chair. Thank you again, Ms. Vicente. Not to belabor Mr. Sakata's question about the genetics, but just trying to make sure that I understood you correctly. You made the assumption that the stock structure of Chinook also applied to chum, that they were the same or pretty close. Is that how I took your response to Mr. Sakata?
Thanks for the question, Ms. Vanderhoven, and through the chair. I think in some ways, yes, but I think the point we are really trying to make with that discussion of discrete spawning populations is that there are specific tributaries on the Kuskokwim known for significant populations of chum salmon, like the Aniak River that's described in our appendix. And though we don't know the exact composition of, say, Aniak River chum salmon in annual harvest of coastal Western Alaska chum in the Pollock fishery or in the Area M fishery, there could be significant impacts to that tributary that folks are seeing on the ground now.
Thank you. And Mr. Mueller?
Thank you, Madam Chairman. Thank you for your presentation here. I'm on the same slide 11 here, and just a little bit curious, you touched briefly on 7.5 point B, impacts of food webs, habitat, and rivers. And so the condition of the rivers and the tributaries and stuff, and I bring this up because of years ago, and it was in the context of Chinook. But years ago, I was engaged in conversation, and I think it was a Lucknock or one of the communities on the lower Yukon, with some elders that brought up the habitat of the river systems and tributaries. And it was specific to, you know, in years past and since, the fur market has gone away, and it was referencing beaver dams and beaver houses, of which this elder was urging us to put more attention in that area relative to the spawning habitat of our salmon, Chinook in this particular case. Has any of those discussions come up in with your traditional and local knowledge holders?
Yeah, thank you for the question, Mr. Mueller, and through the chair. I mean, certainly, and that's why we talk about cumulative impacts affecting salmon declines. And there are environmental drivers. Beavers come up regularly, northern pike come up regularly. You know, the condition of streams, the heat stress that chum salmon faced when migrating through our rivers in 2019. It's, you know, it's all part of the drivers of declines. But we discuss in depth in our analysis what could potentially be actionable by this council. And that's why we focus on bycatch and intercept and things like that. Thank you.
Thank you very much for your presentation.
Thank you.
Is Crystal here?
Good afternoon, everybody. I hope everyone had a great lunch. Let me just get set up here real quick. So my name is Crystal Lapp. I'm the Natural Resource Policy Analyst for Tanana Chiefs Conference in our Tribal Resource Stewardship Department. I get situated here. I'd like to extend my gratitude for the opportunity to present on a few key points the tribes of the Tanana Chiefs Conference has indicated as important impacts they would like highlighted during this presentation relating to the chum salmon decline. Given my allotted time of 10 minutes and the inability to provide a comprehensive presentation on all of TCC's contributions, I kindly ask that questions regarding my presentation and additional information be directed to me personally in the essence of time. I do understand that you've been told to hold your questions until the end, but my goal is to be mindful and respectful of the council's time, staff's time, and to ensure that ample opportunity is provided for public testimony. For reference, I have provided speaker commentary along with this presentation, which has been uploaded to the agenda reports online. For time immemorial, the tribes of the Tanana Chiefs region have been dedicated stewards of their natural resources, a responsibility that is both sacred and essential to survival. Their ancestral lands stretch for over 235,000 square miles of the interior of Alaska, which equates to 37% of the state of Alaska. Through generations, these communities have developed intricate systems of knowledge to manage resources sustainably, ensuring the land, waters, and wildlife continue to thrive. Their traditional practices are more than just survival methods. They reflect a holistic worldview, one that recognizes the interconnectedness of people, animals, and ecosystems in a delicate balance. The Tanana Chiefs tribes have a history of resilience and advocacy for protecting their lands and their resources. In 1915, tribal chiefs from across the region united to defend their land and resource rights, taking a stand against external threats. This legacy of advocacy continued, leading to the formation of Tanana Chiefs Conference in 1962, bringing together 42 members, including 39 villages and 37 federally recognized tribes, in a collective effort to protect their ways of life and the integrity of their environment. I want to highlight that the stewardship of the Tanana Chiefs tribes remain a powerful testament to their deep-rooted values, cultural resistance, and unwavering commitment to preserving the land and its resources that have sustained them for millennia. Their story is one of harmony, endurance, and continued renewal of the sacred relationship between people and their resources. A relationship that ensures future generations can live, hunt, fish, and thrive as their ancestors have for thousands of years. I'd like to highlight Appendix 8.2. This covers multiple bits of information, but this is particularly on health impacts. So between 2019 and 2023, pre-diabetes cases in the interior region increased by 70%, while diabetes along TCC beneficiaries grew by 24.6%. As traditional diets shift towards processed foods, rates of diabetes, obesity, and nutritional deficiencies have worsened. Food insecurity, which affects both mental and physical health, disproportionately impacts remote Alaska Native communities, and it creates a growing public health crisis along with the salmon crisis. The ongoing decline of salmon availability has significantly weakened food security and nutrition in our region, leading to worsening health conditions. And without intervention, the continued lack of quality food and traditional nutrition sources, such as salmon, is expected to contribute to long-term rises in chronic illnesses. The impact extends beyond physical health. Food insecurity and the loss of traditional foods deeply affects mental health and emotional well-being. Salmon is more than just a food. It represents that cultural identity, self-sufficiency, and community connection. The inability to harvest the staple food has contributed to increased stress, anxiety, depression, and loss of cultural traditions. This has been said directly to our behavioral health counselors. Many communities have also experienced higher rates of substance abuse, which is often linked to economic and social stressors caused by declining food access. The most common thing when I consult with our behavioral health department is that they're hurting, not just physically, but mentally. That is the number one thing that they contribute, is that the loss of the practice of subsistence contributes directly to their mental health, their physical health, and their overall well-being. Appendix 8.2, this goes over a lot of financial impacts. One of the biggest financial impacts that I would like to highlight is that the cost of salmon distribution amongst Tanana Chiefs Conference and our tribes is exponential and not sustainable in the long term. As you can see from this slide, and I just want to note that the numbers that are represented up here do not factor in the volunteer labor hours, volunteer transportation, or additional support for like elder nutrition programs or things like that. That's sometimes hard to quantify. You know, the hidden costs further strain already limited resources, and the annual expense of distributing replacement salmon averages collectively between TCC and our tribes at 1.96 million per year. We're finding that it's diverting critical funds for healthcare, education, and infrastructure, which are all services essential to our tribe's well-being. Since 2020, the Tanana Chiefs region collectively, like I said, has spent over 1.96 million a year to replace chum salmon lost due to subsistence harvest restrictions. In 2022 alone, Tanana Chiefs distributed over 90,000 pounds of salmon to provide the protein and sustenance and cultural continuity to our members. However, we have found that relying on commercially sourced salmon is not a viable long-term solution, as funding is limited and often hard to find. Continued reliance on purchased salmon is both financially and environmentally unsustainable. It's culturally unsustainable. High distribution costs combined with increased fishing pressure elsewhere contribute to worsening salmon declines, prompting discussions on diversifying our food sources. Oftentimes, when one food source goes, we rely on another food source, and that puts pressure on another natural resource, not to factor in the outside pressure that those other resources may face through sport. So these figures highlight that, as populations, as salmon populations continue to decline, the challenges surrounding food security, cultural survival, and economic stability grow more urgent. While salmon distribution programs might mitigate short-term hunger, they do not replace the deep cultural and economic benefits of subsistence fishing. And with that, I'd like to segue into our subsistence economy. The money spent on subsistence fishing does not simply disappear. It circulates within our local economies, benefiting our villages and our tribes directly. It creates jobs and business opportunities for other people. Households that participate in subsistence fishing support multiple local businesses and service providers. Subsistence fishing comes with substantial costs, so many households have to maintain gainful employment and other sources of income just to afford it. That means that families rely on a mix of subsistence activities and wage-based labor to sustain their livelihood. As you can see from this slide here, subsistence economy to keep our villages and our tribes going can be between 30 and 80% of that village's cash economy. The reality strengthens, lost my place here for a moment, guys. So jobs in education, healthcare, public services, construction, and seasonal industries provide income necessary to fund equipment, maintenance, and fuel required for fishing. Without employment, our households would not be able to afford these essential supplies needed to participate in subsistence. And in this slide has a list of the common expenses that our families and households will spend in an average year, or what they would spend their money on. There is also a per person breakout, a high-low. So beyond direct financial benefits, subsistence also reinforces cultural traditions and ensures food security. Every time a household buys fuel, repairs a boat motor, or purchases fishing supplies, they're not just supporting their own needs, but they're contributing to their own economic stability of their entire tribe and village. It's not just about harvesting food. We have a complex and vital economic activity, such as subsistence, that connects our employment, businesses, and financial stability. By recognizing the interdependence between jobs and subsistence activities, we can appreciate how our traditional ways of life continue to sustain our economies and our future and keep us independent people. The last point I'd like to touch on is what I said in the beginning, that for time immemorial, we have been here. And I don't say that as something anecdotal or opinion. Western science has now proved with the Upward Sun River site. So for over 11,500 years, our indigenous people have relied on chum salmon not just for sustenance, but as the cornerstone of our culture, identity, and survival. The Upward Sun River site stands as a proof of this deep connection, showing that salmon have always been vital to our people and our land. For context, the drawings that you see in the slide currently is from the Healy Lake tribe. they found 2 ancestral burial sites that have direct genetic link to fall chum salmon. And the tribe graciously provided these drawings because they wanted you to see that we have been here for time immemorial. So traditional knowledge has guided its stewardship for generations. We emphasize balance, sustainability, and gratitude. Our teaching stress taking only what is needed and avoiding waste and honoring salmon through ceremonies and rituals. And I say this again because there's been questions on what traditional knowledge is, and I'm giving you the principles of what that traditional knowledge is. So the discovery of salmon remains at the Upward Sun River site confirmed the enduring reliance on this vital resources and demonstrating sustainable harvest practices dating back to 11,500 years ago. So what I would like to highlight in our appendices is that traditional knowledge that is sometimes confused on a Western science understanding with methodology, just because I think sometimes what we say might feel a little bit different, but what we are saying is fact, and sometimes that fact has a little bit of emotion to it. So again, I would like to thank you all for allowing me the time to present. I do have additional slides that have additional commentary along with them. And again, I encourage you to reach out to us individually if you have any further questions. And I also want to thank you for taking the time to read our contributions to the environmental impact statement.
Thank you very much for your presentation, Ms. Lapp. Just want to make sure I interpreted your request for questions. Would you be willing to take questions on the slides that you did show, and you're asking that we withhold questions for any supplemental information to side conversations?
Through the chair, thank you for that clarification. Yes, my concern was the amount that we have contributed to the EIS documented itself in the appendices, and that the limited amount of time would not be able to award me a comprehensive time to go over all of our methodologies and all of our information. And so I didn't want to put us all in a predicament of a time suck of you guys asking stuff that you read about, and I haven't really presented on that today. I am happy to take questions on the things that I've presented on. And then I'm also happy to take questions at any time, not only during this meeting, but after, for further clarification.
Okay. Thank you for that clarification. We'll see if there are any questions on the presentation. Yes, Mr. Blahovdy.
I'm glad you clarified, because I did have one. I understand that because of the lack of salmon, not just chum salmon, but the expense that the tribes have gone through to get enough salmon and to just be able to continue the cultural practice of being able to eat salmon. So was that part of the financial cost that you had calculated up on the slide? And do you know like approximately how much that is TCC's paying? I know some salmon's donated, but you're also buying salmon, I understand as well, right?
Through the chair, yes, thank you. To my understanding, and I can stand corrected, I do have some experts behind me. We have had only 1 year of donated salmon, and the rest we have purchased salmon ourselves. And that's just TCC. Again, as you can see from our individual tribal expenditure, that's more than what we spent. And so I can't speak on those specifics, but I would actually like to get those for you to see where they've sourced them if it was donated. And I want to also note that within my analyses of that $1.2 million that our tribes have collectively spent, the cost really wasn't on the salmon itself. The cost was on transportation and keeping the salmon cold enough. And even then, they had to purchase more because transportation issues are hard. And they would have shipments coming to them that were thawed and rotten by the time they came to them. So some of that number is from a repurchase.
Thank you. And Ms. Baker.
Thank you, Madam Chair. Thank you, Ms. Lapp, for your presentation. And my question is on the slide that relates to Appendix A3, the financial impacts, where you have the pie chart. And I just wanted to make sure, yes, thank you. I understood actually the bottom graph that you have there that you did review very quickly, given your time limitation, because this is somewhat exciting because in our council analyses, we rarely have cost information. It is largely revenues. And so I just want to make sure I understand in terms of the estimated annual fishing related cost per person. Can you just give me a sense of how you came up with the low and the high? And a little bit more would be really helpful. Thank you.
Through the chair, thank you, Rachel, for asking that question. I think this is a subject that isn't touched on very much. In my conversations, just in everyday life, I think there's a misunderstanding that subsistence is just a free activity and that there's no cost into it, and there really is. And even though I spoke a lot on the local economy as it does sustain and keep our local economies and our villages going, we also contribute to the local or the economies as a whole in Alaska. So when I came up with these numbers, it was actually through personal conversations, one-on-one conversations. And I was able to reach out to at least a couple tribal citizens in each of our villages to come up with this. And when we're looking at the low estimate and the high estimate, that is because logistically within our region, for how large we are, it's hard to pinpoint just an average. We have some places that have better access to transportation, to freight costs, have better freight costs, so things like that. There's some years that they may not have to purchase a lot more equipment because it's still in good condition. There's some years where maybe they don't have to make major repairs. And so that might be where we would see that low estimate of cost per person. And when we factored in cost per person, we factored in cost even for those not bringing in an income, because subsistence fishing is really a community thing. It's a family thing, and everyone contributes in their own way. And we're buying gear for all of them. So, and that's why when I listed out everything, it's pretty different from upriver than it would be or downriver, and there's so many different cost factors that it's so hard to generalize our region because we're so distinct, and we all have our positives and negatives when it comes to purchasing these supplies and getting them. But again, I could definitely send you kind of the methodology and a bit more of that breakdown, because I do have that available if you would like.
Through the chair, thank you. That was a great answer to the question, and I really appreciate it. It's helpful.
Thank you. And Mr. Twait.
Thanks, Madam Chair. Thanks, Ms. Lapp. Two questions about two different slides. First, the Upward Sun River slide. Can you just describe to me a little bit about what's happening in each of those four different illustrations?
Through the chair, Bill, thank you for that question. Our tribe was really hoping that somebody would have a little bit of an interest in this, because not only is it our history, but it does show that reciprocal, long-standing relationship. So where you see the two people, what looks like a burial site, that's a burial site. They found two infant children, and there is ceremonial offerings in there. There is also ceremonial burnings and other indications of ceremonial practices in direct relation with fall chum salmon in that site. The archaeological site in itself is quite vast, because at that time we were quite nomadic people, and we had multiple sites throughout our tributaries because we followed our resources and we followed our salmon. So there's just a few drawings that you can kind of see that little bit of nomadic village life from 11,500 years ago. You'll see one here where there's some antlers in the background. That would be our hunters out there providing food for those that they're traveling with. You see people out there gathering. And I do want to say that the mountains in the back of these are actually accurate to what you would see in the Upper Tanana. And then you can see a kind of a traditional site of what the houses would be like, and that is actually a direct recreation from what we've unearthed on that site. So these are, like I said, 100% accurate from what we have found. And I also want to note that we don't have the drawing on here, but there was also another burial site of a toddler found in that area, which would have been around where those homes are, which also had fall chum salmon.
Thanks, that's really helpful. I was kind of tracking a couple of them, and a couple of them, it took your answer, and that helps a lot. And now back to numbers. I was sort of caught by the range that you gave us for subsistence economies in different communities and the importance of subsistence economies in those communities. 30 to 80% is a big range. And so I assume that really at the ends of the spectrum, there's sort of two very different types of communities. And I was wondering if there was a way for you to just sort of characterize maybe some of the differences between a 30% community and an 80% community for us.
Through the chair, that's a great question. And again, in essence of time, this is really where I get fun and have fun with all of the data that I've collected. Yeah, 30 to 80% is a huge range, and you're right on the right track. That is due to our different regions. So I'm going to just refer quickly to that first slide that shows our 6 different regions. Because like I said, we're 235,000 square miles. We're slightly smaller than the size of the state of Texas. So our ancestral lands is quite large. So here you can see our 6 regions, and then we do have the Fairbanks North Star Borough in there. They're part of our ancestral lands. But when I say 30% to 80%, when we see the 80%, those are going to be our villages that are way off the beaten path, right? So they're not on road systems. They have limited access to aircraft coming into their villages. Some of our villages don't have a big enough runway to have a larger plane, to have that buying power to buy in bulk. So there's a lot of factors that go into that. And so when we find that they are a bit more remote or even in smaller in population, they're tending to pay higher prices. So they're tending to keep their money in their own community as much as possible. But when we start going down to like the lower end, that's when we're going to start going into kind of our upper Tanana area. They're on the road system, and it's a high traffic road system. And so they're often buying a lot of their supplies because there's closer urban areas to them. So a little bit of their subsistence money is going to stay in their area, and that's going to be typically more on the fuel purchases, propane, diesel, those types of services versus gear. And oftentimes in those economies that are in that higher range, it's not often affordable or accessible to send gear out to get repaired. So that creates jobs within the community itself, keeps that cash flowing, and they'll hire their cousin or their uncle or, somebody to go and fix something because they may be off on a job right now. So that's why we have such a wide variety of numbers in our region, is because we're very vast and we're very different, and we all have different things and different amenities in our villages. Not every village has a store. That's also a huge factor when we're looking at that higher end, is because they're purchasing from each other. So yes, that's also something that I do have that raw data, and I would love to sit down and talk or provide it to you. It is interesting to see and unveil that subsistence is a zero cost activity. It does have financial impact, as well as what you guys hear in our testimony of that cultural, spiritual, and traditional way of life impact. So just for essence of time, I wanted to highlight that fact. And so thank you, Bill, for asking that question. Thank you.
Thank you. And Mr. Sakata?
Yes, thank you for the presentation. I'm not as familiar with the TCC region as I am with the areas that we serve, but it is huge and it's very diverse, it looks like. Can you I thought I heard a testifier mention the tribal membership or the population served? I just wanted to be sure, something like 18,000. Is that correct?
Through the chair, yes. I believe our enrolled tribal citizen number is around that 18,000 mark. And that is a lot of people. And that, as you can see, we are very, very all stretched out, but we're also very connected. And so that I want to also note that Fairbanks is included in here. And oftentimes Tanana Chiefs Conference, we care for all in the Fairbanks area. It's not just our tribal citizens. So when I'm talking numbers like in the second slide, and I say it doesn't factor in like elder nutrition programs and a few other things, it's things like that that is done kind of out of our traditional ways, and that's sharing, that's caring for others. But we do have a large amount of overall tribal citizens in the Fairbanks urban area. And a lot of my numbers do not account for that because that's a different analysis.
Okay, thank you very much. Just as a follow-up, looking at some of your health numbers, though, yeah, I can definitely see that there is a crisis going on there. Some of those appear to be based on inability for choice on things like food, from what I heard in your testimony. Can you give me an idea of what percentage of your tribal membership is on the road system versus not?
Through the chair, thank you, Rudy, for that question. I also just want to reiterate that this is a presentation and not a testimony. Sorry. Yeah, we do have a health crisis going on, right? The numbers that you see on here are directly from our native hospital in Fairbanks. So these are people that are coming to our own hospital. This is our own data. This is the malnutrition and obesity that you see right there. That's directly from our nutritional department, which works with our diabetes clinic and a few others. And yes, we are finding that people are having to depend on highly processed and shelf-stable foods because of the cost of food and because of the inaccessibility and the uncertainty, especially during winter, of transport. So as far as direct numbers of who lives on the road system and who lives off the road system, I believe I have that stashed in my computer somewhere, so I'd love to follow up with you on that.
Yeah, that'd be fine. Thank you.
Thank you. And Ms. Goen?
Thank you, Madam Chair, and thank you for the report here. This is really interesting information and different than we often see, so thank you for taking the time to pull it together. My question is on the health impacts slides as well. I don't think we're as familiar with hearing about well-being, emotional well-being of a community. So I'm wondering if you can speak a little bit more to that and how the decline in salmon, chum salmon in particular, has affected mental well-being.
Through the chair, Jamie, that's an excellent question. Because well-being, that word can be quite vague. So when I'm talking to our traditional knowledge holders, when I'm talking to our hospital, when I'm talking to our various departments that treat the overall well-being of our people, when we're discussing the decline of the activity in itself of subsistence, we're talking physical. It's a physical thing to go out there and get salmon or to moose hunt or to get caribou. And so that contributes to the physical well-being. But that also contributes to our emotional well-being, that contributes to educational, that contributes to so many other things. But when we start to be inactive, when we start to depend on shelf-stable foods that are low in nutritional value, it physically makes people feel worn down. That is a common comment when I'm getting feedback from our people of, how is your diet changing, or how has your diet change affected you the most? And they just say, I feel physically different because they are. And so I think we all kind of have a general understanding of how health works. So when your body's not feeling good, your mind's not feeling good. So that's a really complex question, I think very much to the individual, obviously, but overall, that's how I could probably sum it up, is everything is connected, even within our bodies. And so when we're not getting that nutrition that we need that sustains us, especially through the winter, which salmon is high in vitamin D, omega-3s, and a lot of other nutrients, stuff that we normally wouldn't be able to get when there's snow and ice all over the tundra and there's limited resources. That's what sustains us through the winter and keeps our mental health and physical health good. So thank you for that question, Jamie.
Okay, I'm not seeing any other questions. We appreciate your presentation and your contributions.
Sine Angel and Sine to everybody here on the council, and thank you for allowing me this time.
So we do have one last report, but before taking that up, I think we're going to take our SSC report because our SSC members have been waiting so patiently and expeditiously work to get the report done for us by 1 p.m. today. So, okay, thank you.
Good afternoon, Madam Chair, members of the SSC. For the record, Franz Mütter, former co-chair of the SSC, filling in for Dr. Sherry Dressel, and with me are Dr. Ian Stewart and Dr. Jason Gasper, to the new co-chairs, which is the first bullet point on our report here. The SSC re-elected Sherry Dressel and elected Jason Gasper and Ian Stewart to be co-chairs for 2025. And the plan is for Dr. Gasper to chair the April meeting, Dr. Dressel the June and December meeting, and Dr. Stewart the October meeting. The SSC also re-elected Alison Whitman to serve as vice chair for 2025. And then finally, we appreciate the appointments of and welcome new members Sarah Weiss and Jennifer Burns to the SSC. Jennifer Burns wasn't able to join us in February, but will participate in April. Before we get to the chum salmon bycatch item, we had, during the discussions, some general comments came up that we felt we'd pull out and also highlight in our report under general comments that are more applicable to other analyses as well. One is that, this analysis was, I think, the first major analysis that we've reviewed where we sort of specifically focused on previous SC comments, on any key new additions and revisions. And we generally felt that worked pretty well. And for previously reviewed analyses, when we see those in the future, the SSC would support focusing on just those sections for large documents that helped streamline the process. Then with regard to impact analyses or other analyses in council documents, the SSC encourages the use of social indicators and human well-being frameworks that are pretty well established in the social science literature, as I understand it, to better characterize or better conduct qualitative analyses of potential impacts in any documents that the council reviews. And then finally, we support the inclusion of LKTKS in council documents and felt that this chum salmon document in particular could, perhaps serve as a potential model. And we note that that reflects some fairly concrete progress towards providing this type of information to decision makers on a more regular basis. Those were our general comments. And then getting into the chum salmon bycatch initial review. This is a second initial review for us. The focus of this review, like as I said, was on responses to our previous general comments, responses to SSC comments on economic and social impacts, then the new AEQ analysis, and the new alternative 5. To kind of get to the bottom line here is the SSC finds the document is adequate to allow the council to understand the impacts of the alternatives. We did, however, have a number of recommendations to the to the authors to consider in revisions to the document before it's advanced for public review. And we'll go through those recommendations, the key recommendations in the coming slides. Before we actually go into the recommendations, the SSC wanted to highlight a couple comments from our April 2024 minutes that are still very relevant. One is with regards to scheduling a performance review of any new management measures that may be introduced to reduce chum salmon bycatch to be conducted relatively soon after implementation. And then a second comment, unrelated comment, is that the SSC recognizes that establishing new management lines based on historical data can be problematic for many reasons, particularly when climate change leads to changes in migration distribution for many marine species, and that's really in reference, and I think we have another mention of that, really in reference to putting in place kind of static areas in the face of changing distributions of different species. A few more general comments on the document. The SSC recommended that when we, throughout the document in comparisons with the status quo alternative, that it's made very clear, maybe making it more clear than it currently is, that these comparisons are all based on on data from the 2011 through 2023 period, but because of the changes to the IPAs following the high bycatch in 2021, that that may mask analyses comparing the status quo to other analyses. These changes may be to some extent masked, and in that regard, we recommend caution when interpreting results that rely, say, just on the later years of the retrospective analyses because of those changes that were made. The SSC also recommends that the author or the authors further refine, consolidate, and present the chum removals in a single place in the document, including the area M removals, because they're currently somewhat scattered throughout the document. And then we recommended that the authors reduce, revise, and clarify text and figures that to help basically improve the accessibility of the report, in particular with regards to the executive summary for the public to have a shortened, more streamlined executive summary and document overall. Then also, as noted in our general comments, we support the revisions to this document to more fully incorporate LKTKS and that acknowledges the breadths and depths of information that's now included in the main document, and also the details in the appendices. We recommended that the authors also include a table or a figure that better summarizes the potential benefits to Western Alaska communities and the long-term impacts on chum salmon populations from any of the alternatives. And then we also recommend expanding the discussion of the vessel level impacts that could reference as appropriate some of the quantitative analyses that are already included in Appendix 6. The next couple slides, I believe, are with regards to the simplified AEQ analyses and impacts that we had recommended in our last review. So we generally support the use of the simplified AEQ analyses to inform the Council's decision-making. And we generally agree with the authors that the AEQ estimates of chum salmon removals due to bycatch and the associated impact rates are helpful in developing realistic expectations of what we might expect in terms of salmon savings under the different alternatives. And we also agree and highlight that these are not a complete assessment of the potential impacts that bycatch may have on Western Alaska chum salmon populations. So we, like I said, we do support the simplified AQ analyses and just ask for a few additions to that analysis to the extent practicable. And that's incorporating the uncertainty in the run size information that was provided for the upper middle Yukon AEQ impacts analyses, and in the graphics that were presented for that. It was our understanding that that information is readily available and could be included in the figures. We also encourage the authors to provide figures or tables that have the AEQ, the commercial and subsistence catches as a proportion of the total removals for both the coastal Western Alaska reporting group and for the upper middle Yukon reporting group, and then also as a proportion of run size, which is only available for the upper middle Yukon group. And then finally, we encourage the authors to explore the AEQ assumptions regarding when the bee season bycatch savings, what the fish that could be saved when they actually return to the river systems, whether especially later in the season, if those fish could even possibly return to the river systems that same year. That is currently not taken into account in the analyses, but may also not make a big difference. The next couple slides or so are with regards to the new alternative 5. We appreciated the thorough discussion of the benefits and potential costs of alternative 5, which, as you know, would implement the spatial corridor with area-specific limits. And we also very much appreciated the exploration of the fleet movement model that we had supported when we reviewed this last year, similar to what was used for the Bristol Bay red king crab analyses, and appreciate that the authors tried that, but that ultimately didn't pan out. And we do support the analyst's decision to instead provide a descriptive analysis rather than using that model, which really isn't possible to use in this particular case, the way it was designed, given the limitations in the available data. With regard to the alternative 5 too, we just highlight, and I think we're commenting on maybe also highlighting that in the document more clearly, the behavioral responses to potential spatial closures being sector and vessel specific. And then the highlighting more clearly that the delays in bee season fishing, if there are delays in the fishing schedule during the bee season until after August 31, that could impact Chinook salmon PSC. And then as we also highlighted in our overall general comments, how this actually works, the utility of this, of the static spatial management measures is quite uncertain given the dynamic nature of the marine environment and expected changes under changing ocean climate. And then finally, we suggest that the analysis also consider potential limitations of alternative 5, the corridors on conservation benefits that could be gained through alternative 4, as alternative 5 might restrict the options under alternative 4. And then we also suggest inclusion of a cumulative impacts analysis of the static closures that look at all of the static closures that exist along with the new static closures under the alternative 5, and including any other other closures that are in place, like the summer herring savings areas. And I believe, sorry, got the last part. So that we have a couple slides on the economic and social impacts. And we again highlight, I think we commented on that last year, and that's certainly also highlighted in the document, but highlighting our concerns about potential unintended adverse consequences of some of the higher cap levels on Western Alaska chum bycatch in the alternatives because of incentives and unknown effects of that on incentives to move elsewhere and unknown effects on bycatch in other areas. And then additionally, also concerns across all the alternatives regarding potential increases in Chinook and/or herring bycatch compared to the status quo. And so we recommend a new report section that basically would enhance the discussion of these potential impacts across all the different alternatives in one place. And then we recommend a few other minor changes to the report to describe how the incentives under the alternatives to reduce total bycatch and the associated uncertainty in how that plays out as the fleets move and bycatch rates vary across different areas, and how that might result in the Western Alaska chum savings to be anticipated to be only realized at low caps. And this, I think, specifically refers to Table 1.5 that kind of has the arrows of when to expect positive benefits in terms of Western Alaska chum savings under the lower caps and less so under the higher caps. And we're simply asking for an enhanced discussion of and justification for those directional arrows in the table. And then we recommend to provide further context on the impacts of the different alternatives by considering vulnerability and resilience of the pollock-dependent communities that rely on the pollock fishery. And then finally, we suggest or recommend interpreting the alternative 4. There was some confusion about exactly what is being compared when alternative 4 is being called, or the impacts of alternative 4 compared to the impacts of alternative 1, because some of these measures were already in place in the last few years. And so we recommend interpreting alternative 4 as basically eliminating the option to modify or remove any of the provisions in that option, as opposed to alternative 1, status quo. And I believe that's all we had on that. Happy to take any questions.
Thank you very much for the report. Mr. Curlin.
Thanks, Madam Chair, and thanks much for the report. So I'll start on your very last slide and your last bullet about alternative 4. I'm wondering if the AP's discussion, the SSC's discussion on that noted that IPAs can include modifications, voluntary additional measures over time. So essentially this would be a floor. So the requirements, if the council were to move forward with alternative 4, the secretary were to approve it, those would be essentially minimum requirements in regulation, but the IPA holders could continue to propose other things to include. So was that part of the SSC's discussion.
Thanks for the question, Mr. Kurland. Through the chair, we didn't specifically discuss how, and I don't think the document discusses, to my knowledge, how that might play out in the future under alternative 4, what additional measures the fleet may take under that. We were more focused on comparing the alternative 4 that would put these, measures in regulation versus alternative 1, and to clarifying in the document. I think there was some unequal treatment of how the benefits or costs would play out under alternative 1 versus alternative 4. We were not focused on any additional measures that the fleet might take under alternative, if alternative 4 would be put in place. Is that captured? Jason?
Yeah, Mr. Kurland, through the chair. I think too, the other part of the discussion was interpreting alternative 4 as removing the possibility of reverting to pre-2022 status under alternative 1 by removing some or all of those provisions. So there's sort of a cost if those provisions aren't needed, and so they have to be removed through regulations.
Thanks very much. That was a helpful clarification. My second question, second and final, is on slide 8, where you were discussing the adult equivalency analysis. No, not that one. Yeah. So the last bullet there, not a complete assessment of the potential impact bycatch may have. So essentially there was the SSC flagging that we should treat the numbers that come out of the AEQ analysis as a minimum. I'll just clarify that that would be sort of the minimum effect on chum salmon population.
I'll do my best to answer it through the chair. I don't think we were looking at that as a minimum, but flagging all the associated uncertainties, and there's more work that could be done, but I think the uncertainties would sort of bury any making definitive conclusions about the impacts. But I welcome any other comments from my colleagues here if you have any.
Yeah, I think we were also just trying to recognize the potential impacts, both positive and negative, could extend beyond just the number of fish that were quantified by the AEQ. So not so much that that was a minimum. I don't think we had any reason to think it was a high or a low estimate, but just that there were additional impacts beyond that number of fish.
Okay, thank you.
Ms. Vanderhoven.
Thank you, Madam Chair. Thank you for your report. I need to go back up to slide 5 or 6. It's where you highlighted your 2 comments from 2024. And I didn't realize your written report was posted, so it may be in there, so apologies. My first question, was there additional discussion about these 2, or was there some concern, or I guess I'm not clear why these 2 were called out. I didn't hear you speak to anything in particular about these 2.
Thanks for the question, Ms. Vanderhoven, through the chair. I trying to recall when those were elevated. I think it was during our sort of discussion of responses to the analyst responses to our previous comments from last April, that I think it's primarily because we felt these were sort of overarching issues that that we felt are important for the council to consider. We had highlighted these last year. They don't relate otherwise directly to any of the other topics, and we wanted to pull those out again to highlight that the uncertainties in terms of future changes in the system, the dynamic nature of the system, and then the importance of a review. That's about all I can offer. We didn't go through all the comments that we made last year and rank them by any means, but these two we felt were two overarching comments that we felt were important too.
Thank you. That's helpful. And so you may not be able to answer my second question then regarding the first one about the performance review. Would the SSC be looking to provide some kind of input as to what we might be looking for in a performance review, or how we would define what the performance review was? I'm not sure exactly what the guidance is to us there. And when it's not clear, I don't think we always make the best decisions on what the expectation might be.
Through the chair, Ms. Van Oven, thanks for the for that question. We actually do have the full quote in our written report, and it has a little more detail, but basically just recommending, clearly defining which outcomes might be considered a success here in the context of that action, and how that might be measured. And so, I mean, I think in general, we often recommend kind of tracking how a new program or action works over time to learn from it. And we thought that would be particularly important here. And I don't know if you have anything to add to that. But we have a little more in our minutes, but just, really just pulled out the full quote from last April.
Thank you. And Mr. Twite?
Thanks, Madam Chair. Dr. Muter, still on the slide, but back down to the bottom one. It occurred to me, as Ms. Vanderhoven was asking her question and you were answering, that you're reiterating this after having kind of looked at this meeting at the corridor idea in a lot more depth than you were able to back when you made these comments originally. And so the fact that you're still highlighting them doesn't mean that you're skeptical about the corridor concept. It means that you're concerned that if corridors are defined in a very rigid manner, such as through regulation, that might be a lot less useful, or that might be somewhat self-defeating. So I'm asking, am I interpreting the SSC's sentiments correctly?
Through the chair, Mr. Twide, yeah, I think that's correct, or I can at least try to characterize it from my perspective. Yeah, I think we have, often had static closure areas that in some cases may have worked out very well if species distribution is really tied to substrate in a particular area. In other cases, not so much. And with salmon, obviously they in the pelagic environment, and they may during their movements they may be tied to certain depth contours, or there may be a good reason for why they perhaps choose these corridors or parts of these corridors. But that could, especially in the pelagic environment, that could change as the climate changes. So we don't know if whatever the retrospective analysis might show now, we don't know if that is also going to be the case in a warmer ocean, particularly if the migration itself is tied to temperature, for example. That would change the seasonal and spatial distribution potentially of the salmon, and it might be, the corridors might become less effective even if they would have been effective in the past.
Yes, Ms. Kimball.
Thank you. Thank you for the report. I think it just got me started to think about Ms. Vanderhoven's questions on the performance review. Is absent a performance review in our current draft, what was the SSC conversation about how to discern benefits between alternatives or between options and alternatives? because I think that's really at the core of what we're trying to accomplish is some improvement. And so did the SSC have a conversation about that, whether the council or should be focusing on salmon saved or Western Alaska salmon saved or reduction in the impact rate? We have one for the middle and upper Yukon of less than 1%. Should we be trying to get something less than 1%? Was there a conversation about how we can start to gauge whether we're making an improvement under our current set of alternatives? Because otherwise we have work to do to modify alternatives.
Thanks for the question through the chair, Ms. Kimball. We obviously didn't really discuss the alternatives per se and whether there may be other alternatives to do a better job, but we did feel that the document, kind of to the extent possible, provides what we understand about the potential benefits that could accrue given all the associated uncertainties. And we made some suggestions to perhaps better highlight how different options, say like the lower cap versus a higher cap, may result in potential benefits. Obviously, we are all focused on, are there ways in which the bycatch of Western Alaska chum salmon in particular can be reduced, and we felt that the AEQ analysis provides a good step in terms of providing some reasonable expectations of what the potential benefits might be, in terms of just number of salmon saved. The impacts or benefits beyond that are, perhaps even more difficult to define, but I think that's where you'll have, input from the LKTKS portion on trying to characterize potential benefits of whichever number of salmon might be saved. I don't know if that really addresses your question, but we did feel there was certainly some contrast in the existing alternatives in terms of the number of salmon potentially saved that would then translate into some of the other benefits at the community level and to the kind of chum salmon population downstream. And I look to my colleagues if they want to expand on that.
Through the chair, Ms. Kimball, another aspect of this discussion that we did spend quite a bit of time on was the treatment of uncertainty in the analysis. And one of our recommendations was to provide a better perception of the uncertainty, especially in the run reconstruction and escapement estimates where possible, in order to determine how detectable a potential change might be as a result of management action. And so several of our recommendations to the AEQ were focused on this idea of better describing that and also bringing those sources of data together onto the same graphs or on similar scales so that we could see the relative magnitude of each and the detectability.
I appreciate that. Thank you. My last question is on slide 7. And I do apologize for both these questions if they're in the written report. I haven't had time. I think it was posted during the presentations. But the last 2 bullets, oh, you don't see the numbers. It's not this. It's not that. That is it. Yes. The last 2 bullets there, is there anything in your minutes or discussion in helping the authors kind of meet those requests or recommendations? I feel like those were both things that, at least when I heard the presentation, it felt like they have gone as far as they could in terms of trying to discern benefits you know, among Western Alaska communities, they couldn't do that at the community level. And similarly with the vessel level impacts, that they were somewhat limited in how much they could do there. So really, it's a yes or no question if there's anything in your minutes to help them go further than they've already gone.
Through the chair, Ms. Kimball, I can't quite boil it down to yes or no, but I mean there is more in the minutes, but I think the intent here for bullet 2 was primarily just to pull the information that is available and provided in the document together into a single table or figure for presentation purposes. So this is not asking for anything new really for the second bullet. And for the third bullet, we actually weren't quite sure because we did not review fully review the vessel level information that was provided in Appendix 6. We did some of that on the fly a little bit, but we just wanted to at least encourage the authors to the extent that the information is available to discuss more explicitly the vessel level impacts in the main document. Again, not asking for additional analyses, but for bringing that out more clearly.
Thank you. Appreciate that response.
Any further questions on the SSC report? Yes, Ms. Baker.
Thank you, Madam Chair. Most of mine have been covered, and now I've lost, perhaps we can find this slide together. There was a suggestion a recommendation by the SSC for a new section of the analysis. It was about the unintended consequences. I had it and then I lost it.
I think that was the last slide.
Yeah. Oh, thank you.
No, I mean the last
think
slide in
it was
the report. Yeah. Oh.
Thank you. So I just wanted to understand this recommendation a little bit more. It is in essence the recommendation for a new section to further discuss the impacts on the different resource components that are generally the impacts are evaluated separately for chum salmon and Chinook salmon and herring. Not only combine those unintended consequences together, but also across alternatives. So it's all sort of in one place. Okay. Maybe you can probably explain that recommendation better than I just did to help us all. Can you please summarize that?
Yeah, through the chair, Ms. Baker, I think you did a good job summarizing it. I think that was the intent to, not asking for any more information or analyses, but to, like, what is currently under each discussed sort of separately under each alternative, to pull that together in a section for us and the public to better compare across alternatives. So really more structural presentation issue than any new analyses. Does that help?
Through the chair, yes, thank you. And then the last question may not be fair, but did the SSC have a chance to discuss prioritization of any of these recommendations in terms of, there's a lot here and good suggestions, but so not asking you to do that here at the table, but was the SSC able to discuss that at all in terms of if there are staff capacity constraints or other things like that? Did you even have that discussion? Were you able to?
Through the chair, Ms. Baker, I don't think we had that discussion. I mean, we do in our minutes sort of bold the things that we consider perhaps higher priority, and those are largely the ones that we pulled out here. We went through each of the sections that we reviewed or each of the new analyses that we reviewed over the course of a day, and then kind of tried to step back a little bit to consider, given all the recommendations that we had, is it still, is that a minor minor changes, or is it a huge lift? And again, we felt, I think, in the end, if I can at least speak from my perspective, we felt that all of these were mostly, some reorganization, clarification, changes to the way things are presented, but not new analyses or new data. In a few cases, I think we may have asked for more sort of, for example, long-term impacts on the chum salmon population. We have some discussion of that, and oftentimes it's just asking for an enhanced discussion where we specifically say in our report, we're not asking for a new analysis. We're just asking for an enhanced discussion of, say, kind of long-term impacts on the population from adding, some number of additional spawners on the spawning grounds and things like that. So we felt that it might be doable, but we did not discuss further prioritization was in that. I don't know. I don't recall anyway. Yeah. And yeah, as is common in these reviews, when we release it, we said, to the extent practical or practicable or something like that, but without prioritization.
Thank you.
Thank you. And Mr. Ritchie.
Thank you, and thank you for the report. I apologize if you've answered this kind of in another question, an answer to another question. But I'm reading this bullet point that both Ms. Kimball and Ms. Vanderhoven asked about the clearly defining which outcomes would be considered a success. And I'm thinking about the purpose and need statement that we have, and I'm wondering if you discussed at the SSC whether there was a high likelihood of the impacts of reducing chum interaction in any of these alternatives, if that would be in regard to a measure of success, if as far as an impact rate, if that would be detectable, if there's a likelihood that that would be detectable. I'm just looking for a little guidance there as I look at this bullet point and I think about the purpose and need statement.
Yeah, through the chair, thanks for the question. I mean, I think in terms of outcome, even just having at the impact rate is more difficult, but even, just having number of chum salmon saved certainly is, as we move forward, if under different levels of chum salmon abundance in the ocean and coming back to the stream, we stay well below the historical rates. And, we have estimates now of the number of Western Alaska chum salmon. If we, stay at low levels, that's certainly a measure of success right there, just as the number avoided. And in terms of the impacts, similarly, I mean, and for the upper middle Yukon, we can assess the impact rate and can monitor that over time. If that stays low over time, that's certainly a measure of, at least you're avoiding perhaps high impacts. Whether you can attribute causes clearly, given all the changes occurring, is certainly another question. But at least you can monitor those two aspects. And I don't know if you have other things that we maybe talked about. Does that help?
Okay, I'm not seeing any further questions. I appreciate your report and the SSC's work this meeting. And to me, turn your product around in a very tight time frame. So thank you again. Okay, we will take our mid-afternoon break now. We'll come back at 4 p.m. And we have one more report from the Science Center on updated genetics. And then we will take a limited amount of public testimony this evening. Again, a reminder that we'll be closing our public testimony sign up at 5 p.m. tonight. Thank you. Council members, please come back to order. So we have one more relatively brief report before beginning public testimony. It's my intention to probably break as close to 5 as possible. So we'll be taking we have 138 people signed up. We'll obviously only be taking a couple. We have 2 members of the public who need to leave today. So we'll be trying to take those 2 individuals as well as a couple first people on our list, probably get through 3 or 4. So we will start with Dr. Berry and then move on to public testimony. Thank you.
Good afternoon, Madam Chair and members of the council. For the record, my name is Patrick Berry. I'm a research geneticist at the Alaska Fishery Science Center. And today I'll be presenting kind of a high-level overview of the annual report on the genetic stock composition of chum salmon bycatch in the Bering Sea Aleutian Island pollock trawl fishery. And I'll be happy to take questions after the presentation on anything I cover within this presentation or that was presented in the report provided. So from 1991 to 2024, the number of chum salmon caught in the Bering Sea Aleutian Island pollock trawl fishery has varied annually. And so in this graph, we have the number of chum salmon from all genetic groups on the vertical axes and the years on the horizontal axes. And there are 2 lines representing the A season in green and the B season in orange. And as you can see, the amount of bycatch in the A season is typically very low, often less than 1% of the overall bycatch. In 2024,
Dr. Berry, you're breaking up. Wondering if there's anything we can do. Is it on his end, do you think? Okay. Okay. Would you mind calling in on your phone, Dr. Berry? Okay, we're trying to contact him over text. Thank you. Thank you for your patience, everyone. Okay, I think Dr. Berry is calling in right now.
Okay, my apologies.
Let's give this another try.
Okay, I think I've resolved the issue. Can you hear me okay?
Yes, that's much better.
Okay, great. All right. So as I was saying, From 1991 to 2024, the number of chum salmon bycatch in the pollock trawl fishery has varied annually. So in this graph, we have both the A and B season bycatch represented in green for the A season and in orange for the B season. And so, you know, over the entire time period from at least 1991 to 2023, you can see that for the most part, the A season bycatch is much, much smaller. It's typically less than 1% of the overall bycatch. But that in the B season, it fluctuates from really low values to some extreme values, like in 2005 when it was just over 700,000. On average, across 1991 to 2023, it was just under 186,000. But in recent years, over the last 3 years, there's been a drastic reduction in the overall bycatch. And so in this year, it was about 32,000 chum salmon caught. So where the bycatch occurs can influence which of the genetic groups that we see in the bycatch. And to visualize kind of the spatial distribution of the B season bycatch, we plot the total number of chum salmon by the ADFNG groundfish statistical area, seen here on the right in the map of the Eastern Bering Sea. So each of these small squares is an ADFNG statistical area, and within that square is a circle with its diameter scaled to the total bycatch amount. And so large circles depict large amounts of bycatch. The largest amount of bycatch came from statistical area 645501 with about 4,000 chum salmon caught. There are additionally 2 other statistical areas that have very similar levels of bycatch within clusters 1 and 2. We often aggregate these ADFNG statistical areas into 4 genetic clusters that we've discussed quite a bit here today. And so I provided the breakdown of the total bycatch by each of these clusters in 2024. And you can see that in cluster 1, it's about 61%. It's about 72% in clusters 1 and 2 combined, with relatively little or a low proportion of the overall bycatch in clusters 3 and 4. And so one thing this doesn't account for is the very different amounts of pollock fishing that occurs within each of these clusters because of those differences in the dynamics between each sector. And so one thing we do to kind of normalize the amount of bycatch by fishing effort is to plot the overall bycatch rate, or the total number of chum per metric ton of pollock that comes out of these ADFNG statistical areas. And so here we have plotted the same map with each circle now representing the chum per metric ton of pollock. And so the largest rate this year was 0.28 chum per metric ton. And still, the largest the highest bycatch rates were still within clusters 1 and 2, and those averaged about 2 to 4 times higher than in cluster areas 3 and 4. And so the bycatch can originate from populations from pretty much across the northern Pacific Rim. And so we use a genetic baseline with representation from throughout chum salmon's natural range. And so these subplots to the right represent baseline populations that are grouped into 6 different genetic reporting groups based on their genetic similarities. And so with these 6 different groups, we can estimate their contribution to the overall bycatch. And I'll quickly run through these groups and trying to highlight some of the important points. So in the upper left-hand plot, we have both the Southeast Asia reporting group in red, which is, I would say, 99 to 100% hatchery origin Japanese chum salmon. In orange is the Northeast Asia reporting group, which is composed of both wild and hatchery origin Russian chum salmon. In the upper right plot, plotted in yellow, is our Western Alaska reporting group, which extends from Kotzebue Sound in the north all the way down to the Nushagak in the south. And these are summer-run Western Alaska fish. Additionally, there are the light blue collections in the upper middle Yukon, and these are predominantly fall-run chum salmon within the upper drainage. In the bottom left is the Southwest Alaska reporting group, which is mostly the North Alaska Peninsula and Kodiak Island. And then in E, or the bottom right, in darker blue is the Eastern Gulf of Alaska Pacific Northwest collection, which is everything pretty much east of Kodiak Island. And there are both wild as well as hatchery-produced chum within this reporting group. And so here are the overall results for 2024. In this table, we have the genetic groups on the far left, and then going through the columns are the estimated number of fish from that genetic group, the credible interval around that number, which integrates some of the uncertainty that we have in these analyses, the mean estimate or the proportion of the total bycatch, and then the uncertainty around that mean estimate. And so going through this kind of quickly, we can see that Northeast Asia made up the majority of the bycatch at about 32%. And both of the Asia reporting groups make up just over 50% of the bycatch, which if you combine them together, that equates to about 18,000 chum salmon. Western Alaska was the largest Alaska reporting group at about 8.3%, which equated to about 2,700 fish. The upper middle Yukon was about half of that at 4.8%, or 1,500 fish. And then that Southwest Alaska group was the lowest genetic group represented at about 2% or 600 fish. So how do these proportions and numbers compare to the long-term historic trends that we've seen from 2011 on? We can just plot the stock proportions through time. So that's seen here in these two plots. On the left, we have the Eastern Gulf of Alaska Pacific Northwest and both Asia reporting groups. And on the right are the Alaska reporting groups. And so just briefly going through this, what we see is that in the left-hand side, the Eastern Gulf of Alaska, Pacific Northwest, and the Northeast Asia reporting groups typically are the largest contributors to the bycatch, and they fluctuate anywhere from 20 to just under 60%. And those two different groups are inversely correlated with one another. And so as one goes down, the other goes up. But typically, these are the largest contributors to the bycatch. The Southeast Asia reporting group in red, it averages about 18% through the time series. If we look at the right-hand side at those Alaska groups, you can see that for the Western Alaska group in yellow, from 2011 till about 2019, it averaged about 18%. But then in 2020 and 2021, it dropped to about 10%. But then again, it rose to just over 20% in 2022, but has since decreased to about 8% in both 2023 and 2024. The upper middle Yukon group, it starts at about 10% early on in the time period, but drops to its lowest levels in about 2019, but over the last 3 years has increased to what we see now at about 4.8%. The Southwest Alaska reporting group has always been a very low contributor to the bycatch, and we don't see really strong trends through time. So if we multiply those stock composition estimates by the total bycatch each year, we arrive at an estimated number of chum salmon by reporting group. And so what we see here is that in the left-hand column, the largest number of a single stock caught as bycatch was just over 300,000 Northeast Asia chum salmon in 2021. That's that peak we see to the right in orange. And so if we look at that Western Alaska group, over the entire time period, it's averaged about 36,000, but goes from a low of about 3,000 fish to a high of 65,000 fish. And you can see that over those last 2 years, it's reduced substantially. So like I said, where the bycatch is encountered can definitely dictate what reporting groups we see in the bycatch. And the differences among the sectors and their ability to disperse within the fishing grounds can dictate some of the genetic groups that we see. And those operational limitations are kind of inherent to each of the different fishing sectors. So in the map here on the left, we have the average bycatch encounter location plotted for the shoreside, mothership, and catcher processor sectors. And so just looking at this graph, you can see that the shoreside sector's average location of encounter of bycatch is much further east than both the mothership and the CP sectors. And the CP is shifted much farther northwest relative to both the mothership and shoreside sectors. If we look at the stock proportions plotted in the upper right, we can see that both the mothership and shoreside sectors caught relatively similar proportions of each genetic group. And for the Western Alaska group, it was substantially higher than the catcher processor sector. Again, if we take these stock proportions and multiply them by the sector-specific bycatch, we can estimate the number of chum salmon for each sector, for each of these reporting groups. And just kind of highlighting the trend in Western Alaska, despite the fact that the mothership sector and the shoreside sector had very similar stock proportions, because the magnitude of their bycatch is so different, the shoreside sector accounts for a much higher proportion of the Western Alaska fish that were encountered as bycatch. And so because of these fleet dynamics, there's been a lot of interest in kind of real-time genetic analyses, particularly for this shoreside sector, because they account for a much larger amount of bycatch, and typically they encounter a much higher proportion of Western Alaska fish. So this year we collaborated with the Bristol Bay Science Research Institute on an in-season project estimating the weekly stock comp for the shoreside sector. So this is specific to the shoreside sector. And so here on the right is just the density of the species and bycatch for all reporting groups for the shoreside sector, so that you can get an idea of the spatial extent of the fishery, of the sector's chum salmon bycatch. And so, we can see that most of their bycatch is encountered really close to that Alaska peninsula. And on the left, we have the stock proportion of each of those genetic groups going from statistical week 24 to statistical week really 40, but that last 3 weeks is an aggregate estimate because the bycatch was so small. I think after overcoming some major logistical and methodological hurdles, this project has demonstrated that they can produce accurate stock comps at a lag of about 4 days. If you look at kind of the variation across the statistical weeks, you can see that there are some certain patterns specifically to the Southeast Asia and Northeast Asia reporting groups. For the most part, in yellow, that Western Alaska component, it's a lower proportion of the overall bycatch, and there's pretty marginal changes within this year. But they were able to, pull off a very difficult feat in doing this. And I know that there's a lot of interest in extending this project into the future. Jordan Head, the executive director of BDSRI, will be providing public testimony. And so I think a lot of the logistical questions can probably be directed at him. And I'm more than happy to talk about more of the analytical considerations going into providing these stock comps at a weekly basis. So just a quick summary of the 2024 chum salmon bycatch. Overall, it was a much lower number of chum salmon that were encountered relative to kind of the historic trends we've seen. And that's like the third year in a row where chum salmon bycatch has been reduced. Overall, it was a lower proportion of Western Alaska chum salmon. If you combine both our Western Alaska and Upper Middle Yukon reporting groups, it accounts for about 13% of the overall bycatch, which equates to about 4,200 fish. Additionally, we see pretty consistent trends of a greater proportion of Western Alaska fish in the easternmost fishing grounds. And because of that and the dynamics within each of those sectors, the shoreside fleet has the highest proportion and overall number of Western Alaska chum salmon in their bycatch. So just a quick acknowledgement to a lot of the collaborators. A lot of the work that the fishery observers do, FMA and ACFIN, all of their contributions kind of facilitate the rapid turnaround of these. We're producing these estimates now at a lag of 4 months now, and a lot of that has to do with efficiencies that have been made in the observer program and kind of the analytical considerations that ACFIN has helped with. So I'm more than happy to take questions now. If anybody does have questions that can't ask me questions about the chum salmon bycatch, I've listed my email address here as well, and the link to all of our prior tech memos. So within the NOAA website, we provide all of the prior year's tech memos so that people can see what has been done in the past.
Thank you very much for your report, Dr. Berry. Are there questions? Okay. Yes, Mr. Williams.
Thank you, Madam Chair, and thank you, Dr. Berry, for your report. Did I hear you correct that you had a lag time of about 4 days on the identification of the genetic information on these fish? Was that the right time frame?
Through the chair, thanks for the question. So for the in-season project that was done in collaboration with BBSRI, for the shoreside sector, yeah, I think we're able to produce those individual statistical week estimates at a lag of about 4 days. So from kind of the last delivery that we're going to analyze from the week, they can extract DNA, produce genotypes, send those genotypes to our lab for us to do the analytical estimation, and then we produce a written report and send it back to them. And that we believe that 4 days is about where we're at right now in the entire process.
Thank you.
Ms. Vanderhoven.
Thank you, Madam Chair. Thank you, Dr. Berry. I just want to clarify what I think I heard. That was 4 days from the end of the reporting week, not 4 days from when a chum ends up in a pollock net, right? Just thinking about, the time it takes to fill the boat and offload the boat, and if it's the beginning of the reporting week or the end of the reporting week. So there's a spread there, not 4 days for each fish.
Through the chair, thank you for the question. I'm sure that a lot of these questions can probably be directed to the executive director of BBSRI. I think, you are correct in saying that from the time a chum salmon is caught to when these are produced, that's not 4 days. Obviously, the shoreside vessels go out for a number of days and often will do multiple different tows within a shoreside delivery that is then sorted by the observer program, and then after that is sampled by BBSRI's port samplers. So there is, that extra time, but they have the ability to, I think BBSRI has the ability to, increase their sampling rate, and if they wanted to produce estimates not on this statistical week schedule, but on a shorter time frame, they could do that provided that they sampled at a rate high enough to meet our minimum sample size requirements.
Thank you.
Thank you. Any additional questions? Okay. So that concludes our presentations on C2. So we will move into public testimony. I do, again, intend to end the day around 5 o'clock today. So I don't think we'll get through many people. And the sign up for public testimony will also close at 5 p.m. today. I've heard the AP will start deliberating on a motion in the morning. And I will announce when that motion is posted. It'll take a little bit longer for the rationale to be posted and the AP to finish its minutes. And I'll announce when they're ready to give the report to the council. So far, it looks like we have almost 160 people signed up for testimony. So I'll ask for the public's assistance in helping with time management so that we're able to hear from everyone. Individuals and companies will have 3 minutes, organizations and associations 6 minutes. If there are multiple people representing an organization, it is our policy to allow one representative 6 minutes from that organization, and other individuals will have 3 minutes. So please coordinate amongst yourselves. We have a timer on the screen in front of you and behind me that will have little visual cues for when you're for a countdown, and there'll also be a little ding at the end of your time. And I will also ask you for a concluding statement if you go over. To the extent we can may be able to allow some additional time for distinguished elders as was done in the AP. But it is very challenging to interrupt people. So I'm just hoping that we can all work together to ensure that, again, we can have a good interaction back and forth between testifiers and in the public, as well as hear from everyone before we need to end our meeting on Tuesday. So I may have to make some time adjustments throughout the next couple of days if it does look like we won't get to people, as well as limit the questions from the council members, which I also do not want to do. So I've also been getting numerous requests for testifying on time certain or to accommodate travel. And to the extent we can, we will accommodate that. But I would ask that members of the public just use those requests sparingly and only when needed to be fair to everyone else who has signed up. So thank you. And I'll repeat those announcements in the morning. So we will begin testimony with Philip Powell, followed by Steve Martell and Merrill Rudd. And I think then we'll have to go with Chief Ridley and Jordan Head after that. I'm guessing about 4 people. Thank you. Philip, are you ready, or would you? Okay, well, how about we go to okay. Is this actually, Phil, we're going to have to, sorry about this. I'm not sure we've done this before. So can I have Steve Martell and Merrill Rudd come up first, and then I need to consult with staff to see whether or not this scenario is within our policy, and or whether or not we'll have your captain call directly in and testify separately. Thank you. Okay. Thank you.
Sorry, thank you guys. For the record, my name is Meryl Rudd, and this is Steve Martell. We represent Sea State, which facilitates salmon avoidance programs described in the IPAs. So we just want to say that Asian hatchery chum salmon are unavoidable throughout the Bering Sea. On the right here, I want to focus on the right. There's this map that's an example of a map that Sea State would use to target rolling hotspot closures in areas with the highest proportions of Western Alaskan chum, which are shown in white. And Asian hatchery chum are still the majority in most of these areas, which are shown in red. And each year of fishing represents a different story behind the fishing dynamics that are occurring. So with each year of genetics, we update our understanding of the distribution of Western Alaskan chum based on where fishing occurred that year. So we're always learning and always improving. And we're very optimistic to use the VBSRI in-season genetic information to inform fleet movement to improve avoidance of Western Alaskan chum. And a hard cap would incentivize the fleet to fish in areas with the lowest total chum bycatch rate, which are not necessarily where Western Alaskan rates are lowest. And an example of this is clear when looking at the difference between the 2021 and 2022 fishing seasons. So too many chum were taken as bycatch in 2021 on the shelf edge in cluster 2 due to complications related to storms. And in 2022, the goal was to cut total chum bycatch in half, and that moved the fleet onto the shelf and into cluster 1 with higher Western Alaskan chum rates. And they were successful at cutting total chum bycatch in half, but caught the same number of Western Alaskan chum. And so we're afraid this is what would happen with a hard cap.
Through the chair, my name is Steve Martell. Again, the IPA agreements that the sectors have set up do two things. One, they force a mandatory communication structure between all of the vessels on the grounds about what's going on. And second, and perhaps most importantly, they allow us to rapidly adapt to changing conditions and deal with anomalies. And I have a herring example I can speak to if you're interested. With regards to our rolling hotspot program, the key to this program is having a large number of vessels on the grounds and having an effective sample size to do the appropriate statistical calculations to identify areas of high chum bycatch rates. What happens is when you have a hard cap in place, we then allocate this hard cap down to the individual vessel. Now, even with a cap of 350,000, we have roughly 20 vessels here that will receive less than 100 chum salmon as part of their allocation. In fact, most of these vessels would be shut down in one single tow because the chum salmon bycatch rates are usually a lot of zeros and then a few hundreds here and there because chum salmon school up in much larger schools, unlike Chinook salmon. Losing this capacity would most definitely extend the bee season and allow us fish longer into October when Chinook salmon rates are high. Managing under these caps is unfair for smaller vessels. The small vessels will pay the price first, whereas the larger vessels will get to continue fishing later on in the season. The reason we use rates in our management system is it's equitable across all vessel sizes and all allocations. And I will leave my comments there. I think we've used our 3 minutes. Thank you.
Thank you for your testimony. I'll see if there are any questions. Yes, Mr. Toyam.
Thanks, Ms. Rudd, Dr. Martell. The first slide about Asian hatchery chum, and it said that we're essentially seeing increasing levels. Is that increasing across all the nations, or are there specific areas where chum is being increased, or specific nations where?
Through the chair, thank you for the question. We do have a slide here. The figure on the left, the top left-hand panel showing the line increasing there. What this represents is the difference or the changes in hatchery production by nations. On the left-hand side are the Asian countries, and on the right-hand side are the North American countries. What we've seen since 1994 is there's been roughly a 550% increase in hatchery production in Russia. If you go through the Russian newspapers this past summer, they have plans to double their hatchery production and their processing capacity for salmonid species in Russia. Again, if you go through the literature in Russia, they've done a tremendous number of experiments to try and learn how hatchery production can be enhanced in Russia. So they've used barcoding programs and experiments to figure out where. The results of those experiments led to an additional doubling of hatchery capacity post-2010 associated with the Shumagan Islands and other areas that we've recently seen huge expansions. We don't see other countries doing that same expansion. In fact, since the Fukushima accident in 2011 in Japan, Japan's production has decreased almost by 50% from what they used to produce with regards to chum salmon only. I can't speak to pink salmon as well. I don't know that data.
Second question.
Thanks. Totally different subject. You mentioned that the BBSRI work looked promising, and one of the questions I was wondering about was the timing issue that you heard a couple questions about in Dr. Berry's presentation. And I was wondering what your sense, since you would probably be key to helping implement this, what your sense is of how that timing would work out. And are there points in the season when 4 days is perfectly fine? Are there points in the season when 4 days just isn't enough and you need quicker? How does that sort of look just from the application point as you go through the season?
Through the chair, may I seek clarification? Are you referring to the 4 days of delay it takes to process the samples?
Correct.
Thank you. Through the chair. This is really exciting research that's going on, and we are quite excited at C-State to start incorporating this information. We've, since 2022, have been working very closely with Patrick Berry, getting into his genetics data. Patrick has been, deserves an award, has been amazing at being able to accommodate our requests. So the first request we asked him was to actually produce these genetic estimates at the ADFMC statistical area. And then he did that. We also asked him to do it by fishing grounds. He did that. So we're really excited, and we know that we can continue to work with Patrick and this BBSRI program as well. We're excited in the first couple of years in this project to actually learn how we can use this finer resolution spatial information. We were just talking to Abby, actually, not 5 minutes before the public testimony started, to design plans and experiments how we would look at how different parts of the fleet are moving to different areas so we can selectively learn to use the genetic more in a scientific manner rather than a fisheries dependent data where we're not really learning much about chum salmon stock rapidly.
To the chair, may I add something? Those are all exciting research opportunities and ways that we could use this in a very applied manner. But I think even at the most basic level, just having any information on the last week or 2 weeks to see where they had fished, even if you don't break down the spatial scale at all, but just have like what the genetics have said over the past 2 weeks or few weeks would be better than what we have now. So any information is better.
I have more.
Thank you. Ms. Kimball.
Thank you. Thank you for your testimony. And I hope this is within the bounds on your slide 2. You know, that's helpful picture of where Asian hatchery is and where Western Alaska chum is primarily. And there's been a lot of talk about the success of the rolling hotspot program that you run and ways to avoid chum. And I'm wondering if you see opportunity for that to work in conjunction with potentially alternative 5. And I bring that up because that's the area where we're targeting the most Western Alaska chum bycatch. If there's a hindrance to the rolling hotspot program with that, or if that's a possibility for those two things to work together.
Through the chair, Ms. Kimball, thank you very much for the question. I do see that, my apologies, I just had a brain malfunction. Can you repeat the question?
Just whether you think alternative 4, which is essentially the program you run now, could work with alternative 5, or whether alternative 5 is a hindrance to alternative 4. And I bring it up primarily based on our SSC report to make sure that we understand how those two would work together.
Through the chair, thank you for the question. Yeah, I do see that the alternative 5 and enhanced genetic programs and everything else like that can be workable. The part that won't be workable is if the cap is sufficiently low that vessels start stacking quota and then the data becomes sparse. And then I can no longer get high resolution genetics data and stuff like that to continue the program to work. So really it's what's key is to make sure that every vessel on the fishing ground has an equal opportunity to access the fish at any point in the year. If an individual vessel is shut down early for whatever reasons, then it's not going to work.
Thank you.
Yes, Mr. Curlin.
Thank you. Mr. Martell, you spoke to the operational challenges of a hard cap and the potential for disproportionate impacts on smaller vessels. And I wonder if you could just clarify for the council and for the public, why is it that the amount apportioned to different vessels couldn't just be distributed differently to alleviate that consequence?
That's an excellent question. In fact, we have a hard cap for herring, and we don't apportion herring down to the individual vessels. It's basically dealt at the sector level. The reason it's different is the consequences are uncertain, as if we were to exceed a chum salmon cap, what those consequences would be. And it's really the consequences that determine the behavior. If an individual fisherman is going to be shut down for the season, they're going to behave very differently than if they have to relocate or move elsewhere or operate in a different fishery altogether. So it really depends on what the consequences of triggering the cap or exceeding the cap that dictates how their behavior is going to change.
Yes, Mr. Ritchie.
Thank you. Thank you for your testimony. Just looking at slide 4, kind of lends to how for your program to be most effective, it is kind of data hungry, which makes sense. And I'm looking at alternative 4 and the 6th provision there. It says it would require pollock sector IPAs to prohibit fishing in bycatch avoidance areas for all vessels. It's all vessels, regardless of performance, when ADFG weekly stat area bycatch rates exceed 5 chum per ton of pollock for the CP IPA and 3 times base rate for the inshore SSIP and MSSSIP. This is similar to what is in effect, except this would be regulatory, and it does include all vessels. I'm wondering if you, from your point of view, would this jeopardize the information that your program needs to work effectively, or is a weekly closure of an area to all vessels, is that still flexible enough for the program to work, or is this overly prescriptive?
Through the chair, Mr. Ritchie, thank you for the question. I don't think the action is overly prescriptive. I think what the provision is trying to prevent is what we saw in 2021, where we can get these runaway chum salmon rates that are going on in an area. And so in addition to that provision, we've also added twice weekly reporting. Again, what happened back in 2021 is we had once weekly reporting. So We saw the problem happening, but we had to wait another 5 days before the actual reporting announcements went out and stuff like that. So does that answer your question, sir? Thank you.
Thank you both for your testimony. So next up is Philip Powell, and followed by Chief Ridley, and Jordan Henn will be our last testifier of the evening. Thank you for your patience.
Madam Chairwoman and members of the North Pacific Fishery Management Council, thank you for the opportunity to speak today. As General Counsel of Global Seas, thank you. I represent a family-owned inshore catcher vessel company that is deeply committed to sustainable fishing practices. Today, I wish to address the preliminary draft environmental impact statement on managing chum salmon bycatch in the Bering Sea pollock fishery. Our industry faces significant challenges with the proposed management alternatives, particularly the speculative nature of any positive impacts on salmon stocks and then the accompanying threat to economic viability of inshore operations like ours that these alternatives present. The no-action alternative, while avoiding operational disruptions, does not address the issues associated with bycatch or Western Alaskan chum salmon returns, crucial for upriver subsistence users. Conversely, hard caps and corridor closures, while well-intentioned, fail to consider the dynamic ecological interactions that could lead to severe economic repercussions for small family-run businesses like ours and the communities they support. Instead, I advocate for enhancing the incentive plan agreements, or IPAs. These agreements have proven effective, achieving a 94% reduction in chum and salmon bycatch from 2021 to 2024. By integrating real-time genetic stock identification and expanding vessel outlier protocols, IPAs can be fine-tuned to further reduce bycatch without harming the economic fabric of our industry and the communities and companies in Alaska that depend on it. One approach could be regulatory requirement for participants to join IPAs. The Alaska pollock fishery is not just a commercial venture. It represents a critical economic artery, supporting over 30,000 jobs and providing essential infrastructure for other fisheries. Without it, it's unclear whether Alaska could even maintain a viable inshore infrastructure for other fisheries. It's imperative that our management strategies reflect the best available science and prioritize sustainability both ecologically and economically. To the members of this council, I urge you to consider the broader impact of your decision. Let's prioritize innovation, adaptive solutions that safeguard our marine resources, and also support our communities and economy at large. Enhanced IPAs represent a balanced, effective approach to achieve these goals. The other alternatives, in my opinion, only threaten a second crisis by negatively impacting the whole Alaskan fishing industry without providing any clear or long-term benefit for Western Alaskan chum salmon returns. It was my intention for our skipper to join us remotely. He couldn't be here in person, obviously, and he couldn't. So with that, I'll read his statement if that's okay. He was good enough to write it down for me, and I'd like to read it for him. My name is Dave Helmerson. I've proudly captained a catcher boat for over 40 years in the Alaskan pollock fishery. This fishery hasn't just been my job, it's been my life, allowing me to raise a family and contribute meaningfully to my community. In recent years, our commitment to sustainable fishing has shown tangible results. For example, in 2022, I harvested 12.3 million pounds of pollock with a bycatch of 879 chum salmon, which when adjusted for the predominance of hatchery fish, indicates a minimal impact on Western Alaskan's chum salmon. By 2024, my crew and I reduced our incidental catch. May I finish? It's 2 paragraphs.
Do you have a concluding statement? Yeah.
I apologize. Well, the gist of Dave's statement is that we work tirelessly on bycatch avoidance methods. Our progress is shown in the numbers that we've caught. And Dave wanted to give a personal face to who the pollock fishery is and the economic driver that it is. And it's important in thinking about management decisions that we think about larger context and the big pictures and how we can benefit everybody, providing the greatest good for the greatest number of people without causing negative unintended consequences.
Thank you for your testimony.
Thank you.
Let's see if there are any questions. Yes, Ms. Kimball.
I just had a quick question. Thank you for your testimony. You mentioned being in the smaller vessel category. Can you remind me or tell me how large your vessel is?
We have a couple, and I don't think none of them are larger than 170 feet.
Thank you.
Thank you for your testimony.
Again, I apologize.
So, Chief Brian Ridley, followed by Jordan Head.
Thank you. My name is Brian Ridley, and I'm the Chief Chairman of the Tanana Chiefs Conference, representing 42 tribal communities in interior Alaska. No meaningful action has been taken by you to confront this crisis. In December of 2022, I was excited you were taking up the chum bycatch cap issue, and yet no meaningful action has been taken to date. This council has decided that the billion-dollar pollock industry is the only group that you choose to support and protect. In fact, this council allows an inflated TAC year after year, knowing that the market doesn't support it. The last 2 to 3 years, I believe, the industry received 50 to 80 million per year in bailout money from the federal government. Our government buys your fish that the market doesn't want. I wonder what Doge would think of this. The salmon crisis is a human rights injustice, and we will not stop fighting until real change happens. We're facing a salmon crisis, yet you continue to allow tons of bycatch without acknowledging its cumulative impact from decades of trawling. The prioritization of the pollock industry over our tribes and tribal members is a glaring example of environmental injustice. While billion-dollar trawl companies profit from our waters, Indigenous families along the Yukon and Kuskokwim rivers are being stripped of their cultural lifeways, food security, and economic stability. State and federal regulations continue to prioritize non-Alaska Native economic interests such as trawling and industrial development over the subsistence rights of Alaska Native communities, perpetuating a cycle of marginalization and environmental injustice. The 2024 Yukon Fall Chum Run was the third lowest on record. Between 2010 and 2014, the average chum salmon taken for subsistence was 84,000 fish, and in 2024, it was 3,600. Our subsistence needs are being blatantly ignored. Salmon once accounted for up to 52% of our total subsistence harvest, and now it's nearly zero. Our economic impact of losing chum salmon is catastrophic. It's an economic injustice that we now spend nearly $2 million a year buying salmon from commercial fleets. We're forced to subsidize our own cultural destruction. This is not conservation, it's forced assimilation, where our Indigenous communities pay the price for your industrial greed. In our region, rates of diabetes have increased by 25%, obesity has risen by 70%, and malnutrition has climbed by 50%. This is a direct result of food insecurity and the loss of nutrient-rich salmon, with tribal members forced to rely on processed, high-carb, and high-sodium foods. The profits of pollock industry that you protect are literally being paid with the lives of our Native people. TCC co-authored sections of the DEIS to provide an ecosystem-wide status of chum salmon stocks in the Kuskokwim and Yukon River systems, as well as the social, economic, environmental, and health impacts that declines in chum salmon populations and harvest restrictions have imposed on our tribes. Despite our contributions, the DEIS prioritizes economic impacts on commercial fishing and fails to meaningfully evaluate the consequences for harvesting communities along the rivers. The DEIS also fails to recognize traditional knowledge as a best available science pursuant to National Standard 2, treating it as a supplementary rather than fully integrating it into the analysis. TCC requests that the Council adopt a holistic ecosystem-based management approach that prioritizes conservation while maintaining accountability for the Bering Sea pollock trawl. TCC supports Alternative 5 in its entirety, with all three options implemented, coupled with a PSC cap of 100,000. The 200,000 cap in the DEIS is insufficient to effectively alter the pollock fleet's fishing behavior. Since 1992, the pollock fleet has operated below 100,000 fish in 14 separate years. These years demonstrate that lower bycatch levels are feasible and do not prevent the pollock industry from maintaining harvests. 100,000 cap is not an arbitrary restriction. It aligns with the historical trends where bycatch was naturally low and the industry profited. The DEIS cannot continue to favor commercial interests without considering escapement or the impact of subsistence harvest opportunities. Conservation continues to be shouldered solely by our tribes. We are willing to sacrifice our fish if it means our future generations can fish. We teach our people only take what you need. Unlike the waste and disrespect shown by your bycatch. Our salmon are not only species suffering under your management. The northern fur seal, snow crab, halibut, herring, and all of the people that eat and live off of those species are being overlooked for the health of the one industry. Our tribes want action now. Our salmon cannot recover if they cannot reach the spawning grounds. There's an urgent need to err on the side of conservation during severely depressed escapements, just as you did 25 years ago. If left unaddressed, our people are facing a health and wellness emergency that threatens our way of life, and salmon will be an endangered species. Thank you. Masicho.
Thank you for your testimony. See if there are any questions. Yes, Ms. Gahn.
Through the chair, thank you, Mr. Ridley, for your testimony. I just want to make sure I had it clear. I heard you say you support alternative 5 with all the corridors and then a cap, but I missed the cap that you said.
A cap of 100,000.
100,000. And then second question, if I may, you mentioned ecosystem-based management and the need for more ecosystem-based management. Do you have an example of how you think this analysis could be improved to have more of that ecosystem-based management lens?
Boy, I'd have to lean on some of the staff at TCC. There's fish staff on my staff that have a lot more knowledge of those things than myself.
We can hold that question for a future testifier. Thank you. Any other questions? Thank you again for your testimony.
If I may, real quick, from the earlier one, 25% of our tribes are on the road and 75% are off the road system.
Thank you. So, Jordan Head, last testifier.
Thank you, Madam Chair. My name is Jordan Head. I'm the Executive Director of the Bristol Bay Science and Research Institute, or BBSRI. I'm here to speak to you about a feasibility project that BBSRI undertook in collaboration with NOAA's Auk Bay Genetics Lab in 2024 to produce in-season estimates of the stock of origin of chum salmon caught in the shoreside sector of the Bering Sea pollock fishery. BBSRI is a 501c3 nonprofit research institute and subsidiary of the Bristol Bay Economic Development Corporation, one of the 6 CDQ groups. As an organization, we've spent the last 25 years doing challenging fisheries research, assessment, and policy analysis, most of which have been in support of data-driven, real-time fisheries management in the Bristol Bay region. For example, the Port Muller test fishery in our at-sea genetics lab provides managers and industry with real-time genetics and run strength information on sockeye salmon returning to Bristol Bay from one of our research vessels. We had 2 main goals when we undertook this project. First was to provide more timely information on the stock composition of chum bycatch than is currently available, and second was to develop a tool for the shoreside fleet that aids in the avoidance of Western Alaska chum salmon bycatch. We sought to accomplish this by producing weekly stock composition estimates of all chum salmon bycatch that was taken in the shoreside sector of the pollock fishery. There were 2 main components of this project. First, port sampling. Port sampling had to take place at a much higher rate than is currently done in the fishery so that we can meet weekly sample size targets and produce accurate stock composition estimates. We accomplished this by varying our sampling rate from sampling every single fish in low bycatch weeks to 1 in 10 fish in higher bycatch weeks. For context, NOAA samples at a rate of 1 in 30. The second aspect was the genetic analysis. This had to be done quickly and accurately. We accomplished this by building a state-of-the-art genetics lab in Dutch Harbor next to where the fish are being landed. I won't go into details on the methods for the sake of time, but know that they were meticulously designed in collaboration with the Alaska Department of Fish and Game, NOAA, and BBSRI for the purposes of ensuring that results produced from this project were accurate. Overall, we were able to sample 91% of all shoreside deliveries in 2024 in the Dutch Harbor and Akutan, and we will have no issues bringing this up to 100% of deliveries in 2025. In total, we sampled just over 7,000 chum salmon, which is 32% of all chum salmon landed in the shoreside sector in 2024. Of these 7,000 samples, only 3,000 of them were needed to produce the 15 weekly stock composition estimates that we made in 2024, going from stat week 24 through 40. These two graphs illustrate the 15 weekly stock composition estimates. The figure on the left shows the proportion of weekly bycatch attributed to the 7 stock reporting groups over the course of the season. And the figure on the right displays the actual number of chum salmon caught in each week and what stock reporting group they belong to. However, I believe these graphs are very busy, and I think we can get an idea of the value of the project when we look at the stocks individually and compare them to the postseason analysis. Here we have the 7 stock reporting groups and NOAA's postseason estimate of the proportion of bycatch they made up in 2024, represented by the horizontal line. For example, looking at the figure on the top left, we can see that coastal Western Alaska chum made up 9.6% of bycatch in the shoreside sector in 2024. When we overlay the results of the in-season project, we can see we have much more definition of how the proportion of fish being caught changes over the course of the season. We've done extensive QA/QC and have had the results of our lab independently verified by both NOAA and the Alaska Department of Fish and Game. NOAA has also done an analysis comparing the postseason results with our in-season results, and we're happy to report that they do collaborate each other, solidifying the accuracy of both in-season and postseason estimates. In conclusion, we have been able to show that doing an in-season genetics project within the shoreside sector of the pollock fishery is completely doable. And even if we don't evolve this project at all, we know that it can provide meaningful information about the current season's bycatch and if it's made up of high or low proportions of Western Alaska chum salmon, which in turn can inform the fleet on whether large-scale efforts should be made to avoid them. We also know that this project at its current level can track the total number of Western Alaska chum salmon being caught during the season, which is a valuable tool to understanding the impacts of the fishery while it's actually being executed rather than after the fact. However, we believe the real question we should focus on going forward is how we can use the success of this feasibility project to take the next step in meaningful, in-season, data-driven decision-making on the avoidance of Western Alaska chum salmon. This project was only successful because everyone came together to make it happen. It was a true collaborative effort between BBSRI, NOAA, ADF&G, industry, and stakeholders. And we believe that continued collaboration is how we can work towards addressing the complex issues surrounding bycatch. We at BBSRI are committed to continuing these collaborative efforts.
Thank you very much for your presentation and testimony. Yes, Ms. Vanderhoven.
Thank you, Madam Chair. Thank you, Mr. Head. My understanding is this work is at this point specific to the shoreside catcher vessel fleet, and you cannot extrapolate to the other 3 sectors, to the CP, the mothership, or CDQ sectors. Is that correct?
Through the chair, yes, at this point, that's correct. Although any CDQ that's being fished in the shoreside sector would be available in this study. So yes, right now this is for the shoreside sector only.
Thank you. And can you provide any information about the status of funding for this work to go forward? I think you were operating under a grant this year, and I'll leave the question there.
Yeah, so this, through the chair, Ms. Vanderhoven. This project was funded through a State of Alaska direct legislative grant. And we've had, at this point, we as BBSRI are not concerned about finding funding for this project going forward. We still have funding for the project going into this year. And there's been a lot of interest throughout all sectors of industry and CDQ to continue funding this long term. We also have the Alaska delegation looking at funding this through the federal CDS process right now.
Yes, Mr. Toy and then Mr. Sakata.
Thanks, Madam Chair. Thank you, Mr. Head. This is really exciting, and it's nice to get the snapshot back so quickly of what worked. You were working mostly out of Dutch Harbor, right? Or entirely out of Dutch Harbor? And the reason I'm asking that is because really my real question is, can you make this work out of other ports, or does it really require a port kind of the size and accessibility as Dutch Harbor? In other words, how replicable is this to other areas?
Yeah, thank you. Good question. Through the chair. We have the same facility on a research vessel in just outside of Bristol Bay that we operate, the Port Muller test fishery. And we have the lab and a Connex on one of those research vessels, and we produce estimates every other day within 12 hours over the course of the entire Bristol Bay fishing season. So it can be done on, like we can do it in many places. It doesn't require a lot of space and it doesn't require a lot to do. As far as, yes, we were in Dutch Harbor, but we were sampling in both Dutch Harbor. We sampled all plants that were accepting shoreside deliveries in 2024 and would continue to do so. So Dutch Harbor and Akutan.
And Mr. Sakata.
Yes, and thank you for the presentation through the chair. The current DEIS that we're looking at kind of, I don't want to say assumes that it references historic genetics versus anything current. In fact, in the first read, I think at least my preferred alternative was the alternative that was capping Western Alaska chums, which was kind of dropped because it just couldn't be done. The information at the time said that it couldn't be done. This sounds more and more like it's getting closer, although as Ms. Vanderhoven pointed out that right now it's shoreside only. Do you see in the future being able to use this type of data to perhaps with some kind of buffer to account for the slight delay that we could place a hard cap or some type of cap on just specific Western Alaska chums?
Through the chair, yeah. I don't think I would speak to what particularly this should be used for. But what I can say is we can, through this project, we can track the number of Western Alaska fish being caught throughout the season in the shoreside sector. We've shown that we can, and it was essentially the same estimate that was provided through the postseason analysis. Those two estimates confirmed each other, so we know it's accurate. As far as going into other sectors, that would be a challenge, but and if we could do sampling in the catcher processor sector, I think that would be a challenge, mainly with how frequently they come to port. But I don't think anything's not doable. And the issue would be for the catcher processor sector is how do we sample those the fish in that sector, which would be a real challenge because we probably wouldn't be able to put our own port samplers onto a vessel, right? So there would be challenges associated with that.
Just a quick follow-up. My understanding was that if we provided space and the technology available, really the restriction or the bottleneck is the fact that, for example, the Northern Hawk, the boat I'm familiar with, had something on the order of 120, 130 chums all year. That's a bottleneck in the sense that you need more samples, correct?
Through the chair, yeah. For this project, we're not doing individual assignment of chum. We're not saying this particular chum belongs to this particular stock. You need a sample size. We did sample, 100 to 200 fish is kind of what the minimum of what you'd want to do with a mixture model. But if you're only categorizing the 100 fish, that changes your sample size. Your sample size is, if we were trying to say what 3,000 fish were, using a sample size of 100 or less, we wouldn't necessarily want to do that. But categorizing a couple hundred, we could run those on chips and probably do a mixture model. That question on sample sizes and stuff, NOAA did all of the analysis for this project. So Dr. Pat Berry did all of the actual analysis as far as generating the stock composition estimates, and he would probably be a better person to answer a question like that.
Yes, Ms. Kimball.
I had two, I think, simple questions. Thanks for the testimony. And one was a little bit related, is whether the project was able to then track like Western Alaska chum at the individual vessel level. Because knowing the sector level is one thing, but if we have caps, we know they're in practice at the individual vessel level. So is that something you're testing through this project, or is that not part of it?
Through the chair, Ms. Kimball. No, at this point, we're not doing individual assignment of chum, so we can't say this specific chum from this specific vessel was a Western Alaska or Asian chum. It's done through sample sizes over a larger area. So no, we wouldn't be able to go to the individual vessel level. We can get further definition of statistical areas because we're sampling at an extremely high rate and running through the genetics lab at an extremely high rate. So our ability to get more temporal time and spatial understanding of where chum are in the fishery would definitely go up, but not to the vessel level.
Thank you. I appreciate that. And that clarification. The second question was, I know this was a year to test it out, and relative to other years, it was a very low chum bycatch year. But did you also get a sense that if it had been a very high bycatch year, that the lab could accommodate an increased number of samples? Were you able to figure that out?
Yes, through the chair, Ms. Kimball. Yeah, that's a great question. So one of the objectives this year for a feasibility year was to see if the level of effort we put would be sufficient. And while it was sufficient in 2024, we know that it was a very low bycatch year. However, with much higher bycatch, you don't have to sample at as high of a rate, right? And so we believe, and we tested kind of through the year, if a crew of the size that we put out there would be able to keep up with a much higher bycatch level, and we do believe it can. It's also pretty rapidly scalable. If we needed to have more people in the field, we can do that pretty quickly, and the genetics lab itself can handle a lot more than what we were doing.
Thank you. And Mr. Ritchie.
Thank you, Madam Chair. Thank you for your testimony. I just have a simple question. It says you sampled about 7,000 of the 21,000 landed, and 3,000 tissue samples were genotyped. I'm just wondering what the selection process was for that 3,000 of the 7,000.
Yeah, through the chair, that's also a really good question. So each week, at the end of each week, so we did this on a weekly basis in 2024. There's nothing, just because it was a feasibility year, we decided we would do weekly stock composition estimates. There was nothing tying us to that time frame. We could do this much more rapidly if it was beneficial to industry. But at the end of each week, we would look at all the samples we had for the week, and then we would come up with, according to how much bycatch there was, what a sample size would be required to get genotype in order to come up with an accurate estimate. And so sometimes we sampled way more fish than were needed to provide for a robust and accurate estimate of that week. And so we didn't need to run all of the samples. So each week is taken of its own. We look at the bycatch, we come up with a sample size needed for stock composition estimates, and then we run only what is needed.
Thank you, Ms. Goen.
Thank you, Madam Chair, and thank you for the presentation. This is really exciting research that's coming online and how quickly that you can turn around this genetics data. Can you also turn around quickly, within a week, the locations of where those salmon are being caught, specifically for Western Alaska salmon?
Yes, through the chair. Thank you for the question. So in this season, since it was a feasibility year, we just wanted to demonstrate that this was possible. So the next logical steps are how can we make the information more beneficial to the people executing the fishery so that they can mitigate their impacts on Western Alaska chum. And so one of the ideas that has come up through conversations with industry is what would be beneficial is possibly, could you give us spatial information on a week, i.e. we have several vessels fishing over here in this area throughout the week, and we have several vessels fishing over here. Can we get an estimate for both areas? And yes, we can do that. And we plan to do that in 2025. And realistically, we can go even a little bit further, and let's say there's a lightning strike event and one vessel gets into a lot of chum, they can bring those in, and if they alert us to that, which we have communication going back and forth with them and plan to develop this a little bit further. If they have a lightning strike, they can bring it back to us. We can sample that and we can run it on the spot. So we can do things like that, all while still maintaining one of the main objective, which is to produce accurate weekly estimates. We'll still maintain that objective, but we have the adaptability to actually answer questions on the grounds in real time as to what's going on.
Thank you for that. That's tremendous. And so just to make sure I understood you clearly, if a vessel hits a lightning strike, you could then prioritize that sample above others to get it out really quickly.
Through the chair, yes, we could, if we were alerted to that lightning strike and we wanted, and industry wanted to look at it, we could provide that information pretty quickly to them.
Great. Thank you. Any other questions? Thank you for your testimony.
Thank you.
Appreciate it. So that concludes testimony for the day. Before we break, I'd just like to express our condolences and thoughts to all the family and friends and communities impacted by the Bering Air plane crash when it was en route to Nome last night. So many condolences. So we will reconvene tomorrow at 8 a.m. and begin public testimony with John Hendershey.